Hey everyone, my name is Vishwas and welcome to the most comprehensive Next.js tutorial course. Throughout this course, we will build from the ground up, exploring all key concepts in Next.js. We will be focusing on version 15 and above, depending on when you're watching. In this introduction, I'll cover what Next.js is, why it's worth learning, and what you need to know before getting started. So, what exactly is Next.js? Next.js is a React framework for building full-stack web applications. When building applications with React alone, it's not feasible to create a fully featured application ready for production. React is a library for building user interfaces responsible only for the view layer of an application. As a developer, you need to make decisions about other features such as routing, data fetching, and more. Next.js, on the other hand, is a React framework. It uses React for building user interfaces, but also provides additional features that enable you to build production-ready applications. These features include routing, optimized rendering, data fetching, bundling, compiling, and more. You don't have to install additional packages, as Next.js provides everything you need. However, keep in mind that Next.js, being a framework, has opinions and conventions that should be followed to implement these features. There is no need to worry though, as the conventions have emerged from a team with years of experience in writing React apps for production. So, to reiterate, Next.js is a React framework for building production-ready full-stack web applications. Now that we understand what Next.js is, let's see why it's worth learning. The reason to learn Next.js stems from the fact that it simplifies the process of building production-ready web applications. Let me list some of the key features that Next.js provides out of the box. First is routing. Traditional React applications require installing and configuring third-party routing packages every time you need to create a route. Next.js simplifies this with file-based routing. You just create files and the routes are automatically generated. Second is API routes, which sets Next.js apart as a full-stack framework. You can build both front-end React components and back-end APIs within the same Next.js application, allowing seamless integration between your front-end and back-end code. Third is rendering flexibility. Next.js supports both server-side and client-side rendering approaches. When implemented properly, this leads to improved performance and better search engine optimization. Fourth is streamlined data fetching. Next.js provides built-in async await support in React components, making data fetching straightforward and efficient. Next.js is also flexible with styling approaches, supporting CSS modules, Tailwind CSS, and CSS in JS solutions to match your preferences. Additionally, Next.js includes out-of-the-box optimizations for images, fonts, and scripts, enhancing your application's core web vitals and overall user experience. Finally, Next.js comes with an optimized development and production build system. This means you can focus on writing code instead of dealing with complex configurations. These features combine to make Next.js a powerful framework for web development. Throughout this course, we will explore each feature in detail. Also, please note that I may refer to Next.js simply as Next in the course, so please don't get confused. Now, what about the prerequisites? HTML, CSS, and modern JavaScript knowledge are required. Since Next.js is a React framework, it's also essential to have a good understanding of React fundamentals. While you don't need to be an expert, you should be familiar with concepts like function components, props, state, JSX, and hooks. If you're new to React, I have an extensive tutorial series that covers React from beginner to advanced level, so make sure to check that out. My goal is to guide you from a complete beginner to becoming an expert in Next.js. You can find all source code for this course in the GitHub repository linked in the description. With this introduction, let's move on to building our first Hello World application in Next.js. Let's create our first Next.js application together. First things first, we need to set up our development environment. We need two things, Node.js and a text editor of your choice. Head over to nodejs.org to download and install the latest stable release of Node.js. If you already have it installed, just make sure it's up to date. Next.js requires Node.js version 18.18 or later. For the text editor, I personally recommend VS Code. You can grab that from code.visualstudio.com. Alright, with our environment ready, let's dive in. I've created a folder called Next.js Tutorials and opened VS Code in it. This folder will be our workspace throughout the course. Creating a new Next.js project is super simple. it just takes one command. Open up your terminal, Control backtick being the shortcut, and run the command npx create -next-app at latest. When you do this, you will see several prompts. First up, it will ask for the project name. We will call it hello-world. Then you will see 7 configuration prompts. Let me guide you through these choices. We want TypeScript, we want ESLint, we want Tailwind CSS, we want our code in a source directory, we will use the new app router. TurboPack is stable in version 15, but we will opt out for now and we will stick with the default import alias. Give it a few seconds to do its thing, and you'll see a new folder called Hello World with your Next.js application inside. To get the application running, navigate into the project folder with the command cd hello-world. Then run the command npm run dev. This starts a development server on localhost port 3000. Control+click or Command+click the link it gives to open the application right in your browser. And there you have it. Your Hello World application is up and running. You'll see the Next.js welcome page with an instruction that says, get started by editing source/app/page.tsx, save and see your changes instantly. Let's do exactly that. Go back to VS Code, minimize the terminal with Control backtick, open the source folder, then the app folder, and find page.tsx. Here, if you scroll down, you can see the 2 instructions. Get started by editing source/app/page.tsx and save and see your changes instantly. Let's replace the text in the second list item with Hello World. Save it, and the browser will automatically refresh and you will see your text change on the screen. Just like that, you've got your first Next.js application running. Now that we know how to generate a Next.js app using create next app, let's take a look at the project's folder structure. Previously, we learned how to create and run a basic Next.js application. Now, we're going to dig into the project's structure to understand what makes everything tick when we run our application. I've got the Hello World project open in VS Code, and at the root level, we can see 4 folders and 10 files. Let's break this down one by one, starting with the files. First, we have package.json. This is where all our project dependencies and scripts live. For dependencies, we've got the essentials, Next.js version 15, React and React DOM version 19. Depending on what you choose during setup, you might also have TypeScript with its types, Tailwind with post CSS, and ESLint packages. The scripts section is pretty straightforward. Dev for development mode, build for production builds, start for running the production server, and lint for setting up Next.js's built-in ESLint configuration. A straightforward package.json file with dependencies and scripts. Next up are our configuration files. We've got next.config.ts for Next.js settings, tsconfig.json for TypeScript, eslint.config.mjs for ESLint, and both tailwind.config.ts and postcss.config.mjs for Tailwind CSS. There are also a few files we won't focus on much in this course. Packagelock.json, which ensures consistent installation of our dependencies, gitignore for version control, the README file, which contains a few instructions related to running, building, and deploying the application, and nextenv.d.ts, which contains the TypeScript declarations for Next.js. Now let's proceed to the different folders. First is the .next folder. This gets created when you run either dev or build scripts. It's where your Next.js application actually gets served from. You will notice that this folder is gitignored, so don't worry about this one too much during development. Then we have node modules, the home of all our installed dependencies. This gets created when you run npm install, or in our case, when we ran the dev script which handles the installation automatically if needed. Like the .next folder, this one's gitignored too, and we don't need to worry about it during development. The third folder is the public folder. It's pretty important. It's where all your static assets like images and SVGs go. Finally, we've got the star of the show, the source folder. Inside source, there is the app folder, which is the app router. This is where we will spend most of our time in this course. Currently, it contains 4 files. Favicon for the browser tab icon, globals.css for application-wide styles, layout.tsx for shared UI elements across pages, and page.tsx, which creates what you see at localhost port 3000. This page.tsx is what we tweaked earlier. The home component defined here slots into layout.tsx as children prop to create the complete UI. In layout.tsx, depending on the minor version of Next.js, you might see Geist font imported as a Google font or might also be referenced as a local font. That does not affect our learnings, so don't worry too much about it. But let me explain how it all comes together. When we run the command npm run dev in the terminal, the execution starts from package.json, moves to layout.tsx, rendering the root layout component. For the URL localhost 3000, it looks for the component in page.tsx within the app folder. That is our home component. It renders this component inside the root layout. You might now be wondering how this app folder handles routing in our application. But before we get there, we need to cover some new React concepts that are fundamental to how we write Next.js code. Let's explore those next. Before we dive into routing, let's cover a fundamental concept that will help us better understand how routing works in Next.js. That concept is React Server Components, or RSC for short. React Server Components is a new architecture that was introduced by the React team and quickly adopted by Next.js. This architecture introduces a new approach to creating React components by dividing them into 2 distinct types: server components and client components. We will explore these component types in more detail as we move forward, but for now, let's focus on a few key points. By default, Next.js treats all components as server components. These components can perform server-side tasks like reading files or fetching data directly from a database. The trade-off is that they can't use React hooks or handle user interactions. If you want to create a client component, you will need to add the useClient directive at the top of your component file. While client components can't perform server-side tasks like reading files, they can use hooks and handle interactions. Think of client components as the traditional React components you're already familiar with from previous versions of React. As we get into routing, you will see practical examples of both component types. We will work with server components that wait for certain operations to complete before rendering content, and we will use client components to take advantage of hooks from the routing module. Having this basic understanding of server and client components will really help you grasp the routing concepts better. If none of this makes sense right now, don't worry. We will cover everything about React Server Components in much more detail later in the course. Alright, with this foundation, let's jump into routing in Next.js. Let's dive into one of Next.js's core features, routing. Next.js uses a file system-based routing system, meaning the URLs you can access in your browser are determined by how you organize your files and folders in your code. Let me show you how this works with some practical examples. I have created a new Next.js project using the command npx create next app at latest routing-demo. Routing demo is the name of our project. When the command completes successfully, you should have a project similar to mine. Navigate to the source folder. Now we will start fresh by deleting the app folder since we are going to build our routes from scratch. I mentioned earlier that Next.js has a file-based routing mechanism. You might naturally wonder, does every file in our app folder become a route? Not quite. Next.js is built around conventions, and routing is one area where these conventions are particularly important. There are 3 main conventions to remember. First, all routes must live inside the app folder. Second, route files must be named either page.js or page.tsx, depending on whether you're using TypeScript. Third, each folder represents a segment of the URL path. When these conventions are followed, the file automatically becomes available as a route. Let's put this into practice. For scenario 1, we want to create a home page that shows up when someone visits our site at localhost port 3000. Let's head back to VS Code and implement this scenario. The first key convention in Next.js routing is that all routes must be placed in an app folder within the source directory. Let's create this folder. The second convention is that any file meant to be a route must be named page.tsx or page.js if you're not using TypeScript. Let's create a page.tsx file in the app folder. From this file, we will default export a simple React component. Export default function home, and this returns an h1 tag that says welcome home. And just like that, we have created our first Next.js route. In the terminal, run the command npm run dev to start the dev server. In the browser, visit localhost 3000 and you will see welcome home displayed. This is our first key routing concept to remember. Page.tsx file inside the app folder automatically maps to your site's root URL. With that, we have successfully implemented scenario 1. Before we continue, let's talk about the layout.tsx file. Even though we deleted this file when removing the app folder, Next.js will automatically create and set it up when you first access the root route. We will explore layouts in depth later, but for now, just remember that this file gets automatically created behind the scenes. Now let's tackle scenario number 2. For this scenario, we need to create 2 additional routes, one for the About page and one for the Profile page. The URL will read localhost 3000/about and localhost 3000/profile. Back in VS Code, let's create these routes. There are 3 simple steps. First, create a new folder called About inside the app folder. Second, inside this About folder, create a page.tsx file. Third, from this file, default export a React component. Export default function About, which returns an h1 about me. Similarly, create yet another folder in the app folder called Profile. Inside the folder, create a page.tsx file. From this file, default export a React component. Export default function Profile, return an h1 tag that says my profile. After saving the files and heading back to the browser, the home page will still be displayed at the root route, localhost port 3000. When you navigate to localhost 3000/about, you will see the About Me page, and similarly, going to /profile will show the My Profile page. Scenario 2 is now complete. The second key routing concept to remember is that routes are directly tied to their folder names within the app directory. A page.tsx file inside the About folder maps to the /about route, and a page.tsx file inside the Profile folder maps to the /profile route. Let me show you a quick visualization of everything we have covered so far. It is pretty straightforward. Page.tsx in the app folder directly maps to the root route, and each folder in the app folder directly maps to a segment in your URL. Now you might be wondering what happens if someone tries to access a URL that doesn't match any file in your app folder. Let's say someone tries to visit /dashboard. In this case, Next.js has got you covered. It will automatically serve up a 404 not found response. You don't need to write any special code to handle these non-existing routes. By now, you should have a solid understanding of how file-based routing works in Next.js. The beauty of this system is that you don't need to mess around with installing and configuring a router in your code. Your file and folder structure does all the heavy lifting. This is a perfect example of Next.js's philosophy of favoring conventions over configuration when it comes to routing. All right, let's continue exploring more routing concepts. Previously, we got a glimpse of Next.js's file-based routing system. We saw how the page.tsx file in the app folder maps to our root domain and how page.tsx files in subfolders create routes matching their folder names, like About and Profile. Now, let's tackle nested routes. In scenario 3, we need to set up a page that shows up when users visit localhost 3000/blog. We will also need to handle 2 additional routes, localhost 3000/blog/first and localhost 3000/blog/second. Let me show you how easy this is with the app router. First up, let's create a blog folder inside our app directory. Inside this blog folder, we will add page.tsx file with a simple React component exported as default. So page.tsx, and the React component export default function blog that returns an h1 tag my blog. If we save this and check localhost 3000/blog, we will see our blog page right away. That takes care of the first part of scenario 3. But what about these nested routes? /blog/first and /blog/second. This is where Next.js really shines. We can simply create 2 new folders inside the blog folder named first and second. So new folder, first, new folder, second. In each folder, we will create a page.tsx file with its own component exported as default. Page.tsx and another page.tsx. We export a default function called firstBlog that returns an h1 tag first blog post. And in the other, we export a default function secondBlog that returns an h1 tag second blog post. Save the files. Navigate to localhost 3000/blog/first, and you will see the first blog page render exactly where it should. And similarly, when you navigate to /blog/second, you will see the second blog page. Just like that, we have implemented scenario number 3. Here's a visualization of how these nested routes work. Page.tsx in the app folder corresponds to the root route. Page.tsx in the blog folder corresponds to /blog. Page.tsx in the first folder corresponds to /blog/first, and similarly /blog/second. The key takeaway here is that Next.js mirrors your folder structure in your URLs automatically. It is that simple. Up next, we will check out something even more powerful: dynamic routes. Previously, we learned about nested routes by creating a blog folder in the app directory with first and second subfolders. Each subfolder has its own page.tsx file corresponding to /blog/first and /blog/second. While this works for simple cases, using predefined paths isn't always practical for complex applications. Let's dive into scenario 4 to understand why. In this scenario, we are building a product listing and details page. When the user visits /products, they should see a list of 3 products. However, when they navigate to /products, followed by the product's ID, they should see details for that specific product. For example, navigating to /products/1 should display details about the first product, /products/2 should display details about the second product, and so on. Let me show you how we can implement this in Next.js. First, let's create a products folder in our app directory. New folder, products. Inside it, we'll create a page.tsx file. This file will contain a React component that displays a list of 3 products. So export default function, product list, and we return an h1 that says product list, and 3 h2 for product 1, 2, and 3. If you head over to localhost 3000/products, you will see our product list. That is part 1 done. Now, based on what we have learned about nested routes, you might think we could just create separate folders for each product, right? A folder for product ID 1, a folder for product ID 2, and so on. Similar to first and second in our blog folder. Let's try that approach first. We'll create a folder named 1 in our products directory and add a page.tsx file. Here, we will default export a React component that displays the text details about the product using an h1 tag. Export default function, product details, returns an h1 details about product. Sure enough, if we visit localhost 3000/products/1, it works. But here's the thing. Imagine having hundreds of products. Creating a folder for each one would be a maintenance nightmare. This is where dynamic route segments come in handy. First, delete this one folder, and instead, we will create a special folder with square brackets. So within products, new folder, square brackets, and we'll call it product ID. I'm using product ID instead of just ID because it is more descriptive. Inside this folder, we will create our page.tsx file. We will default export the same component. Export default function product details returns an h1 tag details about product. But now something cool happens. When you refresh the browser and visit /products/1, we will see the product details page. Visit /products/2/products/3, even /products/100, they all work. That is because Next.js treats a folder name in square brackets as a dynamic segment, making our routes dynamic and flexible. Product ID here refers to product ID 1, 2, 100, and so on. But showing this same text for every product isn't very useful. In a real app, you would probably fetch product details from an API based on this product ID. For now, let's at least show which product we are looking at. Now, every page in the app router receives route parameters through the params prop. Let's destructure it as params. The type of params is a promise that resolves to an object containing the dynamic segments as key value pairs. In our case, that is product ID, the name of our folder. The nice thing about server components is that we can use async await to resolve the promise and access the dynamic segment. So export default async function product details, and within the component, const product ID is equal to await params and access product ID. Display the product ID in the UI. Now, when you visit /product/1, you will see details about product 1, and /products/100 shows details about product 100. And remember, the ID doesn't have to be a number. It could be a string. For example, products/iPhone, and we see details about product iPhone. Scenario 4 has been successfully implemented. Let me summarize what we have built. We have created a folder with square brackets containing product ID, added a page.tsx inside it, and Next.js now maps any /products/ID URL to this file. Inside the component, we grab the product ID from the params prop to show dynamic content. Here is a visualization of dynamic routes. Page.tsx within the app folder corresponds to the root route. Page.tsx within the products folder corresponds to /products, and page.tsx within the product ID within square brackets folder corresponds to a dynamic segment, /1, /2, /100, and so on. This pattern is super useful for building list detail views in your application. Whether you're building an e-commerce site with millions of products, a blog with a few hundred blog posts, or any app that needs dynamic routing, this approach will serve you well. Let's build on our knowledge of dynamic routes and dive into nested dynamic routes. In real-world applications, you will often come across scenarios where you need to handle multiple dynamic segments in your routes. Consider scenario 5. You want to show product details at /products/1, but you also need to display the first review for that product at /products/1/reviews/1. Let me show you how to set this up with the app router. Previously, we set up the dynamic product ID route. That is why /products/1 already shows product details. Now let's tackle /products/1/reviews/1. If you're comfortable with file-based routing by now, this next part should click right away. When we are dealing with multiple path segments, we need to think in terms of nested folders. Here's what we will do. First, inside the product ID folder, create a reviews folder. This gives us /products/product ID/reviews. But we are not done yet. We also need a dynamic review ID. So inside this reviews folder, create another folder named review ID within square brackets. Within this folder, create a page.tsx file. Here, let's define a React component that shows both the product ID and review ID. So export default async function product review, and we destructure route params. Params is of type promise that resolves to product ID, which is of type string, and review ID of type string. Product ID and review ID correspond to product ID, our dynamic route, and review ID, our dynamic route as well. Within the component, we destructure product ID and review ID by awaiting params. We then return an h1 review ID followed by for product, product ID. Now for the fun part. In the browser, navigate to localhost 3000/products/1/reviews/1, and you will see exactly what we wanted. Review 1 for product 1. Try changing the URL. Maybe go to product 100 and review ID 5. Watch those IDs update in real time. Review 5 for product 100. We have successfully implemented scenario 5. Here is a visualization to help you picture these nested dynamic routes. Page.tsx within the app folder corresponds to the root. Page.tsx within products corresponds to /products. Page.tsx within product ID corresponds to /1. We don't have a list review route, and we skip to review ID, where page.tsx corresponds to the review ID 1 /products/1/reviews/1. The key takeaway here is that you can create nested dynamic routes simply by using dynamic segments with nested folder names. But here is something interesting. Next.js actually has another way to handle multiple dynamic path segments. Before we dive into that, I have an exercise for you. Implement a review listing page for each product. So create a page.tsx file in the reviews folder and list a couple of reviews. Let me know how that goes in the comment section. Let's dive into another powerful routing concept called catch-all segments. To understand this better, consider scenario 6. Imagine we're building a documentation site for our project. This site has multiple features, and each feature contains several concepts that need documentation. Picture a site navigation with 5 features, where the first feature expands to show 5 different concepts. The goal is to create unique routes for each concept under its respective feature. Think about URLs like localhost 3000/docs/feature1/concept1, /docs/feature1/concept2, /docs/feature2/concept1, and so on. Now, if we have 20 features and each feature has 20 concepts, we are looking at 400 different routes. Since Next.js uses file system-based routing, that would mean 400 separate files in a project. But here's where dynamic routing comes to the rescue. By using dynamic route folders with a concept ID, we can cut that down to just 20 files. Take it a step further by making the feature folder dynamic with a feature ID, and we are down to just 2 folders. One for feature ID and one for concept ID. Much better, right? But there is still a catch. Every time we add a new path segment to our URL, like /docs/feature1/concept1/example1, we need another level of nesting in our routes folder. Since every page in our documentation shares the same layout, wouldn't it be great if we could handle all these route segments with just one file? That is exactly what Catch-all Segments feature lets us do. Let me show you how to set it up. In your app folder, create a docs folder. Inside that, create another folder with a special Next.js naming convention. Use square brackets with 3 dots, like the spread operator, followed by a name. We will use slug, since that is a common term for URLs. Then create a page.tsx file within the slug folder. Default export a React component. So export default function docs that returns an h1 tag docs homepage. The magic of this file is that it matches any URL with docs in the path. Try it out. Whether you visit /docs/feature1/concept1 or even /docs/feature1/concept1/example1, you will see the same docs page. That is the catch-all segments route in action. It captures all URL segments and handles them in this single file. This is perfect for documentation sites where you want different URL segments for organization and SEO, but keep the same basic layout. Of course, you'll want to access the different URL segments in your code. Let me show you how to do that using the params object. We destructure params from prop, and params is of type promise. We have slug, which is an array of strings. Within the component, destructure slug from params by awaiting it. Make sure your component is an async function. For the JSX, we will use an if-else block to handle the different possibilities. So if slug exists and the length is equal to 2, we return an h1 tag viewing docs for feature slug of 0 and concept slug of 1. Else, if slug exists and the length is equal to 1, we return an h1 tag viewing docs for feature slug of 0. Pretty simple. In the browser, navigate to /docs/routing and you will see viewing docs for feature routing. Navigate to /docs/routing/catch all segments and you will see viewing docs for feature routing and concept catch all segments. You can customize this UI logic however you need, but typically you would use the slug array to fetch the right documentation for each feature or concept. Scenario 6 has been successfully implemented. Now Next.js also offers optional catch-all segments. Right now, if you navigate to just /docs in the URL, you will see a 404 error. But if you want to show the same docs page here too, just wrap your folder name in an extra pair of square brackets. So rename the slug folder and wrap it with an extra pair of square brackets. This makes the slug segments optional, and now /docs will work as well, triggering this last return statement. Now you might be wondering, when should you use a simple page.tsx in the docs folder versus the optional catch-all page.tsx, since both of them render UI for /docs in the URL? Well, it is straightforward. If your page UI is always the same, the simple page.tsx in the docs folder. If your page UI is different based on the URL, for example, as it is the case in our current scenario, then use the optional catch-all route. Page.tsx within slug folder as opposed to page.tsx directly within docs folder. Here is a visualization of catch-all segments. Localhost 3000 will render page.tsx in the app folder. For any URL that contains docs, we render page.tsx in the slug folder, which is our catch-all segment. Alright, that is a comprehensive look at catch-all segments. We have covered a lot about Next.js routing, but there is still more to explore. Let's continue with the next topic. Let's explore how to create a custom 404 page using the app router. By default, when you visit a route that doesn't exist in your app folder, you will see a basic 404 page. Try visiting localhost 3000/building to see what I mean. While this default page works fine for development, you would probably want to customize it for your production site. The good news is it is super simple. All you need to do is create a file called notfound.js or notfound.tsx if you're using TypeScript in your app folder. Let me show you how. First, in VS Code, create a new file in the app folder called notfound.tsx. not-found.tsx. Remember, the file name must be exactly not-found. This is a Next.js convention. Here, define and export a React component. So export default function not-found, and we return a div tag with an h2 heading that says page not found and a paragraph tag could not find requested resource. Feel free to style this component however you want. I'm keeping it simple here since we are focusing on the concept rather than styling. If you refresh your browser now, you will see the custom not found page instead of the default one. Page not found, could not find requested resource. This file is particularly useful for production sites where you want your 404 page to match your site's branding and design. But here is something cool. While this not found page works automatically with Next.js file-based routing, you can also trigger it programmatically using the not found function. Let me show you an example. Let's say we are building a product review system where we will never have more than 1,000 reviews. And we want to show a 404 page for any review ID above 1,000. So in the review ID folder, page.tsx file, import the not found function from next/navigation. Then within the component, if parse int review ID is greater than 1,000, call the NotFound function. And while we're at it, here is another neat feature. You can actually create specific NotFound pages for different sections of your app. For example, in the review ID folder, you can create another notfound.tsx file with more specific messaging. So I'm going to copy our NotFound file from the app directory, paste it inside the review ID directory, and change the messaging. Review not found. In the browser, when you visit /products/1/reviews/1001, you will see this more specific review not found page instead of your global 404 page. This is because Next.js will use the most specific not found page it can find. In this case, the one in the review ID folder rather than the one in the app folder. One thing to keep in mind though is that the not found component does not accept props. You might be wondering, what if I need to show different messages based on the route parameter? For that, we will rely on the usePathName hook from Next.js. Let's import it and invoke it within our not found component. Import usePathName from next/navigation, and then within the component, const pathname is equal to usePathName. However, when we save this file, we encounter an error. You're importing a component that needs usePathName. This React hook only works in a client component. To fix, mark the file or its parent with the useClient directive. If you remember from earlier, I mentioned that in the new React Server Component architecture, all React components are server components by default, and hooks can only be used inside client components. So let's follow the instruction to fix the error. Add useClient at the top of the file. Within quotes, useClient. Our not found component is now a client component. You can access the pathname constant within the component and extract the route parameters from it. So const product ID is equal to pathname.split on /, we access at index 2. Similarly, review ID is going to be pathname.split at / and access index 4. Now we can display the extracted values within the component's JSX. Review ID, not found for product ID. In the browser, you will see the message review 1001 not found for product 1. Alright, that is everything you need to know about the not found file and function in Next.js App Router. While Next.js gives us some routing conventions to follow, it's actually pretty flexible about how you structure your project files and folders. Let's take a look at file colocation in Next.js. You already know that Next.js uses a file system-based router. Each folder represents a route segment that maps to a URL path. But here is the important part. A route only becomes publicly accessible when you add a page.js or page.tsx file to it. Let me show you what I mean. Let's create a new folder called dashboard in our app directory. Inside it, we'll create a file called linechart.tsx. Here, we will define a simple React component, default function linechart, which returns an h1 tag linechart. Now, if you try going to /dashboard in your browser, you will get a 404 page not found error. Why? Because we haven't added a page.tsx file yet. That is what makes a route accessible. Let's create page.tsx. Now here is another interesting thing. Even when a route is public with a page.tsx file, the browser only gets what is returned by page.tsx, and it has to be a default exported React component. Let's see what happens if we create a component without making it a default export. It's a function bar_chart that returns an h1 bar chart. In the browser, you can see the 404 page go away, but you will see an error saying the default export is not a React component in /dashboard/page. Let's fix this by adding a proper default export to our component. So export default function dashboard that returns an h1 dashboard. Now, when you visit the browser and refresh, you will see dashboard appear. Notice that the bar chart component still isn't showing up. So what is the key takeaway here? You can safely co-locate project files inside route segments in the app directory without worrying about them accidentally becoming routes themselves. By the way, while you can keep your files in the app directory, you don't have to. Some developers prefer to keep their files outside the app directory, maybe in the source folder with a separate components folder for all their UI components. Chassis and library does this, for example, and that is totally fine too. Next.js also gives us 2 more cool features to help organize our project. Let me show you those next. We just learned about safe co-location of files, which Next.js handles right out of the box. Now, let's dive into another cool Next.js feature, private folders. This will help you keep your project super organized. So what is a private folder? Think of it as a way to tell Next.js, hey, this folder is just for internal stuff. Don't include it in the routing system. The folder and all its subfolders are excluded from routing. To create a private folder, just add an underscore at the start of the folder name. Let me show you how this works. In your app folder, create a folder called _lib. This is where you might put utility functions like formatDate.js or .ts if you're using TypeScript. We will skip the implementation details for now. But here is what I really want to show you. Let's create a page.tsx file inside this _lib folder with a simple React component. So new file, page.tsx, export default function, private route, and return an h1 tag. You cannot view this in the browser. Now you might think this would show up at localhost 3000 /_lib, but it won't. The underscore in _lib makes it a private folder, so Next.js won't create a route for it. Try navigating to /_lib in the browser, and you will get a 404 error. Page not found, could not find requested resource. This is the custom 404 page we defined earlier. Private folders are super useful for a bunch of things. Keeping your UI logic separate from routing logic, having a consistent way to organize internal files in your project, making it easier to group related files in your code editor, and finally, avoiding potential naming conflicts with future Next.js file naming conventions. And here is a quick pro tip. If you actually want an underscore in your URL, use %5f instead. That is just the URL encoded version of an underscore. Try switching underscore with %5f and see what happens in your browser. Let me know in the comment section if you can view page.tsx in the browser. Private folders is just one of the ways to organize your Next.js project. If this is not your cup of tea, you can always choose to not use the feature and simply rely on file colocation or even place files outside of the app folder. Up next, we will check out another awesome feature Next.js gives us for project organization. Let's dive into another powerful feature Next.js offers for organizing our projects, route groups. This feature lets us logically organize our routes and project files without impacting the URL structure. It is also worth noting that route groups are actually the only way to share a layout between routes without affecting the URL. Let's see route groups in action by implementing some authentication routes. We will build routes for register, login, and forgot password. First, head over to your app folder and create 3 folders: register, login, and forgot password. In each folder, we will define a page.tsx file with a simple React component with a heading. So register page.tsx, export default function register, which returns an h1 tag register. Copy page.tsx from register folder, paste it in the login folder, and change register to login. Similarly, paste page.tsx in forgot password and change component name to forgot password. In the browser, visiting localhost 3000 /register shows register, /login shows login, and /forgot password shows forgot password. Now this works, but there is a problem. Our authentication routes are scattered throughout the app folder. While this might be fine when you're working solo and know all the authentication routes, it does become challenging in a team environment. Let's improve the developer experience by grouping related routes together. We can do this by creating an auth folder to house all our authentication related routes. Let's try it. Create an auth folder inside the app directory and move the register, login, and forgot password folders inside it. So register, move it inside auth, update imports, move login inside auth, update imports, and move forgot password inside auth, update imports, and save the changes. The project structure looks much cleaner now, right? But if you check your browser, you will notice the routes are broken. /register, login, and forgot password all return 404. This happens because Next.js automatically maps nested folders to URL paths. So now we have auth/register, auth/login, and auth/forgot password. While this URL structure might work for auth routes, it might not be ideal for other groups like marketing or analytics. This is where route groups come in handy. To create a route group, we simply wrap the folder name in parentheses. So rename auth folder, add parentheses, and auth inside it. This tells Next.js to treat this folder as an organizational tool only, excluding it from the URL path. If you have trouble renaming the folder, stop the dev server with Ctrl+C, rename the folder, and restart the server with npm run dev. Check your browser again, localhost 3000/register. We see register page, /login, login page, and forgot password. We see the forgot password page. But now our code is neatly organized. And if you need more organization, you can even nest route groups within each other. That wraps up our exploration of routing with pages in the app router. Up next, we will explore layouts in detail. We've explored pages so far, which are route-specific UI components. Now, let's dive into layouts. A layout is UI that is shared between multiple pages in your application. Think of it like having a consistent structure, such as a header and footer, that appears on every page. Next.js makes this super easy to implement. Creating a layout is straightforward. You just need to default export a React component from a layout.js or layout.tsx file. That component takes a children prop, which Next.js will populate with your page content. Let's look at this in action. I should mention that we don't need to create a layout from scratch because Next.js provides one by default. In your app folder, you will find layout.tsx. Like page.tsx, this follows Next.js's special file naming conventions. This layout.tsx file in the app folder is called the root layout, and it is not optional. Every Next.js app must have one. In fact, Next.js is so insistent about this that if you delete it, it will automatically regenerate the file. Let me show you. Delete, move to trash, refresh localhost 3000 in the browser, and look at that. Next.js has already recreated it. Let's understand the code here. We'll talk about the metadata object later, but for now, let's focus on the React component. Every layout component needs a children prop. This is where your page content will go. In our case, the page.tsx in the app folder becomes the children when layout.tsx renders. If you inspect the elements in Chrome DevTools, you will see an HTML tag with language is equal to English, matching our layout, and a body tag containing an h1 tag, welcome home. That is coming from our page.tsx component through the children prop. Right now, our layout isn't doing much. Let's make it more useful by adding a header and a footer. I will paste the code since this is basic HTML and CSS. So we have the header tag with style, background color light blue, padding 1 rem, with a paragraph tag that says header. We then have the footer element with style, background color ghost white, padding 1 rem, with a paragraph that says footer. Sandwiched in between header and footer is our children props. Really simple HTML and CSS. Although we could make separate components for the header and footer, we are keeping it simple with placeholder text and basic styling for now. Take a look at the browser, and you will see the header and footer. The cool part is that these stay in place no matter which route you visit. Try going to /about or /products. The header and footer remain constant. That is the power of the root layout.tsx file. It creates a consistent structure across your entire application. You can add whatever markup, styles, or behavior you want to. Just remember to include the children prop so your pages can render their unique content. Here is a visualization of how layouts work in the app router. When you visit localhost 3000, the root layout component in layout.tsx in the app folder gets rendered. This contains a header at the top, a footer at the bottom, and the children prop in between. The children prop gets replaced by the component defined in page.tsx within the app folder. When you visit localhost 3000/about, the component defined in page.tsx within the about folder replaces the children content in the layout file. And when you visit localhost 3000/profile, the component defined in page.tsx within the profile folder replaces the children prop in the layout file. I hope this helps you understand layouts better. Now here is a quick challenge before we proceed. Try creating your own header and footer components and add them to the root layout. Drop a comment to let me know how it goes. Up next, we will explore nested layouts. Previously, we explored layouts, these handy UI components that are shared between multiple pages in your application. Every app needs a root layout, which in our case lives in the layout.tsx file in the app folder. Now here is something cool about layouts. You can nest them. Let's say you want a special layout just for your product details pages. We can do that by adding a layout.tsx file inside the product details folder. Let me show you how. In the product ID folder, create layout.tsx file. Here, define and default export a React component. So export default function. Let's call this product details layout. The component accepts children prop of type react.reactNode, and we return the children prop along with an h2 that says featured products. So just like the root layout, we're exporting a React component with a children prop. But this time, the children prop represents the product ID page content. Details about product followed by product ID. I've also added a simple h2 heading that says featured products. Think of this as a spot where you might want to show a carousel of featured products. Let's see how this works. Back in the browser, when you visit the root route, so localhost 3000, you will only see the root layout, header, footer, and the children content from page.tsx in the app folder. Same thing happens when you visit /products. Header, footer, and the product list component as children. But here is where it gets interesting. When you navigate to a specific product, so /products/1, you will see that featured products section appear for /1, /2, and even /100. This happens because first, Next.js renders the root layout with the children prop representing the product ID folder content. Then the product ID's layout kicks in, replacing the children prop in the root layout. We will see featured products. Finally, the actual page content from page.tsx in the product ID folder fills in the children prop in the product ID layout. This pattern gives you the power to create specialized layouts for different parts of your application. Here's a visualization of nested layouts in the app router. For localhost 3000, the layout.tsx file in the app folder gets rendered. For /products, the component in page.tsx in the products folder replaces the children prop in the root layout. When you visit /products/1 tsx, the component in layout.tsx becomes the children prop in the root layout. The product details layout contains the featured products. And then the component from page.tsx gets rendered as the children prop in the product ID's layout.tsx file. So we see the header and footer, and sandwiched in between, we see the layout and page components from product ID. When you navigate to /product/2, only the page.tsx content gets replaced with the updated JSX. The key takeaway here is that Next.js App Router supports nested layouts, letting you customize different parts of your app exactly how you want to. Now you might be wondering, what if I want to exclude the header and footer from certain pages? For pages like login, register, or forgot password, you may want a cleaner, more focused layout. Well, don't worry. There is a straightforward solution for this, which we will explore next. Before we start, I just want to mention that I have switched to a fresh Next.js project just for this topic to make this super easy to follow. Now imagine we're building an app with routes for revenue, customers, login, and register, all of which I've already created behind the scenes. We want our revenue and customers pages to have a nice header and footer, but we want to keep our login and register pages clean and minimal. Here's the challenge though. If we add a header and footer in the root layout.tsx file, they will be applied to every single page in our application. There's just no way around it. But what if we want different layouts for different parts of the app? This is where multiple root layouts come into play. Now you might be thinking, how can we have multiple root layouts? Isn't there supposed to be only one in the app folder? This is where route groups really shine. Remember how route groups help us organize our project structure without affecting URLs? Well, they also let us apply layouts selectively to specific parts of our application. Let me show you how. First, create two route groups in the app folder. First, marketing for revenue and customers. Let's move those folders. And then another route group, auth for login and register. Let's move them as well. Next, we will take our root layout.tsx file and move it from the app folder into the marketing route group. Move it, update imports, and change the name to marketing layout. It is very important that the root layout does not exist in the app folder anymore. We will create another layout in the auth folder. So copy paste the layout file and rename this to auth layout. And here, let's get rid of the header and only have the footer. When you save the files and check this out in your browser, you will see an error. Page.tsx doesn't have a root layout. And this is the page.tsx file in the app folder. All you have to do is move this into the marketing route group. Now, page.tsx corresponds to localhost 3000, and it does have a root layout file to work with. But in the browser, you will see something cool. The URLs haven't changed at all, but now the register and login pages have only the footer in the layout, whereas customers and revenue has both header and footer. We're able to define multiple root layouts that affect specific parts of our application. This is what makes route groups so powerful in Next.js. They give us the flexibility to create different user interfaces for different parts of our app, all while keeping our code organized and maintainable. Alright, now that you're comfortable with how components work in a layout, let's dive into something else that is interesting. This metadata object that is sitting right above it. We will switch back to the route demo project to understand this better. Let's talk about search engine optimization and how Next.js can help us get it right. The Metadata API in Next.js is a powerful feature that lets us define metadata for each page, making sure our content looks great when it is shared or indexed by search engines. The app router gives us two ways to handle metadata in layout.tsx or page.tsx files. You can either export a static metadata object or export a dynamic generate metadata function. Before we dive in, here are the key points you need to know about configuring routing metadata. Both layout.tsx and page.tsx can export metadata. Layout metadata applies to all its pages, while page metadata is specific to that page. Metadata follows a top-down order, starting from the root level. When metadata exists in multiple places along a route, they merge together, with page metadata overriding layout metadata for matching properties. Let's jump into VS Code and start with the static metadata object approach. We will keep the existing metadata in root layout.tsx file. Title, Next.js, description generated by Next.js. In our About Routes page.tsx, export a metadata object, so export const metadata with the title property set to About Codevolution. While both layout and page can have metadata, the page's metadata takes priority when they overlap. Let's check this out in the browser. Looking at the Home Pages Elements panel, you will see the title Next.js and description generated by Next.js. This comes from our layout.tsx metadata. Now, when we go to localhost 3000/about, notice how the title changes to About Codevolution while keeping the same description generated by Next.js. This happens because when routes have multiple metadata objects, they merge together with deeper segments taking priority. Since About page is deeper than the root layout, its title overrides the layout's title. About Codevolution overrides Next.js. The description stays the same because it wasn't overwritten. It was never defined in page.tsx. This pattern works the same way no matter how deeply nested your layouts and pages are. And this is how static metadata object configuration works in Next.js. Next, let's take a look at dynamic metadata. This comes in handy when your metadata depends on dynamic information like current route parameters, external data, or metadata defined in parent segments. You can define it by exporting a generateMetadata function from a layout.tsx or page.tsx file. A perfect example is a dynamic route like product ID. Instead of having the same title for every product, which would happen with a static metadata object, we can make it unique for each product. Here's how we set up the generateMetadata function. In page.tsx, first we'll create our component props type. So type props is equal to params, which is a promise that resolves to product ID of type string. And then we will use this type with our component. So params of type props. Finally, we will define the generateMetadata function. At the top, import the metadata type from Next.js. Then export a function called generateMetadata, exactly this name. And this is an async function. The function receives params of type props and returns a promise of type metadata. Within the function body, we await params and access product ID. We assign it to a constant called ID, and we return a metadata object with the title set to product followed by the product ID. Now, if we head back to the browser and visit /products/1, inspect the title, we can see it is product 1. Navigate to /100, and we can see the title product 100. For this simple example, we are using the product ID directly in our title. However, in a real e-commerce application, where you might have a product catalog, you could fetch the product details within this function and set the title accordingly. We don't have an API to work with, so we will keep it simple and return a promise that resolves in 100 milliseconds. So const title is equal to await new promise, which will resolve after 100 milliseconds. So set timeout, resolve. Let's assume the title fetched is the word iPhone followed by the ID. We return title, product, followed by title. In the browser, if we navigate to /products/16, we can see the title is product iPhone 16. This is how you configure dynamic routing metadata in Next.js. One important point I should mention is that you can't use both a metadata object and generateMetadata function in the same route segment. It is one or the other. And before we move on, there is one crucial limitation you need to be aware of when working with metadata. It will not work in pages that are marked with the use client directive. Let me show you what I mean. I'm going to create a new route in the app folder called counter. I'm going to create a page.tsx file. that default exports a simple counter component. Count state variable, set a function, button on click to increment the count. Since the component uses React hooks, I will mark it with the useClient directive at the top. I will also set the title to counter in the metadata object. So export const metadata. It's an object with title set to counter. In the browser, when you navigate to the route /counter, you will encounter an error. You're attempting to export metadata from a component marked with useClient, which is disallowed. Either remove the export or the useClient directive. You will encounter the same error even if you export the generateMetadata function. The solution is to keep your metadata in server components and extract any client-side functionality into separate components. So let me show you the correct pattern. In the counter folder, create a new counter.tsx file and move the client-side logic from page.tsx into counter.tsx. I'm going to copy the code, paste it here, remove the metadata object, and rename the component to counter as a named export. It doesn't have to be a named export, but I prefer my components to be named exports. In the counter routes page.tsx file, we can now import the counter component and return it. So return counter, and make sure to import the counter component at the top. Remove the useClient directive, the useState hook, but leave the metadata object as it is. Now, when you refresh /counter route, you will see the counter title and the page renders without any errors. You also see the same title in the browser tab, counter. This is the recommended way to handle metadata in client components. Let's dive deeper into the title field in metadata, which plays a crucial role in routing. The title field's main job is to define your document title, and you can set it using either a string or an object. Let me show you both approaches. The simplest way to set the title is with a string value. This is what we have been doing in our layout.tsx and page.tsx files. When we set the title to about Codevolution, it renders exactly that string in the browser's title tag. But what if you need more control? That is where defining the title as an object comes in handy. It might seem complex at first, but you will get the hang of it. Alright, in your route layout, you will first want to import and use the metadata type for better TypeScript support. Import metadata from Next. Metadata is of type metadata. Now, when using the object approach, you get three powerful options: template, default, and absolute. Let's start with default. The title.default property acts as a fallback for any child routes that don't specify their own title. For instance, if we set the value to Next.js tutorial-codevolution, and you have a page like app/blog/page.tsx without a defined title, it will automatically use this default title. In the browser, navigate to /blog, and we see the title Next.js tutorial-codevolution. The default value is the fallback value. Next up is the template option. This is really useful when you want to add consistent prefixes or suffixes to your titles. This property applies to child routes. We will set it to %s, the pipe character, and Codevolution. Now, in the blog page, if you set the title to blog, so export const metadata title set to blog, the output is blog pipe Codevolution. The child page title, which is blog, replaces %s in the layout template. This pattern is particularly useful in multi-page applications where you want consistent title formatting across your site. Lastly, we have the absolute title option. Sometimes you might want to break free from the template pattern set by parent segments. That is exactly what title.absolute property does. Remove this property from the layout file and add it to the blog page. Title is an object, and we set absolute. The value is the string blog. And here is what we get. Just blog, nice and clean. And we are breaking away from the pattern set in layout.tsx file. Title.absolute overrides the parent segment's title. Alright, that covers everything you need to know about routing and SEO metadata in Next.js. Up next, we will explore linking and navigation with the app router. Previously, we dove into the file-based routing system in Next.js. We covered defining routes for our application's route, nested routes, dynamic routes, and catch-all routes. While we've been typing URLs directly in the browser to test these routes, that is not how real users navigate websites. Instead, they click on links or get redirected after certain actions. Let's see how to implement this in Next.js. First up, let's look at navigating from the home page to the blog page when clicking a link. For client-side navigation, Next.js gives us the link component. The link component is a React component that extends the HTML anchor element, and it is the primary way to navigate between routes in Next.js. To use it, we will need to import it from next/link. In our root page.tsx file in the app folder, let's start by importing the link component. Import link from next/link. Now we can add the link component to navigate anywhere in our application. Here's the syntax. I'll wrap the h1 tag with React fragment and add a link right below the heading. The text is blog, href is equal to /blog. By using the link component with an href prop, we create clickable navigation elements. In this case, we are showing blog as the text, and when clicked, it will take us to /blog. Save this, head to the browser, and you will see a clickable blog link that takes you right to the blog page. Let's add another example to make sure we've got this down. We will create a link to the products page right after our blog link. So link component, the text is products, and the href is /products. Simple, right? Back in the home page, refresh, and we see the products link. Clicking it takes you to /products where we see the product list component. Both our links are working smoothly. Now, it's always good to help users get back to the home page. So let's add a home link in our products list page. Open page.tsx file in your products folder and import the link component. Import link from next/link. Then add a link to the home page in the JSX. The text is home and href is /. This points to our application's route. Now, when you're on the products page, you will see a link to take you back home. Next, let's tackle something more interesting, dynamic routes. In our products page, we have 3 products listed. We can turn each product's heading into a link to its details page. Remember how our dynamic routes are /products/product ID. For example, /products/1. Well, here is how we implement that as a link. Within h2, link component, product1 becomes the text, and href is equal to /products/1. Similarly, product2 and product3. In the browser, you should see the products linked to their respective details pages. Product 1 details about product 1, 2, and 3. While hardcoding these links works, sometimes we need to generate them dynamically. Let's say we have a product ID coming from somewhere else. So const product ID is equal to 100. The value could be from a prop, for example. We can use template literals to create link using this product ID. I'm going to duplicate the h2 heading and bind this product ID. The href, we're going to use backticks, which is the key below escape key. Make sure to wrap it within curly braces, and then $curly braces, product ID. This creates a dynamic link showing product 100 that leads to the corresponding product page. Now here is something I want to highlight about the link component. It has a replace prop that changes how navigation history works. Let's add it to product 3's link component. Now try this. Back in the browser, from the home page, click on products, click product 1, and then hit back. Works normally. Same with product 2, details page, and we go back. But with product 3, we navigate to the details page, but when I hit the back button, it takes you straight to the home page, skipping the product list. That is because replace overrides the current history entry instead of adding a new one. This is something to keep in mind. The link component makes client-side navigation a breeze in Next.js. Just import it from next/link, add your href, and you're good to go. Previously, we learned about the link component for navigating between routes. Now, let's tackle something we haven't covered yet: styling active links. You know how most websites highlight the current page you're on in the navigation menu? Well, we'll build exactly that. It is not just about aesthetics. It helps user understand where they are in your application and is very important. To save time and get us started, I have already prepared some code. In our auth route group, I've created a layout.tsx file with a navlinks array containing 3 items: register, login, and forgot password. Each has a name and a corresponding href property. The layout component maps over these links and renders them using Next.js's link component. If you head over to /register in the browser, you will see all 3 links in the auth layout. You can click between them, and they will stay visible throughout: register, login, and forgot password. Now, let's make them show which one is active. Next.js gives us the usePathName hook to help us figure out which link is active. Let's bring that in. At the top, import usePathName from next/navigation and use it in the auth layout component. The const pathname is equal to usePathName. When we save the file, we encounter an error we've seen before. Remember how server components are default in Next.js? Well, hooks only work in client components, so we need to add the useClient directive at the top of our file. Perfect. Now that is fixed, let's use the pathname constant. It gives us the current URL path. So /register for the register route, /login for the login route, /forgot password for the forgot password route, and so on. These match up with the href values in our navlinks array. So inside the map method, we can add const isActive is equal to pathname being equal to the link's href, or pathname.starts with link href and link.href is not equal to the root route. Next, it's time to add some styles. On the link component, let's add a class name with a conditional. So if isActive is true, we specify font bold and margin right 4. If it is not active, we specify text blue 500 and margin right 4. These are Tailwind CSS classes. Font bold makes the text bold, and text blue 500 gives us a nice blue color. MR4 adds some breathing room on the right. If you check the browser's Elements panel, you will see the active link has the font bold class, while the other links have text blue 500. We are currently viewing /forgot password, so forgot password is our active route. But wait, the styles don't seem to be visible in the browser. This is because we removed the global CSS file earlier. No worries, let's create a styles.css file in the auth folder and add Tailwind CSS, base, components, and utilities. In the layout.tsx file, import the styles.css file. Or if you prefer, you can also bring back the global CSS file from earlier. Either way works. Now head back to the browser, and you can see the current route forgot password is bold and the other links are blue. Click login and the styling changes. That is all it takes to style active links in Next.js. Let's dive into params and searchParams in Next.js. If you're working with navigation, you will definitely need to understand these 2 concepts. In simple terms, for a given URL, params is a promise that resolves to an object containing dynamic route parameters, like ID, for example. SearchParams is a promise that resolves to an object containing the query parameters, like filters and sorting. To understand this better, let's build a simple news article page that supports multiple languages. First, let's look at how to create links with both params and searchParams. In the home component, add 2 links. The first one says read in English, and href is /articles /breaking news 123 language is equal to English. I'm going to duplicate this link, change the text to read in French, and change language to FR. Here, breaking news 123 is the dynamic route parameter, and language is the query parameter. Next, let's define a route for the articles. We've done this before, so in the app folder, create a folder called articles, and inside it, create another folder called article ID. This time within square brackets. Inside the folder, create a page.tsx file and define the news article component. Export default function, news article, and for the JSX, render an h1 tag with the text news article followed by ID and a paragraph with the text reading in language. I will then add a language switcher with links to switch the language. So import the link component from next/link and invoke it. The language is going to be English and href is going to be /articles/ID ? Language is equal to en. Similarly, we will create Spanish and French with language is equal to es and fr. In the browser, when you click the link read in English, the news article component gets rendered. We have breaking news 123, which is the route parameter, and lang is equal to en, which is the query parameter. Go back, click on read in French, and we see the same component with language is equal to fr. Our next step is to access the value of params and searchParams in the news article component and display them in the UI, replacing ID and language. Begin by destructuring the params and searchParams from the props. Params is a promise that resolves to an object containing the dynamic route parameters. In our case, article ID is the dynamic route parameter. This is of type string. searchParams is a promise that resolves to an object containing the query parameters. Lang is the query parameter, and the value can be English, Spanish, or French. I'll also make it optional. Since params and searchParams are promises, you will need to await them in the component. Add the async keyword to the function, and await the params and searchParams. Get hold of the article ID from params and language from searchParams with the default value of English. Now, replace the placeholder text in the JSX with the values of article ID and language. For the links, use backticks instead of double quotes and interpolate $ID. So article ID across all three links. Head to the browser, and we see the values rendered in the UI. News article, breaking news 123, reading in French. Click on the language links, and you will see the language changes. I should point out that you're able to await and access params and searchParams in the news article component because it is a server component. If this was a client component, you would get an error as client components do not support async await. Add useClient at the top and you will see the issue. Now, to access the values of params and searchParams in a client component, you will need to use a hook from React, which is the use hook. So remove async and await, and instead import use from React. Invoke this hook, passing in params and searchParams. Head to the browser, and you can see the component continues to work as expected. So async await for server components, but use hook for client components. That is how you access params and searchParams in Next.js. Now, one very important point to note is that while page.tsx has access to both params and searchParams, layout.tsx only has access to params. searchParams are not available in layout components. As an exercise, define a layout component and try to access searchParams in it, and let me know in the comments below what happens. While links work great for most cases, sometimes we need to navigate programmatically. Think about when you're shopping on Amazon. After you submit your order, you're automatically redirected to an order confirmation page. This kind of programmatic navigation is essential for form submissions and many other real-world scenarios. Let's dive into how we can achieve this using Next.js App Router. For our example, we'll keep things simple. Even though we don't have a full e-commerce site, we will create a basic scenario where clicking a place order button in the order product page navigates us to the home page. Let's start by creating the order product route. In your app folder, create a new order product folder and add a page.tsx file with a basic React component. Export default function order product. We return an h1 tag order product. Let's add a button to make things interactive. Wrap the heading with React fragment and add a button place order. Now we'll add a click handler to the button using onClick. We will define the handle click function, which logs a simple message to the console, placing your order. After our simulated order placement, you want to redirect the user to the home page. This is where the useRouter hook comes in. First, import it at the top of your file. Import useRouter from next/navigation, and inside your component, set up the router. Const router is equal to useRouter. Then use the push method to handle navigation. So after console log router.push, and the path is the home page. In the browser, if you navigate to /order product, you will get an error because useRouter only works in client components. Add useClient directive at the top of your file to fix this. You will now see your heading and the place order button. Clicking the button will take you straight to the home page. That is programmatic navigation in action. Although we are using / as our destination, you can use any valid route, whether it is nested, dynamic, or even a catch-all route. Sometimes you might also want to replace the current page in the history stack instead of adding a new entry. For that, use router.replace instead of router.push. It is similar to using the replace prop on a link component. You can also use router.back to go back to the previous page, or router.forward to move forward in the history. Now there is one more way to handle programmatic navigation, and that is the redirect function. Let's look at an example using our existing product review component. Remember how we check if the review ID is greater than 100 and show a not found page? Well, let's redirect them to the product list instead. At the top, import redirect from next/navigation, and instead of calling not found, we will call redirect with the destination route /products. Now, when you visit localhost 3000/products/1/reviews/1001, in fact, instead of seeing the not found page, you will be automatically redirected to the products list page. A very contrived example, but it shows how we can use redirects in our application. All right, now that we have covered linking and navigation in Next.js, let's dive deeper into some of the related concepts next. Let's look at another special file that Next.js provides in the app router, the template file. To understand template files better, we need to first look at a specific behavior of layouts. In our app router, we have an auth route group with a layout file that handles navigation between three links: register, login, and forgot password. In this layout, let's add an input element to collect some user data. First, we will import useState from React at the top, and within the layout component, we will include a state variable input with a setter function setInput, and the initial value is an empty string. For the JSX, we will render an input element whose value is equal to the state variable input, and on change, we call the setter function e.target.value. The data we are collecting from this input element is not important. We just need some state in our component. Now let's check this in the browser. Navigate to /register, and we should see our auth layout. The input element might not be visible due to styling, but I can confirm it is there. I will type Codevolution as test input. Now pay attention to what happens to this input value as we navigate from register route to the login route. Notice how the state is preserved? This happens because layouts only mount the new page content while keeping common elements intact. They don't remount shared components, which leads to better performance. Register, login, and forgot password are the new pages that are remounted when navigating between them, whereas the input in the layout, which is a shared component, is not remounted. This behavior works great for most cases. However, sometimes you might need the layout to create a fresh instance for each child component during navigation. This could be useful for scenarios like implementing enter or exit animations or running use effect hooks when routes change. This is where template files come in handy as an alternative to layout files. Templates are similar to layouts in that they are also UI shared between multiple pages in your application. The key difference is that whenever a user navigates between routes sharing a template, you get a completely fresh start. A new template component instance is mounted, DOM elements are recreated, state is cleared, and effects are resynchronized. You can create a template by exporting a default React component from a template.js or template.tsx file. Like layouts, templates need to accept a children prop to render the nested rod segments. To demo this, we simply need to rename our layout.tsx file to template.tsx. Back in the browser, if we type Codevolution again and navigate to forgot password, you will see the state is reset. This is the significance of the template file in the app router. It is worth mentioning that you can actually use both layout.tsx and template.tsx files together. In this case, the layout renders first, and then its children are replaced by template components output. Templates are not a common requirement, and layouts should be your go-to for shared UI. However, if a need does arise for you to use templates, you now understand how to use them. We have already explored several special files like page.tsx, layout.tsx, template.tsx, and notfound.tsx. Now let's look at another important one called loading.tsx. This file helps us create loading states that users see while waiting for content to load in a specific route segment. The loading state appears instantly when navigating, letting users know that the application is responsive and actively loading content. Let's head back to VS Code to see how it works. Creating a loading state is pretty straightforward. You just need to add a loading.tsx file in the right folder. Let's try this out for our blog route segment. Within the blog folder, create loading.tsx. Default export a React component. Export default function loading, which returns an h1 loading. Behind the scenes, this loading.tsx file automatically wraps the page.tsx file and its nested children within a React suspense boundary. If you're new to the concept of suspense, don't worry about it. In the browser, if we navigate directly to localhost 3000/blog, you might notice we don't actually see the loading text. That is because our blog page loads super quickly. The blog page content replaces the loading text in the blink of an eye. But trust me, it is working. To prove it, I'm going to introduce a delay with a promise that takes 2 seconds to resolve. So export default async function blog, and we await a new promise which resolves after 2 seconds. Within said timeout, we call the resolve function. I'm going to pass intentional delay as the value that is returned from the promise. Now, when we go back to the browser and reload the blog page, you can see the loading text for 2 seconds, and after our promise resolves, it gets replaced with the blog page content. Right now, we are just showing basic loading text, but in real applications, you can get creative with this. You might want to use skeleton loaders, spinners, or even show a preview of what is coming, like a photo or title. It is completely up to you how polished you want to make this. Just remember to put the loading.tsx file in the correct folder. There are 2 really cool benefits of using loading UI. First, it gives users immediate feedback when they navigate somewhere new. This makes your app feel snappy and responsive, and users know their click actually did something. Second, Next.js keeps shared layouts interactive while new content loads. This means users can still use things like navigation menus or sidebars even if the main content isn't ready yet. The loading UI pattern makes sure these loading states don't get in the way of the parts that are already working, giving users a smoother experience. Alright, that is about loading.tsx for instant loading states in the app router. It is time to explore another crucial aspect of our application, namely error handling. This is implemented through a special file called error.tsx. Let me show you how it works. Right now, when we visit localhost 3000/products/1/reviews/1, everything works smoothly. We can see the first review of our first product. This URL corresponds to the page.tsx file in our review ID folder. But let's be realistic. Things don't always go perfectly. Network requests might fail and data might be unavailable. Let's simulate an error scenario in our review ID page to see how we can handle such situations. Outside of our component, I'll create a function that generates a random integer between 0 and whatever count we pass in. Inside the component, we will call this function with 2 as the argument. So the function will now return either 0 or 1. If it returns 1, we throw an error with the message error loading review. If we refresh the browser a few times, we will eventually see an unhandled runtime error with our error message error loading review. This is in development mode. Let's see how this behaves in production by running npm run build. Once the build completes, run the command npm run start. Now, when the error occurs, after refreshing a few times, we get a generic application error, a server-side exception has occurred. And we will see our error message in the terminal, error loading review. This isn't great for our users, right? The error message isn't helpful, and worse, an error in our deeply nested review ID component breaks the entire application. We can do better by handling errors gracefully, containing them to just the affected part while keeping the rest of our application running. This is where error.tsx comes in handy. Let's create one in our review ID folder. So adjacent to page.tsx, error.tsx. Here we will define a client component. So use client directive at the top, export default function error boundary that returns a div tag error in review ID. This component acts as an error boundary around our page.tsx file. It is very important to note that error boundaries must be client components. You will need to add useClient at the top of the file. Ctrl+C and restart the dev server with npm run dev. Refresh the page until we hit the error. Now we see error in review ID, which is the text from error.tsx. Of course, in a real application, you would want to style this properly to match your application's design. But what is great, as you might have observed, is that the rest of the application still continues to work. We have the header, the featured products from our products layout, and the footer. Only the review ID component has been replaced by the JSX defined in error.tsx. Now this component receives the error object as a prop. So error of type error. We can use it to make our error message more informative. So replace error in review ID with error.message. By replacing our hard-coded text with error.message, we will now see error loading review when things go wrong. The error we threw in our page.tsx file. This same message is passed to our error.tsx component. Now here is what makes error.tsx so powerful in the app router. It automatically wraps route segments and their nested children in a React error boundary. You can create custom error UIs for specific segments using the file system hierarchy. It isolates errors to affected segments while keeping the rest of your application functional. Finally, it enables you to attempt to recover from an error without requiring a full page reload. Now that we have identified all the special files in the app router, let's look at the bigger picture. The slide shows us the component hierarchy in a folder. Layout component at the top, followed by template, then the error boundary from error.tsx for runtime errors, a suspense boundary from loading.tsx, another error boundary from notfound.tsx for missing resources, and finally the page component. With this error handling setup in place, let's explore more advanced error handling techniques as we continue. Previously, we learned how to handle errors gracefully using error.tsx. While some errors are serious, others might be temporary and can be fixed with a simple retry. Let's take a look at how to recover from such errors. Apart from the error prop, the error boundary in error.tsx provides us with another useful prop, a reset function. The type is a function that returns void. We can make use of this reset function by adding a button in our JSX that triggers it on click. We're going to wrap the message in a paragraph tag and add a button. The text is try again, and on click, we're going to call the reset function. This button gives users a way to retry rendering the component in page.tsx. If we head to the browser and reload until we hit the error, you will notice a try again button. When clicked, it attempts to re-render the review ID component. However, if we keep clicking, we will keep hitting the error again and again. This is because the retry function will attempt to re-render client-side. But converting the review ID component to a client component just to handle errors is a bit overkill. To attempt server-side recovery, we will need to rely on start transition from React and useRouter from Next.js. Here is how we can do it. Start by importing useRouter from Next Navigation and start transition from React. Then, within the component, we define a router constant by calling useRouter. Const router is equal to useRouter. Next, we define a reload function that wraps router.refresh and reset call inside start transition. So start transition, this accepts a function where we call router.refresh and reset. Make sure these lines are outside the return statement. The reload function ensures that the refresh is deferred until the next render phase, allowing React to handle any pending state updates before proceeding. Finally, we update the onClick handler to call the reload function. Now, if we head to the browser and reload until we hit the error, you will notice a try again button. When clicked, it attempts to re-render the review ID component. If our random number isn't 1, we will recover from the error and see the actual page content. Of course, this could just be the reload function, but I hope you found this useful. Alright, we've got more interesting aspects of error handling to cover, so let's keep going. Let's focus on how to handle errors in nested routes. Right now, we have our error.tsx file sitting in the review ID folder. Looking at our route hierarchy, we've got products at the top level, followed by product ID, and review ID is nested inside. This structure actually affects how our error.tsx file works. Here's the key thing to understand. Errors always bubble up to find the closest parent error boundary. What this means is that an error.tsx file handles errors not just for its own folder, but for all the nested child segments below it too. By strategically placing error.tsx files at different levels in your route folders, you can control exactly how detailed your error handling gets. Let me show you what I mean. Let's hop into VS Code and move our error.tsx file from the review ID folder up to the products route. When we refresh the browser and trigger an error, we will see the same error message, error loading review. But there is a crucial difference. This time, the entire products route gets replaced by what is in error.tsx file. That is because the error from page.tsx in the review ID folder bubbles up until it finds the nearest error boundary, which is now in the products folder. But watch what happens when we move the file back to the review ID folder and refresh. Now, the featured product section from our product ID layout stays in place and only the review ID component gets replaced by our error.tsx UI. See how much more precise this is? This really demonstrates how error handling works in nested routes. Where you put your error.tsx file makes a huge difference. It determines exactly which parts of your UI get affected when things go wrong. Up next, we will dive into handling errors within layouts. After handling errors in nested routes, let's tackle something equally important: handling errors within layouts. We know that error.tsx handles errors for all nested child segments, but there is an interesting catch with layout.tsx components in the same segment. The error boundary won't catch errors thrown in layout.tsx within the same segment because of how the component hierarchy works. The layout actually sits above the error boundary in the component tree. Let's head back to VS Code and see this in action with a practical example. I'll start by copying the error.tsx file from the review ID route into the product ID route. Then in the product ID layout.tsx, I will add the same random error throw we had in the review ID page. Copy over both the random number generator and the error throwing logic. Change the message to error loading product. I'll comment out the error code in review ID to avoid confusion. Back in the browser, when we reload the page and trigger the error, you will notice something is off. There is no error boundary catching it, and our app breaks with unhandled runtime error. We also see our error message, error loading product. This highlights a crucial point. Error.tsx won't handle errors from a layout.tsx file in the same segment. The solution? Well, we need to move the error.tsx file up to the layout's parent segment. In this case, the products route. Reload the page, and you will see everything works as expected. The error boundary renders properly, replacing just the products route content while keeping the header and footer and other higher level UI elements intact. At this point, I am pretty sure you have a question lingering in your mind. You might be wondering, if an error boundary can't catch errors in the layout.tsx file from the same segment, what about errors in the root layout? It doesn't have a parent segment. How do we handle those errors? Next.js has thought of this. It provides a special file called globalerror.tsx that goes in your root app directory. This is your last line of defense when something goes catastrophically wrong at the highest level of your application. It is a little verbose to simulate and catch errors in the root layout, so let me show you how to set this up. To introduce an error in our root layout, in the app folder, I'm going to add a special wrapper component that throws an error. So adjacent to the root layout.tsx file, create error wrapper.tsx. I'm going to paste the code and walk you through the code. You can find this code on my GitHub repo, but let me quickly go over what we have here. Error wrapper is a client component, so useClient directive is present at the top. We are importing some styles, the useState hook from React, and then we have this error simulator component. It accepts a message and throws that error message if the error flag is set to true. Error is false by default, but when you click on a button, simulate error, set error is set to true, and the error is triggered. The error simulator component is present in an error wrapper component, which accepts children props and renders the same. This component is necessary to throw an error from our root layout. So in layout.tsx file, import the component and add it to the JSX wrapped around children. So error wrapper, opening and closing. Next, add a global error.tsx file in the app folder. So adjacent to layout.tsx, new file, globalerror.tsx. This file should export a React component that will be rendered when an error occurs in the root layout or any of its nested routes in the absence of an error boundary. Once again, to save time, I'm going to paste the code. You can find this code in my GitHub repository. We start with the useClient directive since error boundaries must be client components. We then import some CSS. We then define a React component called global error, which displays an H2 heading something went wrong. On click of a button, we call window.location.reload, and the text is refresh. Very simple. Now in both files, Tailwind classes are used for styling, and you will notice the globals.css import. The file does not exist yet, so let's create it. In the app folder, create a new file called globals.css. Include Tailwind base, components, and utilities. Alright, our setup is now complete. In the browser, when you navigate to localhost 3000, you should see our newly included wrapper component wrapping page.tsx in the app folder. Using this wrapper component, we can trigger an error in the route layout. Click the button. Now we don't see the global error boundary kick in. We only see the error overlay. This is because the global error boundary only works in production mode. In development, you will see the default Next.js overlay instead. So we have an unhandled runtime error and the error message simulated error in route layout. In the terminal, press Ctrl+C to stop the development server and run the build command. npm run build. Then start the production server with npm run start. Back in the browser, simulate the error in the route layout again. Now we still don't see the global error UI, and we don't see the error overlay either. The reason is that global error.tsx needs to include its own HTML and body tags, because when this error boundary kicks in, it completely replaces your route layout. We have HTML and body tags in layout.tsx, which also need to be included in the global error boundary. So HTML and body. Let's rebuild with npm run build and rerun with npm run start. In the browser, simulate the error again, and we can see the global error UI. Something went wrong, and a button to refresh. That corresponds to the JSX present in our global error boundary. Works only in production mode and requires HTML and body tags to be rendered. These are two crucial things you need to know about global error.tsx that makes it different from our regular error.tsx files. Since we can't catch any more errors, it is recommended to have global error.tsx as simple as possible. HTML and CSS would be the ideal scenario. You wouldn't want errors from your global error boundary. Alright, that covers the key concepts about error handling in the Next.js app router. It is time to dive into some advanced routing concepts in Next.js. We're going to start with parallel routes. What they are, how to set them up, and why they're super useful when building complex user interfaces. Parallel routes is an advanced routing mechanism that lets us render multiple pages simultaneously within the same layout. Let's look at scenario 7, building a complex dashboard for a web application. Imagine needing to display user analytics, revenue metrics, and notifications all at once in the same route. The traditional way would be to create 3 separate components for each part and organize them in a layout.tsx file inside a dashboard folder within the app folder. So let's do that. Now we already have a dashboard folder, so let's create a new folder called complex dashboard, complex-dashboard, and add a layout.tsx file. Using regular components, the code might look something like this. The 3 components will be imported from separate files and rendered within complex dashboard layout component. User analytics, revenue metrics, and notifications. The layout will also render the component from adjacent page.tsx as the children prop. This file doesn't exist yet, so let's create it. New file, page.tsx. Export default function complex dashboard and return an h1 tag that says complex dashboard. Each of the other 3 components, which we won't define by the way, represents a specific dashboard section in the UI. Think of them as cards that will render the necessary data. While this traditional component-based approach works well, parallel routes can achieve the same result with some extra benefits. So how exactly do we implement parallel routes in Next.js? Parallel routes in Next.js are defined using a feature known as slots. Slots help organize content in a modular way. To create a slot, we use the @folder naming convention. Each defined slot automatically becomes a prop in its corresponding layout.tsx file. For our complex dashboard, we will create 3 slots within the complex dashboard folder. @users for user analytics, @revenue for revenue metrics, and @notifications for notifications. Let's implement these now. Let's start with notifications. Within the complex dashboard folder, create a new folder called @notifications with a page.tsx file. Default export a React component called notifications, which returns a div tag with the text notifications. Similarly, within complex dashboard again, create another folder, @revenue, create a page.tsx file, and default export a React component called revenue metrics that returns a div tag that says revenue metrics. Finally, create another folder with a page.tsx file, so @users/page.tsx. Export default function user analytics, which returns a div tag with the text user analytics. 3 simple components with the @folder naming convention. Now we can use these 3 slots in our layout.tsx file. The nice thing is that they are automatically passed in as props to our layout component and no imports are needed. Let's delete the import statements and specify 3 more props: users, revenue, and notifications. And for the types, the same 3 components: users, revenue, and notifications. I will update the JSX with inline styles to match the layout from our slide. You can find this code on my GitHub repo. We have an enclosing div tag with a nested div tag that renders children prop. We have the users slot, revenue slot, and finally notifications slot. Let's also create a nice card component to wrap each one of those slots. In the source folder, we'll make a new folder called components with a card.tsx file. I'll paste the code for a card component to save us the time. Now, in each slot, replace the div tag with the card component. Make sure to import the component at the top. So notifications wrapped with card, revenue metrics wrapped with card, and user analytics wrapped with card. We are now ready to go. When you visit localhost 3000/complex dashboard, you will see our complex dashboard with the main title right here and all the 3 slots nicely laid out: user analytics, revenue metrics, and notifications. If it doesn't work, try restarting the development server. Our parallel routes work as expected. But here's something important to note. Slots are not route segments and don't affect your URL structure. So if you try navigate to complex dashboard/users or @users, you won't see user analytics. You get back a 404 page not found. And what is even more interesting is that the children prop is actually an implicit slot that doesn't need its own folder. Complex dashboard/page.tsx is the same as complex dashboard/@children/page.tsx. So technically, we are working with 4 slots in our layout file. Now let me walk you through some of the use cases for parallel routes. Dashboards with multiple sections, split view interfaces, multi-pane layouts, complex admin interfaces, and really any UI where sections need to operate independently. You might be wondering, what is the benefit of building user interfaces with parallel routes? What makes them so special? While parallel routes are great for splitting a layout into manageable slots, especially when different teams work on different parts, that is not their main superpower. You could do that with regular components as well. The real magic of parallel routes comes from 2 key features: independent route handling and subnavigation. Let's break this down. One of the most compelling features of parallel routes is the ability to handle each route independently. This is huge because each slot in your layout, such as users, revenue, and notifications, can handle its own loading and error states. This granular control is particularly useful in scenarios where different sections of the page load at varying speeds or encounter unique errors. Think about it. If your user analytics data is taking its sweet time to load, you can show a loading spinner just for that part while everything else stays interactive. Or if something goes wrong with fetching revenue metrics, you can display an error message in that specific slot without breaking the rest of your dashboard. The other significant advantage of using parallel routes is their capability to offer a seamless sub-navigation experience within each parallel route. Each slot can essentially function as a mini application, complete with its own navigation and state management. Users can interact with each section separately, applying filters, sorting data, or navigating through pages without affecting other parts. For example, in the Notifications section, users might want to switch between default and archived views to see older notifications. These interactions stay contained within the Notifications section, and the URL updates to match the current view. This makes the URL shareable and helps users track their location in the application. Users can also navigate through different parts of the application without unnecessary page reloads or layout shifts. Now, when discussing sub-navigation in parallel routes, there is a very important concept we need to understand. Let's see what that is next. Let's dive into a crucial aspect of parallel routing, which is handling unmatched routes. We've already learned that sub-navigation within routes is one of the benefits of using parallel routes. For example, in our complex dashboard, we could navigate between a default list of notifications and an archived list of notifications. Let's jump into VS Code and implement the scenario. First, we will update page.tsx in the notifications slot to add navigation to the archived view. Import the link component and include it in the JSX. Let's wrap notifications in a div tag and add another div with link. Text is archived and href is /complex dashboard/archived. Link, by the way, is a default export. Now let's create the archived notifications view. Inside the notifications slot, create an archived folder. Remember, this is a regular route folder, and add a page.tsx file with similar code but modified for the archived view. So copy page.tsx, paste it, update the component name to archived notifications, the heading, and the link we point to default notifications. The href is /complex dashboard. Please note, archived is a regular route folder and not a slot. If you now check the browser, you will see the link for archived notifications. Clicking it changes the URL to /complex dashboard/archived, and the UI shows the archived view. Clicking the default link takes you back to /complex dashboard, and we see the notifications view. Our sub-navigation is working perfectly. With this implementation in place, let's discuss the main topic for this video, which is unmatched routes. By default, the content rendered within a slot matches the current URL. Our complex dashboard has 4 slots: children, users, revenue, and notifications. When you visit localhost 3000/complex dashboard, all slots show their respective content. But when you navigate to localhost 3000/complex dashboard/archived, only the notifications slot has matching content. The other 3 slots, children, users, and revenue, become unmatched. Next.js handles these unmatched slots differently depending on how you navigate. When navigating through the UI, like clicking links, Next.js keeps showing whatever was in the unmatched slots before. So when you move between default and archived notifications, the other 3 slots, children, users, and revenue, stay exactly as they were and are not influenced by the shift in the URL path from /complex dashboard to /complex dashboard/archived. When you reload the page, however, Next.js looks for a default .tsx file in each unmatched slot. This file is critical as it serves as a fallback to render content when the framework cannot retrieve a slot's active state from the current URL. Without the file, you will get a 404 error. That is exactly what happens if you reload /complex-dashboard/archived. Page not found, could not find requested resource. We don't have a default .tsx file in the children, users, or revenue slots. Let's go back to VS Code and fix this by adding the missing file. Now the files can either mirror your page.tsx content or show something completely different. It is up to you. In our case, we will keep it simple and copy the content from page.tsx. For our complex dashboard, we need to add 3 default .tsx files to prevent 404 errors when reloading the page. First is for the children slot. Define default.tsx within the complex dashboard folder. This will serve as the fallback view for the children slot. Copy the contents from page.tsx and paste it. You can rename the component as well as change the heading. Completely up to you. Next, define default.tsx inside the user slot. So within @users folder, default.tsx, and this will serve as the fallback view for the users slot. So copy page.tsx content and paste it. I'll just change the card text to user analytics default content. Finally, define default.tsx in the revenue folder. I'll copy page.tsx content and leave it as it is, no change. This will serve as the fallback view for the revenue slot. Once these are in place, reloading localhost 3000/complex-dashboard/archived works perfectly. The notifications slot shows the archived content as it is the only slot with a component defined for the /archived route. This folder right here. The other slots show the respective default.tsx content as fallbacks. So complex dashboard default, user analytics default content, revenue metrics, which we didn't change. So reload complex dashboard, navigate to archived, children, user, and revenue remains the same. Reload, and we render the default content. This setup ensures you don't accidentally render a route that shouldn't be parallel rendered. If you're having trouble with this, please try restarting the development server. Alright, we have now covered how parallel routes allows you to simultaneously render multiple pages in the same layout. Next, we will explore how parallel routes allows for conditional rendering of pages within the same layout. In our previous exploration of parallel routing, we learned how to display multiple pages simultaneously in the same layout without changing the URL. Now, let's explore conditional routes, another powerful feature that parallel routes enable. Imagine you want to show different content based on whether a user is logged in or not. You might want to display a dashboard for authenticated users, but show a login page for those who are not. Conditional routes allow us to achieve this while maintaining completely separate code on the same URL. Let me show you how to implement this scenario. Let's start by creating our login slot. First, in the complex dashboard folder, create a new subfolder called @login. Inside this folder, create a page.tsx file. We'll keep the component simple. You can copy a component from another slot, for example, users, paste it here, and rename it to login slot. Change the text to please login to continue. In a real application, this would be where you would implement your login form, but this placeholder text works fine for our demo. Now head back to the layout.tsx file and add the login slot to the props. So login, and then login of type react.reactNode. For the JSX, we will create a simple auth check. Add a constant called isLoggedIn and set it to false. In a real application, you would typically use something like getUser or useAuth to check the authentication status, but we'll keep things simple here. Based on the value of isLoggedIn, let's conditionally render the UI. So return isLoggedIn, then what we already have, else the login slot. When you check the browser, you should see the login slot since we set isLoggedIn to false. If you're not seeing the change, try restarting your dev server, npm run dev. Refresh, and we see the card, please log in to continue. Switch the value of isLoggedIn to true, and you will see all the other slots appear. This shows how parallel routes conditionally render different pages while maintaining clean, separated code under the same URL. The login slot also benefits from independent error and loading states, as well as subnavigation to a possible sign-up or forgot password route. The app router in Next.js introduced two advanced routing patterns. We've already learned about parallel routes. Now let's dive into intercepting routes. Let's tackle this in two parts. First, we will understand the core concepts and conventions. Then we will see how to put them to practical use. Intercepting routes is an advanced routing mechanism that allows you to load a route from another part of your application within the current layout. It is particularly useful when you want to display new content while keeping your user in the same context. To help understand better, let me give you a couple of real-world examples. Consider a login flow. Typically, clicking a login link would take you to a new page. But with intercepting routes, you can display a modal instead while still updating the URL to /login. This means sharing that URL or refreshing the page still works as expected, showing the full login page. Or consider a photo gallery. Instead of jumping to a dedicated photo page when someone clicks an image, you can show a modal with the enlarged photo and details like the photographer's name and location. The URL updates to match the specific photo, making it shareable. Accessing that URL directly will show the photo's full page. Of course, defining intercepting routes in a Next.js application involves certain conventions. Let's dive into VS Code and understand them through examples. We will start by setting up our folder structure. In your app folder, create a new folder named F1, short for folder 1, with a page.tsx file containing a simple React component. Page.tsx, export default function F1 that returns an H1 tag F1 page. Inside F1 folder, let's create another folder, F2, with its own page.tsx. So F2/page.tsx. Here, export default function F2, return an H1 tag that says F2 page. Next, let's update our F1 component to include a link to F2. So import link from next/link. And for the JSX, add a div tag with the link component pointing to F2. href is equal to /F1/F2. Remember, F2 folder is nested inside F1 folder. In the browser, when you visit localhost 3000/F1, you will see the F1 component with a link to F2. Clicking this link will take you straight to /F1/F2. We see the JSX F2 page. Let's change this behavior with an intercepting route. To understand intercepting routes conventions better, let's think about two key elements, the source folder and the target folder. We want to intercept the F2 route when navigating from F1 route. So F1 is our source folder and F2 is our target folder. Let's start by creating a new folder in our source folder. This will be our intercepting route. The folder name needs to match our target folder, F2. But we need a special prefix to make it work. For now, I'll just add intercepted hyphen as a placeholder while I explain the actual prefix we need. The prefix we use is super important because it tells Next.js where the target route is located. Notice how both F2 and intercepted F2 are at the same level in our folder structure. When we want to intercept a route at the same level like this, we use a dot inside parentheses notation. So let's replace intercepted hyphen with parentheses with a dot inside. Inside this folder, we'll create a page.tsx file with a React component that shows our intercepted content. So export default function intercepted F2. We return an H1 tag with the prefix and text that says intercepted F2 page. Restart the dev server with npm run dev and navigate to /F1 in the browser. Click the F2 link. The URL updates to /F1/F2 but shows the intercepted content. Refreshing this page, loads the original F2 page instead. This is the idea behind Intercepting Routes. It lets you show alternate UI while preserving context, but defaults to the standard UI on direct page loads. The first convention you need to know about intercepting routes is pretty straightforward. We use a dot within parentheses to match segments that are at the same level in your folder structure. This is similar to relative path convention, where we use a dot to refer to the current folder. Now what if you want to intercept something that is one level up? No problem. We just use two dots within parentheses as the prefix, similar to how we use two dots to refer to the parent folder in relative path convention. Let me show you what I mean with an example. Let's create a new folder called F3 in our app directory. So within app, new folder, F3. Create a page.tsx file with a simple React component. Export default function F3 that returns an H1 tag F3 page. Now head over to page.tsx in the F1 folder and add a link to F3. The text is F3 and the href/F3. When you try this in the browser, clicking this F3 link takes you straight to /F3. This renders F3 page. But let's make it more interesting by intercepting this route. For this example, our source folder is F1, where we are navigating from, and our target folder is F3, where we want to go. So inside the source folder, F1, we'll create a new folder that matches our target folder name, F3. So new folder, F3. We need a special prefix to make it work, but I will just add intercepted hyphen as a placeholder while I explain the actual prefix we need. Since F3 is one level above where we are in the folder structure, we'll use dot within parentheses as our prefix. Kind of like when you use // to go up one folder in file paths. Inside this folder, let's create a page.tsx file with a component that shows we have successfully intercepted the route. So page.tsx, and default export a function called intercepted F3 that shows the prefix as well as the content intercepted F3 page. Give your dev server a quick restart, npm run dev, and now in the /f1 route, when you click that F3 link, the URL still shows /f3, but you will see our intercepted content instead. If you refresh the page, you'll get back to the original F3 content just as you would expect. Hopefully, the convention is starting to make sense. Now, let's see how to match segments that are two levels above in our folder structure. Let's start by creating a new folder called F4 in our app directory. Inside it, we'll add a simple page.tsx file. Export default function F4 and return an H1 tag that says F4 page. For this example, we're going to intercept the F4 route when navigating from F2. So let's add a link to F4 in our F2 page. Import link and invoke it to navigate to F4. href is going to be /F4. If you try this in the browser, by navigating to /F1/F2 and clicking on F4, it takes you directly to /F4 and you see the F4 page content. But we are going to change that behavior. For this scenario, our source folder is F2, where we are navigating from, and our target folder is F4, where we want to go. Inside the source folder F2, we'll create a new folder that matches our target folder name, F4. We need a special prefix to make it work, but I will just add intercepted hyphen as a placeholder while I explain the actual prefix we need. Since F4 sits two levels above where we are in the folder structure, we will use parentheses with two dots and another set of parentheses with two dots. This is our prefix to go up two folders. Inside the folder, let's create a page.tsx file with a component that shows we have successfully intercepted the route. So export default function intercepted F4, the prefix, and the content. Now, give your dev server a quick restart, npm run dev, and try it out. When you load /f1/f2, you should see the link to f4. Click the link, and you will see our intercepted content instead of the original f4 page. If you refresh the page, you'll get the regular f4 route UI back. This is exactly what we want with intercepting routes. This double parentheses with 2 dots inside convention is super useful when you need to intercept routes that are multiple levels up in your folder structure. Think of it like using ... in regular file paths. It is the same concept, just adapted for Next.js routing. So that is our third intercepting routes convention. Next, let's look at the final convention for intercepting routes, using 3 dots within parentheses to match segments from the root app directory. First, let's create a new folder called F5 in our app directory, F5, and add a page.tsx file with a simple React component. Export default function F5, and we return an h1 tag F5 page. Next, inside our F2 folder, we will create an inner F2 folder with a page.tsx that includes a link to F5. So the folder name is inner F2 with a page.tsx file that default exports a React component with a link to /f5. In the browser, navigate to /f1/f2/inner F2, and you'll see the link to F5. Clicking it currently takes you directly to the F5 route, /f5. But what if we want to intercept this route? In this case, our source folder is inner F2, where we are navigating from, and our target folder is where we want to go. Inside source folder, inner F2, we will create a new folder that matches our target folder name, F5. We need a special prefix to make it work, but I will just add intercepted hyphen as a placeholder while I explain the actual prefix we need. Since F5 lives multiple segments above our current position, we can use a special convention, parentheses with 3 dots inside. This tells Next.js to match segments starting from the root app directory. So from the root app directory, there's a folder F5. Let's create our intercepting route with a page.tsx file. Export default function intercepted F5, and we return an h1 tag with the prefix and the content. Now, when you restart the dev server, npm run dev, and navigate to /f1/f2/inner F2 and click the F5 link, you will see our intercepted route instead of the original F5 page. But if you refresh, you'll get the regular F5 route back exactly as we want. This is the fourth convention, using 3 dots within parentheses to match segments from the root app directory. So, to wrap things up, intercepting routes give you this powerful ability to show content from another part of your app while keeping your user in their current context. And this slide here is a quick cheat sheet of the conventions we have covered. I know intercepting routes can feel a bit complex at first, and that is totally normal. Up next, we'll look at a practical example that should make all of this click. We have recently explored parallel routes and intercepting routes, 2 powerful routing patterns in the app router. Now, let me show you how these patterns work together through a practical example. Remember this photo feed example I mentioned earlier? I'll demo this and break down the code to help you understand how it all works. Let's start with the demo. At localhost 3000/photo-feed, you will see an image feed showing the 7 new wonders of the world. Click any image, and a modal appears with an enlarged version of that image, along with details like the name, photographer, and location at the bottom. What's happening here is really interesting. We're looking at a parallel route that has been intercepted. While the URL changes to /photofeed plus the image ID, what you are seeing is a parallel intercepted route rendering within the same layout with the photo feed visible in the background. This is crucial because without the modal parallel route, clicking a photo would completely replace the page content instead of showing an overlay. And here's something even cooler. Normally, with modals, hitting the browser's back button would take you to the previous page instead of closing the modal. But parallel intercepting routes solve this elegantly. Notice how the back and forward browser buttons smoothly open and close the modal. And here is another neat feature. If you share the URL with someone or just refresh the page, it loads the photo details on a fresh page. This makes parallel intercepting routes perfect for modals. You can apply the same principle elsewhere too, like having a login button that opens a modal, but accessing /login directly shows you a full login page. Now that you've seen it in action, let me walk you through the steps to create this. You'll find all the code in the photo feed folder in my GitHub repo, and the modal component is defined in components folder. Step 1, gather your images and put them in a photos folder inside the photo feed folder. We have 7 images. Step 2, create a TypeScript file to import these images and organize them into an array with metadata. Each wonder in our array needs an ID, name, source, photographer, and location. Step 3, set up a page.tsx file in the photo feed folder to display your image list using the wonders array. I went with Tailwind CSS for styling, but use whatever styling you prefer. Wrap each image in a link component pointing to /photo feed followed by the image ID 1 through 7. This page creates your main photo feed at localhost 3000/photo feed. Step 4, create your photo details dynamic route. Inside the photo feed folder, add an ID dynamic route. This route grabs the ID parameter, finds the matching photo from the wonders array, and displays its details: photo name, image source, photographer name, and location. When someone visits /photo feed /ID, like 2 for Petra, they'll see the wonder details. Now for the crucial part. Step 5 is intercepting navigation between the feed and details. Since we want a modal overlaying the feed, we'll start with a parallel route. Create a modal as a parallel route in the photo feed folder and include it in layout.tsx, props.modal. This @modal route is special because it enables simultaneous rendering. Both the feed content and the modal can exist on the screen at the same time. For interception, modal parallel route is the source and the ID route is the destination. So inside the modal source folder, add a new folder that matches the destination folder name. In this case, it is ID dynamic route. Since modal is a parallel route, a prefix needs to be dot within parentheses to match the same level. Within this folder, create a page showing photo details similar to the main dynamic ID route. I moved photo name from the top to the bottom to demonstrate how you can have different UIs for each route. Step 6. Add a default.tsx file to the modal parallel route folder. This file is used to render the modal content when the route is first loaded. We simply return null. Now here is what happens behind the scenes. When you first load /photo feed, Next.js renders both the modal route, which starts empty thanks to default.tsx, and the main content present in page.tsx. Then, when you click an image, the modal route intercepts the navigation to /photo feed /ID. This displays the modal overlay while keeping your main photo feed visible underneath. When you reload the page, there is no interception, and the ID dynamic route is rendered instead. I hope this example helps you understand how parallel intercepting routes work together. Alright, this wraps up page-based routing in Next.js. We will dive into route handlers. Previously, we have learned how to route to pages with the file-based routing system. While that is already a powerful feature, the app router can do even more. It lets you create custom request handlers for your routes using a feature called route handlers. Unlike page routes, which give us HTML content, route handlers let us build RESTful endpoints with complete control over the response. Think of it like building a Node plus Express app. You can perform all your CRUD operations with a database, but here is the cool part. There is no need to set up and configure a separate server. Next.js gives you everything right out of the box. Route handlers are great when making external API requests as well. For example, if you're building an application that needs to talk to third-party services, route handlers are perfect for that. Since they run server-side, your sensitive information, like private keys, stays secure and never reaches the browser. If you're coming from Pages router, you can think of route handlers as API routes. Next.js supports get, post, put, patch, delete, head, and options. If an unsupported method is called, Next.js will return a 405 method not allowed response. Let me show you how to build your first route handler. I've got VS Code open here, and I've started by creating a fresh Next.js project using the command npx create next app at latest route handlers demo. Once the command completes, you should have a project that looks like mine. Let's head into the source folder. First up, we will create a new folder called Hello inside the app folder. Just like page routes, route handlers must live in the app folder. Inside this Hello folder, we'll create a file called route.ts. That's another Next.js convention we need to follow. Here, we will export a function that matches the getHTTP verb. And yes, that's another convention. Export async function get. We'll keep this simple and return a plain text response. Return new response, hello world. We're using the standard JavaScript response object here to handle our incoming request. We return a new response with hello world as text. In the browser, navigate to localhost 3000/hello, and you will see our text response, hello world. And just like that, we've got our first route handler up and running. That is really the core idea of route handlers. In the app folder, create a route.ts file and export functions named after HTTP verbs. In this case, when someone makes a GET request to /hello, our GET handler jumps into action. Now, there are two important things to keep in mind. First, route handlers are super flexible with organization. So just like page routes, you can nest them in folders and subfolders to keep everything tidy. For instance, you could add a dashboard folder in your app directory with its own route handler. So create a new folder, dashboard, and copy over route.ts from hello folder, but change the text to dashboard data. If you want user-specific stuff, create a user's subfolder inside dashboard with another route handler returning user data. So copy, paste it, and change the text to user data. Now in the browser, you can hit /dashboard for dashboard data and /dashboard/users for user data. Very straightforward. Second, watch out for conflicts between page routes and route handlers. Here's what I mean. Say you have a page route profile/page.tsx in the app folder. So profile/page.tsx with a simple export default function profile page, and we return a div tag profile page. In the same folder, let's say you've got a route handler route.ts. You have a get handler function that returns a new response profile API data. In this case, the route.ts will take over by default. So when you visit localhost 3000/profile, you will see profile API data instead of your page component. The fix is to move your route handler to an API subdirectory. So within profile folder, create an API folder and move route.ts within that folder. So profile/route.ts becomes profile/API/route.ts. Now you can have both your page at /profile and your API at /profile/API. To summarize, route handlers allow you to create custom request handlers for a given route. They are defined in a route.js or route.ts file inside the app directory. A route.ts file at the same route segment level as page.tsx will result in a conflict and the page will not be served. The route handler will handle the request. Now that you've got the basics down, let me walk you through some hands-on examples of handling get, post, patch and delete requests with Next.js route handlers. Previously, we learned how to create a basic route handler. Now, let's dive deeper into working with route handlers, starting with how to handle GET requests. Before we begin, I should mention that we won't be focusing on the UI for this section. Instead, we will use Thunder Client, a REST API client for VS Code to test our route handlers. If you haven't already, go ahead and install the Thunder Client extension in VS Code. Once you have it ready, we can proceed. To keep things focused on route handlers, we will skip setting up a database. Instead, we will store our data in memory, which means it will be cleared when we restart the app or refresh the page. That is perfectly fine, since our main goal is to understand how route handlers work. Let's start by creating some data to work with. First, create a new folder called Comments inside your source folder. Inside this folder, create a file called data.ts. And here, I'll paste an array of 3 comments we will use. Think of these as comments on a YouTube video, each with a unique ID and some text. Now that we have our data ready, let's create our route handler. In the same comments folder, create a new file called route.ts. Remember, this is a Next.js convention for creating route handlers. In this file, we will define and export our getHandler function. We start by importing our comments array from the data file. So import comments from /data. Then we export a function called get. Export async function get. This getHandler simply returns our comments array as a JSON response. Return response.json and we pass in comments. Now let's test this handler. Open Thunder Client extension and click on New Request. Set the HTTP method to get and enter the URL localhost 3000/comments. Leave all the other settings as they are. When you click Send, you should see a status 200 OK response with our array of 3 comments. ID 1, first comment, ID 2, second comment, and ID 3, third comment. Perfect. The getHandler is working exactly as expected. Now we are using Thunder Client for testing, but in a real application, your user interface would make this request either when the page loads or when the user interacts with it. The important thing is that we have successfully created a get route handler in Next.js. Up next, we will explore how to handle post requests. Previously, we learned about handling get requests. Now, let's explore how to handle post requests. Let's start with Thunder Client. We'll keep our previous get request and create a new request. First, select post as the HTTP verb. Next, copy over the URL, http localhost 3000/comments. Next, we need to specify a new comment object to add to our comments array. Head over to the body tab and under JSON, add an object. The key, in quotes, is text, and the value is new comment. Notice how we are not specifying an ID. That will be generated by our handler function. When we click Send, we get a status 405 error, method not allowed. Let's fix that by adding a handler for this post request. Going back to our route.ts file in the comments folder, we will define and export a new function. Export async function post. Remember, it is crucial that our function name matches the HTTP verb we want to handle. Each route handler function gets a standard web request object as a parameter. Request of type request. We extract the JSON body from this request by calling and awaiting request.json. This gives us the object we have specified in Thunder Client. Let's store it in a constant called comment. Then we create a new comment object. So const new comment is equal to an object. We set the ID to the current length of our comments array plus 1. So comments dot length plus 1 and use the text from our request body. So text is comment.text. We add this new comment to our comments array using push. comments.push, new comment. Now for the response, we could use response.json, but that would give us a 200 status code. Since we are creating a new resource with our post request, a 201 status is more appropriate. So return new response, passing in our new comment as JSON. So JSON.stringify, new comment, setting the content type to application/JSON in headers, and using status code 201 to indicate successful resource creation. Back in Thunder client, when we hit send now, we get a 201 created status and a new comment as the response, ID 4, text new comment. If we switch to our get request tab and hit send again, we will see all 4 comments, including a new one. And that is the essence of handling post requests. Define your post handler, process the request body, and send back an appropriate response. Please note that any changes to comments will only exist in memory and won't be saved to file system. Our comments array will still contain only 3 comments. Alright, now that we have got this down, let's move on to exploring dynamic route handlers. We have covered creating route handlers for GET and POST requests. Now let's tackle patch and delete requests, which work a bit differently since they require specifying which comment to update or delete. While our /comments route handler handles GET and POST requests, patch and delete requests need an endpoint like /comments/ID, where the ID is a dynamic segment. It could be 1, 2, 3, or any valid ID from our comments array. So first, let's learn how to create a dynamic route handler that returns a single comment based on its ID. This will set us up nicely for handling patch and delete requests later. You will be pleased to know that dynamic route handlers follow the same pattern as dynamic page routes. So to create a route handler for /comments/ID, first we will create a new folder called ID wrapped in square brackets within the comments folder. So new folder within square brackets, ID. Then we'll add a route.ts file inside it, route.ts, and define our get handler function. Export async function get. Inside this function, we need to fetch a specific comment that matches the route's ID parameter. First, we will import the comments array that contains our data. So import comments from data. Next, we need to access the ID route parameter. And as it turns out, the handler function takes 2 parameters. First is a request object, which we are already familiar with. Second is a context object containing the route parameters. So params of type promise, which contains our ID route parameter of type string. Now we are only interested in the context, so prefix the request object with an underscore. Within the function body, await the promise and destructure the ID property from the params object. So const ID is equal to await params. Using this ID, we search through our comments array to find the matching comment. So const comment is equal to comments.find, and for each comment, we check if its ID matches the parameter ID. So parse int ID. Once found, we send it back to the client as a JSON response. Return response.json comment. Let's test this in Thunder client. In the tab where we are making a GET request, let's append /1 to the URL and hit send. We get a 200 OK status, and the comment with ID is equal to 1. Try /2, send, and we get the second comment. Same with /3 for the third comment. The URL parameter determines which comment we retrieve. While we are only working with 3 comments here, in the real application, you might have thousands of database records, but the logic remains the same. Extract the ID from the parameters, find the data corresponding to that ID, and return as JSON. But now that we understand dynamic route handlers, let's move on to handling patch requests for updating individual comments. Let's learn how to handle patch requests. A patch request lets us make partial modifications to a resource. Since we are only working with a single property called text, updating a comment will be pretty straightforward. First, let me show you what a patch request looks like in Thunder Client. We'll start by changing the HTTP verb from get to patch. We will keep the same URL since we are updating the comment with ID 3. In the body tab, under the JSON section, we will add an object with the text property set to a different string, updated comment. When we hit send, we get a status 405 method not allowed. Let's fix that by adding a handler for patch requests. In our route.ts file inside the ID folder, we will create a new route handler function, export async function patch. This function receives two parameters, request and context. I will copy the parameters from our getHandler function. Inside the function, we first destructure the ID by awaiting params. Next, we get the JSON body from the request using await request.json. We assign it to a constant called body. Now we are using request, so let's remove the underscore from our parameter. Next, from body, we destructure the comment text. To find the comment we want to update, we can use either array.find or findIndex. I'm going with findIndex since we will need it for delete operations later. So const index is equal to comments.findIndex, comment such that comment.id is equal to parseInt, the ID parameter. Once we find the comment, we simply update its text property. So comments of index.text is equal to the text from the request. Finally, return the updated comment as a JSON response. Return response.json comments of index. Now, heading back to Thunder Client and hitting send, we get a 200 status code with our updated comment in the response, ID 3 text updated comment. If we make a GET request from the same tab to /comments, we can see our updated comment in the array, ID 3 text updated comment. This is how we handle patch requests in route handlers. Please note that any changes to comments will only exist in memory and won't be saved to the file system. In data.ts, you will continue to see the original text for comment ID 3. Up next, we will look at handling delete requests. Let's learn how to handle delete requests. A delete request, as the name suggests, removes a specified resource. In our case, we will be deleting a comment using its ID. First, let's see what a delete request looks like in Thunder Client. We will start by changing the HTTP verb from patch to delete. The URL structure stays the same since we will still need the comment ID in the URL, /3. For this example, we will delete the comment with ID 3. We can remove the body JSON since it's not needed for delete requests. When we hit send, we get a status 405 error, method not allowed. Let's fix this by adding a handler for the delete request in our API route. In our route.ts file within the ID folder, let's add a new route handler function. We will create an async function called delete that takes two parameters, request and context. These are the same parameters we have seen before for both patch and get requests. We get hold of the ID route parameter by awaiting params. Next, we will use array.findIndex to locate the comment we want to delete. Let's copy the line from our patch function. So const index is equal to comments.findIndex. Find the comment such that its ID is equal to the ID route parameter. Before deleting the comment at the given ID, we store it in a variable so we can return it later. So const deleted comment is equal to comments of index. Then we use array.splice to remove the item. So comments.splice at index one item. And we finally return response.json passing in the deleted comment. Let's test this in Thunder Client. Hitting send now gives us a 200 status code and shows us the deleted comment in the response. ID 3, text, this is the third comment. And if we make a GET request from the same tab to just /comments, you will notice the comment with ID 3 is no longer present in the array. We just have 2 comments. So that is how we handle delete requests in route handlers. Please note that any changes to comments will only exist in memory and won't be saved to the file system. In data.ts, you will continue to see the third comment. Now that we have covered get, post, patch, and delete requests, let's proceed to understand some additional related topics. Let's learn how to work with URL query parameters in route handlers. In our data.ts file, we have an array of 3 comments. Now, imagine we want to filter these comments based on a search term. For instance, when you visit localhost 3000/comments, you will see all 3 comments. But what if you want to see only comments containing the word first by going to /comments, query is equal to first. Let's jump into VS Code and see how to make this happen. In route.ts, present in the comments folder, we have defined our getHandler function, which returns the array of 3 comments. This is the route handler we need to modify. First up, we need to work with the request parameter. While we've been using the standard request API until now, in the context of Next.js, the type we are actually dealing with is next request. Import it at the top from next/server and specify the type in the getHandler. This next request object provides convenient methods for managing query parameters with ease. Let's update our code. Within the function body, we grab all query parameters using request.nextURL.searchParams and store them in a constant called searchParams. Then we use the get method to fetch our specific query parameter. So const query is equal to searchParams.get query. If there is a query parameter, we filter the comments to only include those containing the search term. So const filtered comments is equal to query, if it exists, comments.filter, and filter comments such that they include the query parameter. If there is no query present, respond with the original comments array. Finally, send back the filtered comments as JSON. Let's test it out in the browser. Navigate to localhost 3000/comments, and we continue to see the 3 comments. Now specify query is equal to first, and you will see just the first comment. Try changing the query parameter value to IR, and you'll get both the first and third comments since both contain IR. In case you're wondering how to work with multiple query parameters, you can access them individually using searchParams.get, passing in the parameter name. Very straightforward. But this is how you work with query parameters in route handlers. They're optional, but they're absolute gold for adding powerful features like search, sorting, and pagination to your applications. Let's dive into handling headers in route handlers. We will start with the basics of what headers actually are. HTTP headers represent the metadata associated with an API request and response. This metadata can be classified into 2 main categories. First, we have request headers. These are sent by the client, such as a web browser, to the server. Request headers contain essential information about the request, which helps the server understand and process it correctly. For example, we have user agent, which identifies the browser and operating system to the server. It is often used for browser-specific content rendering and analytics. We have accept, which indicates the content types like text, video, or image formats that the client can process. It enables the server to deliver the resource in a format suitable for the client. Another common request header is the authorization header used by the client to authenticate itself to the server. It carries credentials, allowing controlled access to resources. Second, we have response headers. These are sent back from the server to the client. They provide information about the server and the data being sent in the response. An example is the content type header, which indicates the media type of the response. It tells the client what the data type of the returned content is, such as text/HTML for HTML documents, application/JSON for JSON data, etc. When you're working with route handlers in Next.js, you will need to know how to both read request headers and send back response headers. Let's head over to VS Code and understand with an example. Now we will use the profile route handler we built earlier. Open route.ts present in the API folder. We have a get handler that returns a new response profile API data. I'm going to open Thunder client extension, make a new request to http localhost 3000/profile/API. By default, the request has two headers, accept and user agent. Let's add a third one, authorization, and we can set the value to a bearer token. Bearer 12345. Now the question is, how do we read these headers in our route handler? Well, we've got two options. The first one is using the request parameter. At the top, import type next request from next/server and specify the parameter with its type. Request of type next request. Within the handler function, we use the headers web API to extract the request headers. So new headers, and we pass in request.headers. We store it in a constant called request headers. In the next line, we will use the get method on request headers and log the authorization header to the console. So console.log request headers.get the authorization header which we have just specified. If we send a request from Thunder client, open the terminal, we should see our bearer token authorization header. The value is bearer followed by 12345. While this first option works completely fine, you can also choose to use the headers function that Next.js provides. At the top, import headers from next/headers. And within the function body, we invoke the headers function and store the result in a request headers constant. So const header list is equal to await headers. Headers is an async function, so we will need to await it. We then access the authorization header using the get method and log it to the console. Console.log headerslist.get authorization. Resend the request with a different token value, 1234567, and check the terminal. We can see the latest bearer token is logged. So this is how you read headers from an incoming request. Now let's talk about setting outgoing headers. Here's something important to know. The headers returned from the headers functions are read-only. To set new headers, you will need to return a new response with your custom headers. Let me show you an example. If you access this route in your browser, /profile/API, you will see profile API data in plain text. Check the network tab and you will notice the content type is text/plain. So if we wrap our text in an h1 tag and refresh, it will still show up as plain text. But watch what happens when we set the content type to text/HTML. So return new response. As a second argument, we specify headers and content type is text/HTML. Refresh your browser, and now you've got properly styled h1 text, profile API data. The browser renders it differently because we told it to expect HTML through the response header, content type text/HTML. The takeaway is that to set headers, you need to return a new response with custom headers. Using the request and response headers, you can implement whatever logic you need to in your route handler. Previously, we learned how to work with headers in route handlers. Now, let's dive into handling cookies in route handlers. Cookies are small pieces of data that a server sends to a user's web browser. The browser can store the cookies and send them back to the same server with future requests. Cookies serve three main purposes: managing sessions like user logins and shopping carts, handling personalization such as user preferences and themes, and tracking like recording and analyzing user behavior. If you would like to dive deeper into cookies, you can check out the detailed documentation on MDN. But for now, let's head back to VS Code and see how we can work with cookies in the Next.js route handler. Similar to what we saw with headers, we will primarily look at how to set and get cookies inside a route handler. There are two ways to accomplish this. The first approach is to set a cookie by returning a new response with the set cookie header. So after content type text/HTML, specify set cookie, theme is equal to dark. If we check Thunder Client and look at the cookies tab in the response section, we have no cookies available. It starts empty. With our set cookie logic in place, if we make a new request, we will see our theme cookie appear. Name theme, value dark. Now to read this cookie in our route handler, we can use the request parameter. So const theme is equal to request.cookies.get, and we specify the name of the cookie, theme. Let's log it to the console. Back in Thunder Client, if we send the request and open the terminal, we will see the cookie name-value pair being logged. Name theme, value dark. So this covers our first approach, using the set cookie header to set a cookie and the request object to read it. For the second approach, Next.js provides a built-in cookies function. Let's import it at the top. Import headers, cookies from next/headers. Cookies is an async function, so we will need to await it. Within the handler function, const cookie store is equal to await cookies. Now, to set a cookie using this method, we can call cookiestore.set. We specify the name, results per page, for example, and the value is 20. After sending a new request, a cookie results per page now appears with a value of 20. Reading this cookie is just as straightforward with cookiestore.get. So console.log cookiestore.get results per page. Send the request again, and in the terminal, you will see name results per page value 20. Apart from set and get, the cookies function supports additional methods like has and delete. Please refer to the docs for more information. All right, that wraps up working with cookies in route handlers. Let's quickly talk about handling redirects in route handlers. Imagine you've built a user's API that's been running for a while. Your V1 endpoint has basic user information like ID, email, full name, and created at. After a few months, you've built a more comprehensive V2 endpoint that includes structured names, user preferences, and profile data. To move clients to this new endpoint, we can set up a redirect in V1. So in V1 route.ts, import redirect from next/navigation, and within the getHandler function, call redirect, passing in the new path /API/v2/users. In the browser, when clients hit /API/v1, they'll receive a 307 temporary redirect to /API/v2/users. This works smoothly because all V1 fields are preserved in V2. New fields are purely additive. Existing clients can keep using the same fields they've always used, and new clients can take advantage of the enhanced data structure. It also gives us a chance to clean up any loose ends in V1 before fully switching over. All right, up next, we will look at caching in route handlers. For the final detail about route handlers, let's talk about caching. While route handlers in Next.js aren't cached by default, you can opt into caching when using the get method. Let me show you how this works. Let's create a new folder called time in our app directory and add a route.ts file. So time/route.ts. Here is a simple get handler. This endpoint returns the current time in JSON format. If you navigate to localhost 3000/time in the browser, you will see the current time in hours, 11:45:43 a.m. Each reload will show you the latest time since there is no caching by default, And this is exactly what we want in this case. Now, let's look at a scenario where caching makes perfect sense. Within the app folder, create a new folder called Categories with a route.ts file. Define and export a getHandler function. So export async function get, and we have an array of 4 categories, each with an ID and a name. We return the array in JSON format. We've hardcoded the categories data for simplicity, but in a real-world scenario, this data would typically come from a database. Since this data rarely changes, every request to this endpoint will trigger a database query, which is inefficient. To avoid this, we can use caching. We'll add a configuration option at the top of the file. Export const dynamic is equal to force static. This ensures that the response is cached and served instantly to all users. However, we can't test this route handler because there is no dynamic data in this response. Let's add the same configuration to the time route handler and test that instead. Export const dynamic force static. Now, navigate to /time in your browser. You will see the current time, 11:49:31 a.m. If you reload the page, you will still see the time change. This is because there is no caching during development. Let's build the app using npm run build and start it using npm run start. Now navigate to /time. The time is 11:49:58 a.m. The time remains the same on reloads. Refresh, and you can see the time does not change. This time refers to the time when the app was built. If you come back to the browser and navigate to /time after 10 minutes, you will still see the same time. It changes only when the application is rebuilt. But what if we want to update our data without rebuilding the entire application? Well, you can revalidate cached data using incremental static regeneration. At the top of the file, we will add export const revalidate is equal to 10. This will revalidate the data every 10 seconds. When you run npm run build, the route handler code is generated with the time of the build. When you run npm run start, all requests made to /time are cached and instantaneous. After 10 seconds has passed, the next request will still show the cached stale page, while a new version of the code is generated in the background with the latest timestamp. Now, when you reload again, the updated timestamp is shown for the next 10 seconds, and this process repeats. This is how you revalidate cached route handlers in the app router. It is worth noting that caching only works with get methods. Other HTTP methods like post, put, or delete are never cached. Additionally, if you're using dynamic functions like headers and cookies, or working with the request object in your get method, caching won't be applied. I hope this gives you a good understanding of how caching works in route handlers. We have one final topic to cover in this section, so let's keep going. For our final topic on routing in Next.js, let's learn about middleware. Middleware in Next.js is a powerful feature that lets you intercept and control the flow of requests and responses throughout your application. It does this at a global level, significantly enhancing features like redirects, URL rewrites, authentication, headers, cookies, and more. Let's jump into VS Code and see how to implement middleware in our application. Creating middleware in Next.js is straightforward. Just add a middleware.js or .ts file in your source folder. Middleware.ts. Now, middleware lets you specify paths where it should be active with 2 approaches: custom matcher config or conditional statements. Let's explore both approaches using redirection as an example. Imagine a scenario where navigating to /profile should redirect the user to the home page. Here's how we can achieve this. We start by importing Next response from Next/server, which extends the standard response API. We also import Next request type from Next/server. Next, we define a middleware function that accepts a Next request type request. So export function middleware accepts request of type Next request. This function redirects to the home page when /profile is accessed. So return next response.redirect new URL, and the path is the home page. We also pass in request.url. We then use a config object to tell Next.js to only apply this middleware to the /profile route. So export const config is equal to an object where we specify a matcher /profile. Let's restart the dev server with npm run dev. Now, when you navigate to /profile in the browser, it automatically redirects to the home page, showcasing the matcher config approach. Now, let's look at the second approach using conditional statements. We'll keep the imports, but comment out the function body and the config object. Instead, we will type if request.nextURL.pathname is equal to /profile return next response.redirect new URL, and let's specify the path as /hello, and we pass in request.nextURL. Now, when you visit /profile in the browser, it will redirect to our /hello route, which we created a while ago. This shows how we can use conditional statements to control middleware responses based on the request path. Beyond redirects, middleware also supports URL rewrites, a feature perfect for handling legacy URLs or improving SEO. Instead of redirect, you can use rewrite to keep the URL in the browser unchanged while serving different content. Now navigate to /profile, and you will see it is redirected to /hello. So we see hello world, but the URL in the browser is still /profile. Finally, let's explore the use of cookies and headers in middleware. Let's modify our middleware to handle user preferences for themes and add a custom header for all responses. We start by getting our response object that we will eventually return from the function. So const response is equal to next response.next. Then, using the request object, we check if the user has a theme preference stored in their cookies. So const theme preference is equal to request.cookies.get, and the cookie name is theme. So if there is no theme preference, response.cookies.set, the cookie name is theme and the value is dark. Finally, we return our modified response object from our middleware function. So return response. If we go back to the browser and take a look at cookies in DevTools, in the Application tab, you can see they are empty. If we now refresh, you can see the dark theme cookie being set, name theme, value dark. If we manually overwrite the value to light and then refresh, you can see the value is not overwritten to dark. Very simple to work with cookies. Now headers work just as smoothly. Let's add a custom header to the response using response headers set. Name it custom header and set the value to custom value. Go to the network tab and refresh the page. For /profile, under response headers, you will see our custom header with its value. Custom headers are super useful for passing extra information, which can be used by client-side scripts or for debugging. As you can see, middleware can be effectively used to manipulate both cookies and headers. In summary, middleware in Next.js allows you to effectively control and intercept the request-response cycle, enabling redirects, URL rewrites, and the manipulation of headers and cookies. With that, we conclude this first section on routing in Next.js. We've covered a wide array of topics, from basic route definition using pages and layouts, dynamic routes, route groups, linking and navigation, loading and error states, and advanced concepts like parallel routes, intercepting routes, route handlers, and now middleware. I hope you now feel confident working with routing in Next.js. For our next section, we will dive deep into rendering in Next.js. After exploring the ins and outs of Next.js routing in our first section, we are now ready to tackle something equally important in the second section, rendering in Next.js. Rendering might sound complex, but it is actually pretty straightforward. It is a process of transforming the component code you write into user interfaces that users can see and interact with. The tricky part to building a performant application is figuring out when and where this transformation should happen. You've probably heard terms like CSR, SSR, and RSCs being thrown around, and maybe they've left you scratching your head. Don't worry, we're going to break all of this down in a way that makes sense. But before we jump into rendering in Next.js, let's take a step back and look at how rendering works in React itself. Since Next.js is built on top of React, understanding React's rendering model will make everything else click into place. I should mention, we are about to cover quite a few concepts in this section. If something doesn't make complete sense right away, that is totally normal. Feel free to pause and rewatch any part that feels unclear. Trust me, sometimes it takes a couple of passes for these concepts to really sink in. Alright, with this introduction in mind, let's dive into how React handles rendering. To really grasp how rendering works in Next.js, we need to look at how React's rendering has evolved over the past decade. Let's dive into React's different rendering strategies and see how they've changed over time. If you've been around web development for a while, you probably remember when React was primarily used for building single-page applications. When a client visited your website, the server would send back a single HTML page. This page was pretty bare bones, just a simple div tag and a link to a JavaScript file. Let me show you what I mean with an example from Create React App, which was the go-to tool for starting React projects. You get this minimal HTML file with an empty root div tag and a reference bundle.js JavaScript file. This bundle.js is the real powerhouse which contains everything: the React library, your application's code, everything needed to run your application. The browser would download this file as soon as the HTML was processed. Once your browser downloaded all the JavaScript, it would get to work generating the HTML right there on your computer, injecting it into the DOM under that root div element, and that is when you would finally see your user interface. Here's a very simple way to verify this. If you check the DOM inspector, elements, we can see a header with image and h1 and a paragraph tag. But if you view the page source, you'll only see the original bare-bones HTML the server sent over. This whole approach, where your browser, which is the client, transforms React components into what you see on screen, that is what we call client-side rendering, CSR for short. CSR became super popular for single-page applications, and everyone was using it. However, it wasn't long before developers began noticing some inherent drawbacks to this approach. The first big issue was SEO. When search engines crawl your site, they're mainly looking at HTML content. But with CSR, your initial HTML is basically just an empty div tag, which is not great for search engines trying to figure out what your page is about. Plus, when you have a lot of nested components making API calls, the meaningful content might load too slowly for search engines to even catch it. The second issue was performance and user experience. Think about it. Your browser, which is the client, has to do everything: fetch data, build the UI, make everything interactive, and that is a lot of work. Users often end up staring at a blank screen or a loading spinner while all this happens. And here's the kicker. Every time you add a new feature to your application, that JavaScript bundle gets bigger, making users wait even longer. This is especially frustrating for people with slower internet connections. While CSR was indeed game-changing and gave us the interactive web apps we love today, developers knew they needed better solutions for SEO and performance. Up next, we will look at another rendering approach that tackles these CSR limitations head-on. We just covered client-side rendering in React and its two main drawbacks. The first is SEO. Since content relies on JavaScript to render on the client side, search engines often struggle to index it properly. The second is user experience. Users have to wait while their browsers download, parse, and execute JavaScript before seeing any meaningful content. To overcome these drawbacks of client-side rendering, modern React frameworks like Gatsby and Next.js move towards server-side solutions. Let's look at how this changes content delivery. When a request comes in, instead of sending a bare HTML file that needs client-side JavaScript to build the page, The server now handles rendering the complete HTML. This fully formed HTML document goes straight to the browser. Since the HTML is already generated on the server, the browser can quickly parse and display it, giving us faster initial page load times. This server-side approach tackles both CSR issues head-on. First, search engines can now easily index the server-rendered content, solving our SEO problem. Second, users see actual HTML content right away instead of staring at a blank screen or loading spinner. But here's the catch. While SSR makes content visible faster, it introduces its own complexity around interactivity. The page can't become fully interactive until the JavaScript bundle comprising both React itself and your application's code has finished downloading and executing in the browser. This important phase, known as hydration, is where the static HTML page, initially served by the server, is brought to life. During hydration, React takes control in the browser and reconstructs the component tree in memory using the server-rendered HTML as a blueprint. It carefully maps out where all the interactive elements should go, then hooks up the JavaScript logic. Things like initializing application state, adding click and mouse over handlers, and setting up all the dynamic features needed for a full interactive user experience. Understanding hydration is key for what's coming up next, so please make sure you're comfortable with what we have just learned. Diving deeper, server-side solutions can be categorized into two main strategies: static site generation, or SSG, and server-side rendering, or SSR. Static site generation happens during build time when you deploy your application to the server. This results in pages that are already rendered and ready to serve. It is perfect for content that stays relatively stable, like blog posts. Server-side rendering, on the other hand, renders pages on demand when users request them. It is ideal for personalized content like social media feeds, where the HTML changes based on who's logged in. You will often hear both approaches collectively referred to as server-side rendering, or SSR. While server-side rendering was a big step up from client-side rendering, giving us faster initial loads and better SEO, it came with its own challenges. The first issue with SSR is that components cannot start rendering and then pause or wait while data is still being loaded. If a component needs to fetch something from a database or another source like an API, this fetching must be completed before the server can begin rendering the page. This can delay the server's response time to the browser, as the server must finish collecting all necessary data before any part of the page can be sent to the client. The second issue with SSR is that for successful hydration, where React adds interactivity to the server-rendered HTML, the component tree in the browser must exactly match the server-generated component tree. This means that all the JavaScript for the components must be loaded on the client before you can start hydrating any of them. The third issue with SSR is related to hydration itself. React hydrates the component tree in a single pass, meaning once it starts hydrating, it won't stop until it's finished with the entire tree. As a consequence, all components must be hydrated before you can interact with any of them. These three issues, having to load the data for the entire page, loading the JavaScript for the entire page, and hydrating the entire page at once, create an all-or-nothing waterfall problem that spans from the server to the client, where each issue must be completely resolved before moving on to the next one. This becomes really inefficient when some parts of your app are slower than others, as is often the case in real-world applications. These limitations led the React team to develop a new and improved SSR architecture. Up next, we will explore this architecture and see how it solves these traditional SSR problems. Previously, we explored the fundamentals of server-side rendering in React and discovered its main drawbacks. Let's quickly recap the challenges. First, we can't start rendering HTML until all data is fetched on the server. Second, we need to wait for all JavaScript to load on the client before hydration can begin. And third, every component needs to be hydrated before any of them become interactive. These issues create an all-or-nothing waterfall effect that is pretty inefficient, especially when some parts of your application are slower than others. To address these performance drawbacks of SSR, React 18 introduced the Suspense SSR architecture. This new architecture allows you to use the Suspense component to unlock two game-changing SSR features: HTML streaming on the server and selective hydration on the client. Let's explore these two features in detail. As we discussed a minute ago, traditionally, SSR has been an all-or-nothing affair. The server renders the complete HTML, which is then sent to the client. The client displays this HTML, and only after the complete JavaScript bundle is loaded does React proceed to hydrate the entire application to add interactivity. But React 18 gives us a better way. Here is a similar visualization from a user interface perspective. First, you render all HTML. The client eventually receives it. Then, you load all the code and hydrate the entire application. But React 18 gives us a better way. When you wrap something like your main content area in a suspense component, you're telling React, hey, don't wait for this part, start streaming the rest of the page. React will show a loading spinner for that wrapped section while it works on the rest of the page. When the server finally has the data ready for that main section, React streams the additional HTML through the ongoing stream, along with a tiny bit of JavaScript that knows exactly where to position that HTML. The cool part? Users can see the main section's content even before React itself finishes loading on their browser. This solves our first problem. You don't have to fetch everything before you can show anything. If a particular section is slow and could potentially delay the initial HTML, no problem. It can be seamlessly integrated into the stream later when it is ready. This is the essence of how Suspense facilitates server-side HTML streaming. But we still have another hurdle to jump. Even with faster HTML delivery, we can't start hydrating until we have loaded all the JavaScript for the main section. If that is a big chunk of code, we are still keeping users waiting from being able to interact with the page. To mitigate this, code splitting can be used. It lets you tell your bundler, these parts of the code aren't urgent. Split them into separate scripts. Using React Lazy for code splitting is particularly powerful here. It separates your main section's code from the core JavaScript bundle. This means the browser can download React and most of your application's code independently without getting stuck waiting for that main section's code. And here's where things get really interesting. By wrapping your main section in a suspense component, you're not just enabling streaming, but also telling React it's okay to hydrate other parts of the page before everything is ready. This is what we call selective hydration, and it is a game changer. It allows for the hydration of parts of the page as they become available even before the rest of the HTML and the JavaScript code are fully downloaded. From a user's perspective, here's what happens. First, they see non-interactive content streaming in as HTML. Even though the main section's JavaScript code hasn't been downloaded yet, React starts selectively hydrating, and other parts of the page can become interactive. The main section catches up and becomes interactive once its code loads. This is huge because it means a heavy chunk of JavaScript won't hold up the rest of your page from becoming interactive. But it gets even better. Selective hydration also solves our third problem, the necessity to hydrate everything to interact with anything. React starts hydrating as soon as it can, which means users can interact with things like the header and side navigation without waiting for the main content. And the best part, React handles all this automatically. Also, here is something really clever about how React handles hydration. In scenarios where multiple components are awaiting hydration, it prioritizes hydration based on which components users are trying to interact with. Let's say React is about to hydrate the side nav, but the user clicks on the main content area. React will immediately switch gears and hydrate the clicked component during the click events capture phase. This means the component is ready to respond right away. The side nav, it will get hydrated later. So there you have it. React's new Suspense SSR architecture has effectively tackled all three major drawbacks of traditional SSR. But we are not quite done yet. Despite these improvements in SSR, there are still some challenges we need to think about. First, even though we are streaming JavaScript code to the browser bit by bit, eventually users still end up downloading the entire code for a web page. As we keep adding features to our apps, this code keeps growing. And this leads to an important question. Do users really need to download so much data? Then there is another issue. Right now, every React component gets hydrated on the client side, whether it needs interactivity or not. This means we are using up resources and slowing down load times and time to interactivity by hydrating components that might just be static content. This leads to another question. Should all components be hydrated, even those that don't need interactivity. And here's the third challenge. Even though servers are way better at handling heavy processing, we are still making users' devices do bulk of the JavaScript work. This can really slow things down, especially on less powerful devices. And this leads to another important question. Shouldn't we be leveraging our servers more? These challenges point to something bigger. We need smarter ways to build fast applications that go beyond traditional rendering approaches. What is the solution? That is exactly what we will explore next. We've seen how React's rendering has evolved from client-side rendering to server-side rendering and then to Suspense for server-side rendering. While each step brought improvements, it also introduced new challenges. Suspense with SSR brought us closer to a seamless rendering experience, but we still struggled with large bundle sizes causing excessive downloads for users, unnecessary hydration delaying interactivity, and heavy client-side processing leading to poorer performance. To tackle these challenges, we needed more than just an incremental step. We needed a significant leap forward. That brings us to React Server Components, RSC for short. React Server Components represent a new architecture designed by the React team. This approach leverages the strengths of both server and client environments to optimize efficiency, load times, and interactivity. The architecture introduces a dual component model, differentiating between client components and server components. This distinction is based not on the components and functionality, but rather on their execution environment and the specific systems they are designed to interact with. Let's take a closer look at these two types of components, starting with client components. Client components are the familiar React components we've been using and talking about in our previous rendering techniques. They are typically rendered on the client side, but they can also be rendered to HTML once on the server, allowing users to immediately see the page's HTML content rather than a blank screen. I know it might sound confusing when I say client components can render on the server, but it is best understood as an optimization strategy. These components primarily operate on the client, but can and should also run once on the server for better performance. Client components have full access to the client environment, such as the browser, allowing them to use state, effects, and event listeners for handling interactivity. They can also access browser-exclusive APIs like geolocation or local storage, allowing you to build UI for specific use cases, just as we have done all these years before the introduction of the RSC architecture. In fact, the term client component doesn't signify anything new. It simply helps differentiate these components from the newly introduced server components. Server components, on the other hand, represent a new type of React component specifically designed to operate exclusively on the server. And unlike client components, their code stays on the server and is never downloaded to the client. This design choice offers multiple benefits to React applications. Let's take a closer look at what these benefits are. First up, smaller bundle sizes. Since server components stay on the server, all their dependencies stay there too. This is fantastic for users with slower connections or less powerful devices, since they don't need to download, parse, and execute that JavaScript. Plus, there is no hydration step, making your app load and become interactive faster. Second, you get direct access to server resources. Server components can talk directly to databases and file systems, making data fetching super efficient without any client-side processing. They use the server's power and proximity to data sources to manage compute-intensive rendering tasks. Third, security gets a boost too. Since server components run only on the server, sensitive data and logic like API keys and tokens never leave the server. Fourth, data fetching gets way smarter. Server components allow you to move data fetching to the server closer to your data source. This can improve performance by reducing time it takes to fetch data needed for rendering and the number of requests the client needs to make. Fifth, there is caching. When you render on the server, you can cache the results and reuse them for different users and requests. This means better performance and lower costs since you're not re-rendering and refetching data all the time. Sixth, initial page load and first contentful paint get a serious upgrade. By generating HTML on the server, users see your content immediately, and there is no waiting for JavaScript to download and execute. Seventh, SEO improves too. Search engine bots can easily read the server-rendered HTML, making your pages more indexable. And finally, there is streaming. Server components can split the rendering process into chunks that stream to the client as they're ready. This means users start seeing their content faster instead of waiting for the entire page to render on the server. In the React Server Components architecture, server components handle data fetching and static rendering, while client components take care of rendering the interactive elements. The beauty of this setup is that you get the best of both server and client rendering while using a single language, framework, and set of APIs. It's like getting all the benefits of traditional rendering techniques without their drawbacks. We have covered quite a bit, so let me simplify what we have learned with the key takeaways. React Server Components offer a new approach to building React apps by separating components into two types: server components and client components. Server components run exclusively on the server. They fetch data and prepare content without sending code to the browser. This makes your app faster because users download less code. However, server components can't handle any interactions. Client components, on the other hand, run in the browser and manage all the interactive parts like clicks and typing. They can also get an initial server render for faster page loads. Together, they make websites faster, more secure, and more accessible to everyone, regardless of their device or location. Now you might be thinking, okay Vishwas, this is all great information about React's rendering evolution, but how does this connect to Next.js? Well, here's the thing. The app router in Next.js is built entirely on the React Server Components architecture. All these benefits we have just discussed, they're already built into the latest version of Next.js. Understanding the evolution of React's rendering provides the foundation needed for you to grasp what we are about to explore as we dive deeper into Next.js. Well then, if you're comfortable with the React rendering strategies we have covered so far, let's proceed to understanding rendering in Next.js. Previously, we explored React Server Components and learned about its dual component model that distinguishes between server and client components. Now, let's put that knowledge into practice by creating both types of components in a Next.js application. For this second section of the course on rendering, I've created a fresh Next.js project using the command npx create next app at latest rendering-demo. Once you run this command, you'll have a similar project structure to work with. Looking at how the RSC architecture integrates with Next.js, there is a key point to remember. Every component in a Next.js application defaults to being a server component. This includes the built-in route layout and route page that come with every new Next.js project. But let's create a new component to verify this. We will add an About page to our app by creating a new folder within the app folder, About, with a page.tsx file. Here, define a simple React component. Export default function About page that returns an H1 About page. And just like that, we have created a server component. To prove this, let's add console.log about server component. In the browser, when we navigate to /about, notice how it is logged with a special server tag. You can also see the same message in the terminal. This confirms our component is a server component. Running components on the server brings several advantages: zero bundle size, direct access to server-side resources, improved security, and better SEO. However, server components do have limitations. They can't interact with the browser APIs or handle user interaction. For example, if we try to use state in our About page with the useState hook from React, so import useState from React and invoke the hook, let's call it name and set name, we will get an error because useState requires a client component environment. Currently, our About page is a server component. Server components can't maintain state because they run on the server where browser-based state management doesn't exist. This reinforces the fact that Next.js treats every component as a server component by default, unless explicitly specified otherwise. Let's leave the About page as a functioning server component by removing the useState hook and learn how to create a new client component. We will create a dashboard /page.tsx in the app folder that uses state to manage a user's name. So export default function dashboard page, we import and invoke useState, name and set name. For the JSX, we have a div tag with an h1 dashboard, an input element with value set to the name state variable, and on change, we call set name, which is our setter function. We then have a paragraph, hello, followed by the name state variable. To convert this server component into a client component, at the top of the file, we must include a directive, or to put it simply, a special instruction within the code. Use client within quotes. This directive acts as our ticket to cross the boundary from server to client side and is what allows us to define client components. It signals to Next.js that this dashboard component, along with any components it imports, is intended for client-side execution. As a result, the component gains full access to browser APIs and the ability to handle interactivity. To navigate to this route, let's add a link in our home page. So in the root page.tsx, below the image, link, the text is dashboard, href is equal to /dashboard, and make sure to import the link component at the top. Import link from next/link. If we return to the browser and navigate to /dashboard by clicking the link, we see the component with its state functioning as expected. Hello, Vishwas. Let's now look at a very important point about client components rendering behavior. Let's add console.log dashboard client component to our dashboard page component. Back in the browser, when we click the dashboard link from the home page, the log appears in the browser console, but without the server tag. If we take a look at the terminal, we don't see the message. But if we reload the dashboard page, the dashboard appears both in the browser and in the terminal. Let me explain why this happens. When we navigate using the link component, the dashboard component is only rendered client-side, and we see the message in the browser console. But if we reload the page, the dashboard component is rendered once on the server to allow the user to immediately see the page's HTML content rather than a blank screen, and then again on the client side during hydration. This is why we see the message in the browser console and the terminal. The term client component is indeed confusing, but you'll get used to this behavior as you work with RSCs. On a side note, the message in the browser is logged twice in the browser because of the strict mode during development. This doesn't happen in production, so don't worry about it. To summarize, in the RSC architecture, and by extension in the Next.js app router, components are server components by default. To create client components, add the useClient directive at the top of the file. Server components are rendered exclusively on the server, while client components are rendered once on the server and then on the client. Alright, up next, we will explore the rendering lifecycle of server and client components in Next.js. We've covered server and client components in Next.js. Now, let's dive into their rendering lifecycle. In simpler terms, we will explore how they come to life on your screen. Understanding this process is not mandatory for building Next.js apps, but it's like knowing what happens in the kitchen before your food arrives at the table. Not necessary for enjoying your meal, but definitely interesting. When we talk about React Server components, we're dealing with three key players: your browser, the client, and on the server side, we have Next.js, our framework, and React, our library. Let's break down the initial loading sequence step by step. When your browser requests a page, the Next.js app router matches the requested URL to a server component. Next.js then instructs React to render that server component. React renders the server component and any child components that are also server components, converting them into a special JSON format known as the RSC payload. If you inspect the network tab when navigating to a route, you will come across this special JSON format, which is the RSC payload. During this process, if any server component suspends, React pauses rendering of that subtree and sends a placeholder value instead. While all this is happening, React is also preparing instructions for the client components we will need later. Next.js takes both the RSC payload and the client component instructions to generate HTML on the server. This HTML streams to your browser right away giving you a quick non-interactive preview of the route. At the same time, Next.js also streams the RSC payload as React renders each piece of UI. Once this reaches the browser, Next.js processes everything that was streamed over. React uses the RSC payload and client component instructions to progressively render the UI. Once all the client components and the server components output has been loaded, the final UI state is presented to the user. Client components undergo hydration, transforming our application from a static display into an interactive experience. This is the initial loading sequence for RSCs. Now, let's take a look at the update sequence for refreshing parts of the application. The browser requests a refetch of a specific UI, such as a full route. Next.js processes the request and matches it to the requested server component. Next.js instructs React to render the component tree. React renders the components similar to what happened during initial loading. But here's where it's different. We don't generate new HTML for updates. Instead, Next.js progressively streams the response data straight back to the client. On receiving the streamed response, Next.js triggers a re-render of the route using the new content. React then carefully reconciles or merges the new rendered output with the existing components on the screen. Because we're using a special JSON format instead of HTML, React can update everything while keeping important UI states intact. Things like where you've clicked or what you've typed. This is the RSC update sequence. Alright, now that we understand the React server components rendering lifecycle, let's dive deeper into the topic. In Next.js, there are 3 different ways rendering can happen on the server: static, dynamic, and streaming. Let's take a closer look at each of these next. Earlier, I mentioned the 3 server rendering strategies in Next.js. Now, let's dive into the first one, static rendering. Static rendering is a server rendering strategy where we generate HTML pages when building our application. Think of it as preparing all your content in advance before any user visits your site. Once built, these pages can be cached by CDNs and served instantly to users. What's really cool about this approach is that the same pre-rendered page can be shared among different users, giving your app a significant performance boost. This makes static rendering perfect for things like blog posts, e-commerce product listings, documentation, and marketing pages. Now that we understand what is static rendering and when to use it, you might be wondering, how do we actually use it? Or more specifically, how do we tell Next.js to statically render a specific route? Here's the good news. You don't have to do anything special. Static rendering is the default strategy in the app router. All routes are automatically prepared at build time without any additional setup. Now you might be thinking, hold on, you keep talking about generating HTML at build time, but we haven't built our application, right? We're just running it in development mode. Now that is a great question. Let's talk about the difference between production and development servers. In production, we create one optimized build and deploy it. No on-the-fly changes after deployment. A development server, on the other hand, focuses on the developer experience, and we need something more flexible. We need to see our changes immediately in the browser without rebuilding the app every time. That is why the Next.js team made a clever decision. In production, pages are pre-rendered once during the build, but in development, pages are pre-rendered on every request. Visit the homepage, it is pre-rendered and served. Refresh, pre-rendered again and served. This ensures you always see your latest code changes in every request. Next.js also displays a static route indicator during development to help you identify which routes are static. I will say though, don't worry too much about static generation during development. What really matters is understanding how it works when you build your app for production. Before we dive into the build process, let's stop the dev server and clean up by deleting the .next folder that was generated during development. Next, let's add a link to our About page from the root page.tsx file. So duplicate the link to dashboard and change href as well as the text. In the About page, let's also render the current time. So About page within curly braces, new date, .toLocale time string. This will help prove a point later. Now, in the terminal, run the command npm run build. This creates an optimized production build of our application. The output goes into the .next folder again, But this time, the contents will be quite different from what we saw during development. There is quite a bit to unpack here, so let's start with what we see in the terminal. You'll notice 3 columns showing information about each route: route, size, and firstLoad.js. Route is pretty straightforward. It is the route itself. So /about and /dashboard, for example. Size shows how much data needs to be downloaded when navigating to that corresponding page client-side in the browser. FirstLoad.js tells us how much gets downloaded when initially loading a page from the server. Let's break down these numbers. First, there is a shared bundle that all routes use. It includes your global CSS, runtime code, framework code, vendor code, like React for example, and some route-related code. This shared bundle comes in at 105 KB. Looking at individual routes, a route page from page.tsx in the app folder is 8.4 KB. However, when someone visits the homepage, they will download both this and the shared bundle, totaling 114 KB. Next.js also generates a 404 not found page automatically. It is tiny at 979 bytes, but needs 106 KB with the shared bundle. The About page, which is a server component, is quite lightweight at 136 bytes for client-side navigation and 105 KB for server loads. The Dashboard page, which is a client component, is slightly larger at 370 bytes and 106 KB from the server. Next to each route, you will see some symbols. And at the bottom is a Next.js legend showing how each route is rendered. Our root route, page.tsx, has a hollow circle indicating static rendering. The same goes for not found, about, and dashboard as well. They all are pre-rendered at build time as static HTML. These indicators are super helpful when you're getting started with Next.js and want to understand what's happening under the hood. Now, let's dive into the build output. Next.js puts everything in the .next folder, which has all the files needed to serve our application to the browser. We will focus on 2 main folders, server and static. Inside the server folder, there is an app folder that matches our application's route structure. Let me show you the important files you'll find here. First up, we have the HTML files. See how our build info shows the root page as static? You'll find that as index.html within the app folder. Same story with our not found page, notfound.html. We've also got an about.html with its h1 HTML about page and the timestamp, and dashboard.html with its heading, input, and paragraph. You might wonder why we see HTML for client components. That is because even client components are pre-rendered as an optimization step, something we already discussed when learning about client components. But HTML files aren't the whole story. Each route also gets what is called an RSC payload. For example, about.rsc for the about server component, and dashboard.rsc for the dashboard client component. These files, with a special JSON format, are generated by React for each route and represent your virtual DOM in a super compact way using abbreviations and internal references. For our server components, this payload includes the actual rendered result, like the h1 tag with about page text in it. Client components work a bit differently. Their payload has placeholders showing where the client components should go, plus references to their JavaScript files. Our dashboard routes payload, for example, points to where its component code lives. Static chunks app dashboard page-dd9503b.js. Next to the server folder, we've got this static folder. Dig into static, chunks, app, and you'll find all our routes. The dashboard folder here has that component code file we saw referenced in the RSC payload, the stuff needed for reconciliation and hydration. The h1 tag, dashboard, input, and so on. Now that we understand the build output, let's serve our application from the .next folder. Run the command npm run start. Visit localhost 3000, and with your DevTools open, do an empty cache and hard reload. Look at the different resources that get downloaded. First thing to check is this localhost request. It is coming in as a document type. This is the index.html we saw earlier in the server app folder. Click on Preview, and you can see the preview of the HTML page. The response shows you the HTML code. Apart from the HTML, I want to draw your attention to the two RSC files. Dashboard_RSC and about_RSC. These are essential for building the UI on the client side when we navigate to /about or /dashboard using the links. There's also the dashboard component code page-dd9503b.js that has been downloaded. Here's what's cool. Clear your network tab and click around to About and Dashboard. So About component and Dashboard component. Notice how they render instantly without hitting the server. That is because the initial load included everything required for client-side navigation. So we already have everything we need right in the browser. But wait, how did Next.js know to send us the About and Dashboard stuff before we even clicked anything? That is thanks to a feature called prefetching, a clever technique that preloads routes in the background as their links become visible. For static routes like ours, Next.js automatically prefetches and caches the whole route. So when our homepage loads with the links to About and Dashboard, Next.js is already prefetching About and Dashboard routes for instant navigation. But what about the about.html and dashboard.html files we saw earlier in the server folder? Well, when you type the URL directly or hit refresh in the browser, that is when you get the full HTML document straight from the server. So when you navigate to localhost 3000/about, this time you see the about document, which is HTML. For /dashboard, with the HTML, you will also receive the code needed for hydration. Oh, and remember the timestamp we added to the About page? Notice how it stays the same no matter how many times you refresh. That is because it was locked in when we built the application. We will explore more about rendering, but here is what we've learned. Static rendering is a strategy where the HTML is generated at build time. Along with the HTML, RSC payloads for components and JavaScript chunks for client-side hydration are created. Direct route visits serve HTML files, while client-side navigation uses RSC payloads and JavaScript chunks without additional server requests. This makes static rendering excellent for performance, especially in blogs, documentation, and marketing pages. I know this is a lot to take in. If some parts feel fuzzy, I would encourage you to try this out yourself. Run the code, watch the network tab, and experiment. The best way to understand these concepts is to see them in action. My goal isn't just to show you how to use Next.js, but to help you understand why things work the way they do. Previously, we learned about the first server rendering strategy, namely static rendering. Now, let's dive into our second strategy, dynamic rendering. Dynamic rendering is a server rendering strategy where routes are rendered uniquely for each user when they make a request. It is useful when you need to show personalized data or information that is only available at request time, things like cookies or URL search parameters. News websites, personalized shopping pages, and social media feeds are some examples where dynamic rendering is beneficial. Now that we understand what is dynamic rendering and when to use it, you might be wondering, how do we actually implement it? How do we tell Next.js that we want a particular route to be dynamically rendered? Well, it is quite straightforward. Next.js automatically switches to dynamic rendering for an entire route when it detects what we call a dynamic function or dynamic API. In Next.js, these dynamic functions are cookies, headers, connection, draft mode, searchParams prop, and after, which is a new API. Using any of these automatically opts your entire route into dynamic rendering at request time. Let's write some code to understand better. Back in VS Code, let's modify our about component by importing and using the cookies dynamic function. At the top, import cookies from next/headers. Convert the component to an async function, so export default async function about page, and within the function body, const cookie store is equal to await cookies. Then const theme is equal to cookie store.get. Let's pass in the name of the cookie as theme. We will log theme to the console. Don't worry too much about what we're doing with the cookies function right now. We're just using it to trigger dynamic rendering for this About page. With this code in place, let's build our application and inspect the output from dynamic rendering. I'll first clear out the .next folder and then run npm run build in the terminal. This will take a moment to generate our new .next build folder. First, let's look at the build output in the terminal. We can see all our generated routes listed. Pay close attention to the About route. It has an F symbol next to it. If you check the legend, you will see that F indicates dynamic rendering, server rendered on demand. The next important point to remember is that dynamically rendered pages aren't generated during build time. If we inspect Next, Server, App, we will see HTML files for index, dashboard, and not found, but we won't find an HTML file for the About page. Finally, let's start our application with npm run start. In the browser, when we go to /about and empty cache and hard reload, the page renders on demand, and you will see the log statement in the terminal. Name theme, value light. This cookie was set when we were learning about the cookies function earlier. Check out the network tab, and you will see both the preview and the response containing the HTML. Each time you refresh, you will get the latest time. If you inspect the build folder, there is still no HTML file generated in the server folder. Since we're building a new page for each request, there is simply no need to store it. What I've just explained might seem trivial after understanding static generation builds. However, it is important to remember that building our application and running the built app is as close as we can get to production deployment, so I wanted to make sure you understand how it works. Here is what we've learned. Dynamic rendering is a strategy where the HTML is generated at request time. Next.js automatically enables it when it encounters dynamic functions like cookies, headers, connection, draft mode, after, or searchParams prop. Dynamic rendering is great for personalized content like social media feeds. One of the best parts about Next.js is that you don't have to stress about choosing between static and dynamic rendering. Next.js automatically selects the optimal rendering strategy for each route based on the features and APIs you're using. But if you want to force a route to be dynamically rendered, you can use export const dynamic is equal to force dynamic config at the top of your page. Now that we understand static and dynamic rendering, let's dive into generateStaticParams, a really interesting feature in Next.js. In simple terms, generateStaticParams is a function that works alongside dynamic route segments to generate static routes during build time instead of on demand at request time, giving us a nice performance boost. I know this might sound a bit complex, so let's walk through a practical example together. We will build a product listing and details page to see how this works in action. First, in our app folder, we're going to create a new products folder and add a page.tsx file with a React component for displaying featured products. Export default function products page, and we return an h1 tag that says featured products and 3 links to the 3 featured products, product 1, 2, and 3. Next, we will create an ID dynamic route, so within products, ID within square brackets, with a page.tsx file to show individual product details. Let me paste the code to save us some time. Export default async function product page, which receives route params. We await params and destructure the product ID. We return an h1 tag product ID details rendered at timestamp. When we build our application using npm run build, something interesting happens. If you look at the terminal, you will notice that Next.js handles the product list page and product details page differently. The product list page gets static rendering, while the product details page is set up for dynamic rendering. And this makes sense, right? Next.js doesn't know what ID value it will need until someone actually requests a specific URL. Take a look at the build folder, specifically within server/app, and you will find the HTML file for products.html, but you won't see anything for the product details page. If you run the app with npm run start, and visit /products/1, you will see the timestamp change every time you refresh the page. This is because the product details page is rendered on demand at request time. From our previous learning, we know that static rendering gives us better performance. Wouldn't it be great if we could tell Next.js to pre-render at least our featured products detail pages? Product 1, 2, and 3. Well, that is exactly what generateStaticParams helps us do. Let's look at how to implement it. In the product details page, we will add a generateStaticParams function, which is an async function that returns an array of objects. Each object represents a route we want to pre-render with the object key corresponding to our route's dynamic segment. We want ID with 1, 2, and 3. This function runs during build time. While we are just returning an array here, you could also fetch these IDs from an API. If we rebuild our application now with npm run build, you will see Next.js pre-rendering the product details pages for all 3 featured products, /1, /2, and /3. This is indicated by the new symbol, a filled circle. And if you check the legend, it says SSG, pre-rendered as static HTML using the generateStaticParams function. You can also confirm this by checking the build folder. So server, app, and products. You'll now find HTML files 1.html, 2.html, and 3.html corresponding to our IDs. Start the application with npm run start and navigate to /product/1. Notice how the timestamp stays the same when you refresh. This is because we are now serving a pre-rendered HTML file. Now, what about routes with multiple dynamic segments? Let's say we have a product catalog with categories and products using a route like /products/category/product/page.tsx. In this case, each object includes values for both dynamic segments needed to pre-render the route. Category electronics, smartphone, electronics laptop, books and science fiction, books and biography. generateStaticParams is perfect for scenarios like featured products or popular blog posts. generateStaticParams is a powerful feature in Next.js that lets you pre-render static routes for dynamic segments. It runs at build time, handles multiple dynamic segments, and can really boost your application's performance by ensuring that frequently accessed pages are pre-rendered and ready to serve instantly. Now, I bet you're wondering what happens to pages where the ID isn't included in generateStaticParams. Let's explore that next. Previously, we learned about the generateStaticParams function. It lets us pre-render static routes for dynamic segments by returning an array of objects where the keys match our dynamic route parameters. In our example, we are returning objects with ID values of 1, 2, and 3, which means Next.js will pre-render product detail pages for these 3 products at build time. Pretty straightforward, right? But here is an interesting question. What happens when someone tries to access a product page with an ID that is not in our generateStaticParams function list, like products with ID 4, 5, and so on? Well, Next.js has got us covered. It will still render those pages, just not in advance. Instead, it statically renders them at runtime. Let me show you what I mean. In the browser, if we navigate to /products/4, you will notice the page still works. And if we inspect our build folder, next, server, app, products, we now see 4.html. This file was generated at runtime when we visited /products/4. And since the page is statically rendered, the timestamp will not change each time we refresh the page. Let's try this again with /product/5. Notice there is no 5.html file in our build folder. Visiting /products/5 will generate a new HTML file with the current time, and you can now see that file in the build folder, 5.html. This file is served to the client. Now, Next.js actually gives us some control over this behavior through a setting called dynamicParams. By default, dynamicParams is set to true, which means Next.js will statically render pages on demand for any dynamic segments not included in generateStaticParams. But here's where it gets interesting. We can set it to false, which tells Next.js to return a 404 error for any dynamic segments not included in our pre-rendered list. Let's see this in action. I will change dynamicParams to false, stop our production build, and rebuild with the command npm run build. Start the server with npm run start. Now, if we try going to /products/4, we get a 404 page. So dynamicParams true and dynamicParams false. The value controls what happens when the dynamic segment is visited that was not generated with generateStaticParams. Now you might be wondering, when should you use each option? Well, it really depends on your use case. If you're building an e-commerce site, you will probably want to keep dynamicParams set to true. This way, you can pre-render your most popular product pages for better performance, but still allow access to all your other products. They will just be rendered on demand. On the flip side, if you're working with something like a blog where you have a smaller, more fixed number of pages, you can pre-render all of them and set dynamicParams to false. This way, if someone tries to access a blog post that doesn't exist, they will get a clean 404 error instead of waiting for a page that will never exist. So that is about dynamicParams in a nutshell. It's a simple setting that gives you powerful control over how Next.js handles those dynamic segments that are not included in generateStaticParams. Let's dive into streaming, the third and final server rendering strategy. Streaming is a strategy that allows for progressive UI rendering from the server. Work is broken down into smaller chunks and streamed to the client as soon as they're ready. This means users can see parts of the page right away without waiting for everything to load. It is particularly powerful for improving initial page load times and handling UI elements that depend on slower data fetches, which would normally hold up the entire route. This might sound familiar if you recall our Suspense SSR discussion about React's rendering. The key difference here is that we're looking at it through Next.js, where streaming comes built right into the app router. Let me show you how to set up suspense boundaries in your application. To save time, I've set up a route called product reviews that renders 3 elements, and each one saying product reviews, a product component, a reviews component. These components live in our source/components folder. For both components, I've added intentional delays, 2 seconds for the product component and 4 seconds for the reviews component. This delay mimics what it would be like if we were actually fetching data. With our dev server running, if we visit localhost 3000/product reviews, so product-reviews, you will notice the page takes a while to show anything, even just the H1 element. Check the network tab, and you will see for product reviews, the server response time is 6 seconds. That is because it is fetching everything before sending anything. Let's improve this using the streaming strategy supported in the app router. It is super simple. We just wrap our slower components with Suspense, and Next.js handles the rest. At the top, import Suspense from React, and wrap both product and reviews components with the Suspense component. On the Suspense component, specify the fallback prop. Let's go with a simple paragraph tag that says loading product details, and another loading reviews. Now watch what happens when we reload. The heading appears instantly, followed by the product details after 2 seconds, and finally the reviews after 4 seconds. While the components are loading, we will see the fallback text, loading product details and loading reviews. This is progressive HTML rendering in action, from the server to the client. And that wraps up our look at server rendering strategies in Next.js. We've got one more crucial rendering topic to cover next, so let's dive into that. Now that we've built a strong foundation understanding RSC and the dual component model, it's time to explore server and client composition patterns. I'll give you a quick overview here, and then we'll take a deeper look at specific use cases for server and client components as we continue. Let's begin with server components. These are your go-to choice for several key tasks: fetching data, accessing backend resources directly, keeping sensitive information secure on the server, and handling large dependencies server-side, which means less JavaScript for your users to download. Moving on to client components, these are your best friends when it comes to adding interactivity, handling event listeners, managing state and lifecycle effects, working with browser-specific APIs, implementing custom hooks, or using React class components. While these use cases might sound straightforward, there's actually quite a bit more to unpack about using these components effectively. Let's dive deeper into these patterns next. For our first server component pattern, let's talk about the separation of server-only code. When building Next.js applications, some code is specifically designed to run exclusively on the server. Think about modules or functions that handle environment variables, communicate directly with databases, or process sensitive information. Since JavaScript modules can be shared between server and client components, code meant for the server could accidentally find its way to the client. This is bad news, as it can bloat your JavaScript bundle, expose your secret keys, database queries, and sensitive business logic. It's super important to keep server-only code separate from client-side code. Luckily, there's a neat solution to this problem. We can use a package called server-only that throws a build time error if someone accidentally imports server code into a client component. Let me show you how this works. Let's jump into VS Code and create two components. First, we will create a server route/page.tsx with a simple React component. Export default function server route page that returns an h1 tag server route. Then we will create in the app folder once again client route/page.tsx with another React component, adding the useClient directive at the top. Export default function client route page, return an h1 element client route. Now, in the source folder, let's make a new utils folder with a new file called serverutils.ts. server-utils.ts. We'll create a function that is meant to run only on the server. The actual implementation isn't important right now. We just want to demonstrate the concept, so here is a function with a log statement and a return value. Export const server-side function, console.log, and a return statement. This function could be doing all sorts of server-side stuff, using npm packages, accessing environment variables for API keys, making database calls, or handling sensitive business logic and calculations before returning a value. The implementation is not important right now. But let's use this function in our server component. So within server route page.tsx, import server-side function from utils/serverutils, and within the function body, const result is equal to server-side function. Bind result in the h1. In the browser, when you visit localhost 3000/server-route, you'll see the log message with the server tag, and you'll see them in the terminal as well. That is because our code is running on the server. We also see server result as part of the h1 tag. Now what happens if we use this function in our client component? Copy the import statement, paste it in client route page.tsx, const result is equal to server-side function, and we bind it, result. If you navigate to /client route, you'll notice the log messages, but this time without the server tag. In the terminal for /client route, we see the log messages, but we see them again in the browser as the client component executes. This is exactly what we want to prevent. Given the nature of the operations in server-side function, it is crucial to ensure that it executes only on the server. If this code ends up in the client bundle, you're looking at potential performance issues from larger bundle sizes and heavy computations, security risks from exposed sensitive logic, and possible functional errors when server-specific code tries to run in the browser. Here is where server-only package comes to the rescue. Let's install it with npm install server-only. Once it is installed, import it to your serverutils.ts file. At the very top, import server-only. Now, if anyone tries to import this module into a client component, the build will fail immediately, preventing any potential issues related to exposing server-side code to the client. It's like having a security guard that stops server code from sneaking into the client bundle. In summary, keeping server-only code separate from client-side code isn't just good practice. It is essential for security, performance, and reliability. The server-only package helps enforce this separation, making your application more robust and secure. Alright, let's proceed to the next pattern. For our second server component pattern, let's explore working with third-party packages. Server components have introduced an exciting new paradigm in React, and the ecosystem is evolving to keep up. Third-party packages are starting to add the useClient directive to components that need client-side features, making it clear where they should run. Here's the thing though, many NPM packages haven't made this transition yet. This means, while they work fine in client components, they might break or fail completely in server components. Don't worry though, there is a straightforward solution. We can wrap the third-party components that need client-side features in our own client components. Let me show you how this works with a real example. We will use React Slick, a popular carousel component from NPM that relies on client-side features. To get started, let's install the necessary packages. In the terminal, run the command npm install react-slick, slick carousel, and @types/React Slick. Now we have an error because we are using React 19, so run the command by adding --force. Next, I'll open the playground example in npm. From here, we will grab the sample code, copy the code in imageSlider.jsx to client route page.tsx. This is a client component. Start with the imports, followed by the JSX. We can remove the CSS import line and instead copy the CSS from imageSlider.css to globals.css. Change color black to white as we are working with dark mode. In the JSX, place kitten does not work anymore, so let's use pixum.photos instead. Back in the browser, when you check localhost 3000/client route, you should see a perfectly working carousel. Now what happens if we try to use this carousel directly in a server component? Let's paste the same code into server route page.tsx. So the imports, copy, and paste into server route page.tsx, and then the JSX. Copy, and paste. In the browser, when we visit /server route, we hit a problem. Why? Well, the slider component uses client-side features, but the library itself doesn't include the useClient directive. Sure, we could add useClient to our server route, but that would mean giving up valuable server-side capabilities like database calls, access to secret environment variables, etc. To resolve this, you must encapsulate third-party components that depend on client-only features within your own client component. So in the components folder, create a new file, imageSlider.tsx. We will use the same carousel code, but add the useClient directive at the top. We'll also rename this to imageSlider as a named export. Now, our server component can be cleaned up to simply use the imageSlider component. Import it at the top and invoke it as part of the JSX. Our server-side function can be reinstated, our imageSlider component can be imported, and it can be included in the JSX. We still have a server component, but now with one element behaving as a client component. Check the browser again, and we see the component working as expected. Server route followed by server result, and we have the carousel. We see just the one image from Pixum, but if you work with local images, you will see all of them. In summary, third-party packages in the React ecosystem are in a transitional phase where numerous components from NPM packages haven't yet adopted the useClient directive. Wrapping such components in our own client components will allow us to leverage the ecosystem of third-party packages while adhering to the new server components model. All right, we have one more server component pattern to cover. Let's see what that is next. For our final server component pattern, let's explore working with context providers. If you're familiar with React, you know that context providers typically live near the root of an application to share global state and logic. For example, your application's theme. However, there is a catch with the RSC architecture. React context is not supported in server components. If you try to create a context at your application's root, you will run into an error. The solution is to create your context and render its provider inside a dedicated client component. Let me show you how this works in VS Code. We start with layout.tsx in the app folder. Here, let's set up and provide a theme context that our entire application can use. Import create context from React. Next, we define the theme type, which has colors as an object, primary of type string, secondary of type string as well. Next, we define the default theme. So default theme of type theme, colors object, define a primary color and a secondary color. Next, we define const theme context is equal to create context of type theme, and we pass in the default theme. Finally, we wrap the body tag with theme context dot provider. Value is equal to default theme, and we add the closing tag. When we save this and check our browser, we will see an error. You're importing a component that needs create context. This React hook only works in a client component. Now, we could add the useClient directive to make layout.tsx a client component, but that would tell Next.js to run this component and everything it imports on the client side. That is not what we want. Instead, let's create our context and render its provider in a separate client component. In the components folder, let's create a new file called theme-provider.tsx. Since we have seen the code already, I'll paste it here to save us some time. Let's break this down. We've got our type, default theme, and theme context creation just like before. We're now exporting a theme provider component that renders theme context.provider with our default theme value and renders any children passed to it. I have also added a convenient useTheme hook that any component can use to access the theme. But the most important part is the useClient directive at the top. Back in layout.tsx, we can now simplify our code with the theme provider. Delete create context import, and instead import the theme provider from our themeprovider.tsx file. Delete the code for type theme, the default theme, the context creation, and for the JSX, specify the theme provider component. To test this out, let's use our theme context in the client route page. So in page.tsx, which is a client component, import the useTheme hook and use it to access the theme. Const theme is equal to useTheme. And for the JSX, we will delete the carousel code and apply the primary color to an H1 element. Client route page, and we're going to specify inline styles. Color, theme.colors.primary. The component is now a very simple component. In the browser, head to /client route, and you'll see the client route page in our primary blue color. Switch it to secondary, and it turns gray. Our theme provider is working as expected. Now here is something important to make note of. Even though we are wrapping our application in a client component, which is theme provider, server components further down the tree stay as server components. We will explore this concept more deeply pretty soon, but this is the key to working with context providers and server components. Instead of converting your server component to a client component, create a new client component and use it within your server component with the children props. If you're using React version 19, you can render just context as a provider instead of context.provider. So theme context.provider can be rendered as just theme context. Head to the browser, refresh, and you will continue to see the same result. All right, up next, let's dive into client component patterns. For our first client component pattern, let's talk about the separation of client-only code. Earlier, we looked at server-only code in Next.js applications, and now we're going to flip things around and focus on client-only code. Just like how we need to keep certain operations server-side, it's equally crucial to keep some functionality strictly on the client side. Now, what exactly is client-side code? Well, it's code that works with browser-specific features like DOM manipulation, window object interactions, or local storage operations. These features aren't available on the server, so we need to make sure such code runs only on the client side to avoid server-side rendering errors. To prevent unintended server-side usage of client-side code, we can use a package called client-only. Let's dive into VS Code and understand with an example. From earlier, we have our server route, which is a server component, and client route, which is a client component. Now, let's add a client-only function. In the source folder, inside the utils folder, create a new file called clientutils.ts. We will define a function that's meant to run only on the client side. The actual implementation isn't important right now. We just want to demonstrate the concept, so here is a simple function with a log statement and a return value. Export const client-side function, console.log, use window object, use local storage, and return a client result. This function could use any browser-specific features like window or local storage, things that would not work server-side. Let's import and use this function in our client route component. At the top, import client-side function from utils/clientutils, and within the component, const result is equal to client-side function. We will render a paragraph tag for the result. When you run this in the browser, you will see the log messages pop up in the console. Use window object, use local storage. We also see the client result being rendered in the UI. There is no special server tag, and this confirms that everything is running client-side as planned. Now, let's safeguard our client-only code. Start by installing the client-only package. In your terminal, run the command npm install client-only. If you come across an error, specify --force. Once the command completes, import it at the top of the clientutils.ts file. So import client only. When we import client only in a module, it creates a safety net. If someone tries to use this code on the server side, it will fail at build time. Let's import and use this client-side function in server route page.tsx file. So copy the import statement, paste it, copy the invocation, paste it, call this client result, and render it as part of the h1 tag. Save the file, and in the terminal, you should see an error. You're importing a component that imports client only. It only works in a client component, but none of its parents are marked with use client, so they're server components by default. This error acts as a clean signal to developers about the inappropriate use of client-specific code in a server context. You will also notice the same error when you navigate to /server route. Instead of running into problems when your application is running, you will catch these issues early during development. In summary, just as server-only code needs isolation, client-only code needs to stay on the client side where it can properly use browser features. The client-only package acts as our safety net, making sure our client-side code stays right where it belongs, which makes our apps more reliable and easier to maintain. All right, let's proceed to the next client component pattern. Let's dive into our second and final client component pattern, the strategic placement of client components in your component tree. This is super important for optimizing the performance of your application. Since server components can't handle state and interactivity, we need client components to fill the gap. The key recommendation here is to position these client components lower in your component tree. Let me show you why this matters. I've prepared some code to demo this concept. In our project, I've set up a new route called landing page and also created 3 new components in the components folder: navbar, navsearch, and navlinks. Before we dive into the code, let me explain what we are building. Picture a landing page with a navbar at the top and a main content area below. We will focus on the navbar today. It consists of an outer wrapper, which is the navbar component itself, containing 2 inner components: navlinks for navigation links and navsearch with a search bar that lets users search through our site. This creates a simple component tree. The landing page component sits at the top with the nav components as its children. I have already implemented this structure in our Next.js application, so let me walk you through it. Looking at landing page component, you will notice we've imported the navbar component at the top. Inside this navbar component, we have brought in both navlinks and navsearch. These components simply output text for now: list of navlinks, navsearch input. Each component includes a console log to show when it renders. So console log navbar rendered, navlinks rendered, and navsearch rendered. Don't worry too much about the specific implementation details, as we're focusing on understanding the component hierarchy. Let's check this out in the browser by going to /landing page. Take a look at the DevTools console, and you will see log statements with the server tag because these are all server components. You can confirm this by looking at the terminal, where you'll spot the same log statements: navbar rendered, navlinks rendered, and navsearch rendered. Right now, our search bar doesn't have any state associated with it. Let's introduce a state variable to track the value of the search input. We will do this in the navbar component. Import useState from React and invoke the useState hook. Let's call it search, set search, initial value empty string. When we save this, we get an error. Our navbar component isn't marked as client component. Let's fix that by adding the useClient directive at the top. After saving and refreshing, we now see client-side log statements in the browser for all 3 components: navbar rendered, navlinks rendered, navsearch rendered, all of them without the server tag. And don't worry about seeing the logs twice. That is just React's strict mode in development. But here is a thought. If useClient is declared in the navbar component, shouldn't that be the only component running client-side? Well, this is a common misconception. When you mark a component with useClient, it doesn't just affect that component, but also affects every child component in the component tree below it. In our case, navlinks and navsearch become client components as well. Think of useClient as drawing a line in your component tree, and everything below that line runs on the client side. It is crucial to understand this concept, especially when you're working with larger component trees. If you convert a high-level component to a client component just to add some interactivity, you're accidentally making its entire subtree of children run on the client too. This means sending more code to the browser and losing the benefits of server components. That is why we want to push client components as far down the tree as possible, ideally making them leaf components. In our case, we can make this better. Instead of making the navbar a client component, we can keep it as a server component and just convert navsearch to a client component. It's the only one that actually needs state. Back in VS Code, let's move useClient to navsearch along with the state, the useState hook as well. In the browser, reload the page, and you will see only navsearch running on the client side. Navbar and navlinks have the server tag. So that is about client component placement within the app router. Let's wrap up this section on rendering by diving into the supported and unsupported patterns of interleaving server and client components in Next.js. Trust me, this is best understood through examples, so let's jump right into some code. First, create a new route called Interleaving within the app folder. Add a page.tsx file inside it. We will need a few components to demonstrate this, So in the components folder, let's create both server and client components. Let's start with our server component. Create server component 1.tsx. Let's name it server component 1. Export const server component 1, and this is a function that returns an h1 tag server component 1. Let's also include a server-only operation like a file system read in this component. At the top, import fs module, and within the component, invoke fs.readFileSync, passing in a path and UTF-8 as second argument. We are not concerned about the result of this readFile method, so we can skip the assignment. This is our first server component. Duplicate this file, so copy and paste, and name it server component 2. Update the component name as well as the read file argument. So server component 2, server component 2.tsx, and the h1 server component 2. Now for our client component, within the same components folder, create client-component-1.tsx and name it client component 1. Export const client component 1, and this is equal to a function that returns an h1 tag client component 1. Here, include a client-only operation like a useState call. So add the useClient directive at the top, import useState from React, and invoke it within the component. Const name, set name is equal to useState, and the initial value is Batman. Once again, we are not worried about using the state variable or the setter function within our component. This is our first client component. Let's duplicate this file. So copy, paste it, rename this to client component 2.tsx. Update the component name and the JSX. Now let's define a component in Interleaving page.tsx file. Export default function interleaving page, and we return an h1 tag interleaving page. Now that we have all our components ready, let's explore the different interleaving patterns. First is server component inside another server component. Now our interleaving route is already a server component, but let's make use of the other components we have just created. So at the top, import server component 1 into page.tsx, invoke it, and then within server component 1, import server component 2 and include it in the JSX. So h1 server component 1 and then server component 2. In the browser, navigate to /interleaving, and you should see the route working without any issues. Server component 2 nested inside server component 1, which is nested inside interleaving component. Our first pattern of server component inside another server component works as expected. The second pattern is client component inside another client component. So in page.tsx, within interleaving folder, import client component 1 and invoke it. Then nest client component 2 inside client component 1. So import client component 2, wrap h1 with React fragment, and invoke client component 2. Check the browser, and you can see this works perfectly fine as well. Client component 2 nested inside client component 1, nested inside interleaving page. Our second pattern of client component inside client component also works perfectly fine. The third pattern is client component inside a server component. So import server component 1 into page.tsx, and then nest client component 1 inside server component 1. Import client component 1 and invoke client component 1. Check the browser, and you can see this pattern also works without any issues. Client component 2 is currently nested inside client component 1, which is nested inside server component 1, which is nested inside interleaving page component. So the third pattern of client component inside a server component works perfectly. Finally, let's take a look at server component inside a client component. So in interleaving page.tsx, import client component 1. Then nest server component 1 inside client component 1. Import server component 1 and invoke it. When you save the file and check the browser, you will see an error. Module not found, can't resolve fs. Why? Because any component nested inside a client component automatically becomes a client component too. Since client components render after server components, you can't import a server component directly into a client component. Even though server component 1 is defined as a server component, when it is nested inside a client component, it transforms into a client component which is executed client-side. In the client environment, there is no file system module and hence the error. So it is important to remember that importing a server component into a client component is a pattern not supported in Next.js. But don't worry, there is a neat workaround. Instead of nesting the server component, pass it as a prop to the client component. A common approach is using React's children prop to create what is called a slot. So in Interleaving page.tsx, pass server component 1 as children props to client component 1. Opening and closing tag and nest server component 1. In client component 1, specify children prop of type react.reactNode, and instead of importing and invoking server component 1, we specify the children prop. Check the browser now, and everything works fine. Client component nested inside server component, which is nested inside client component. This is the recommended pattern for interleaving server and client components in Next.js. And remember, you're not limited to just the children prop. You can use any prop on the client component. That brings us to the end of our second section, which is a deep dive into rendering in Next.js. We've covered everything from CSR and SSR to suspense, RSCs, component types, rendering lifecycles, static and dynamic rendering, streaming, and these composition patterns. You should now have a solid grasp of how rendering works in the Next.js app router. There is plenty more Next.js goodness coming up, so please stay tuned for the next section. In our previous two sections, we have covered routing and rendering. Now let's dive into our third section, data fetching and mutations in Next.js. So far, we've been working with hard-coded content in our routes and components. But let's be real, in actual enterprise applications, you're usually pulling data from external sources. The app router is built on React Server Components architecture, which gives us the flexibility to fetch data using either server components or client components. However, it is usually preferable to use server components for data operations because you can directly communicate with your databases and file systems on the server side. You can get better performance since you're closer to your data sources. Your client-side bundle stays lean because the heavy lifting happens server-side, and your sensitive operations and API keys remain secure on the server. Throughout this third section, I'll show you how to handle data in both client and server components, but we will mainly focus on server components. To get us started with this section on data fetching, I've already set up a fresh Next.js project in VS Code using the command npx create next app at latest data-fetching-demo. Go ahead and run this command. You should end up with the same project I have here. Now that we are all set up, let's dive into data fetching with Next.js. Let's learn how to fetch data in the Next.js app router. First things first, we need some actual data to work with. I'm going to introduce you to JSON Placeholder, a free fake API service that gives us mock data to play around with. If you head over to jsonplaceholder.typecode.com and check out their resources section, you will find a /users endpoint. This gives us a JSON array of 10 users with different details. We're going to fetch this data and display each user's name, username, email, and phone number in our Next.js application. While Next.js really shines with data fetching in server components, which we will get to later, let's start with something you might be more familiar with, client-side data fetching. If you've done any data fetching in React before, you will feel right at home. Let's begin. In your app folder, create a new folder called users client and add a page.tsx file inside it. I chose the name users-client since we're handling user data in a client component, but feel free to name it as you see fit. The code we are about to write should look pretty familiar if you've worked with React before, so we'll move through it at a good pace. First, let's define our TypeScript type for the users. We'll keep it simple and just include the fields we care about. Type user contains ID, name, username, email, and phone number. For our component, we will call it users client. So export default function users client. We need 3 pieces of state within this component. Users to store the fetched users, loading to track if the users are being fetched, and error to store any error messages. Don't forget to import useState from React. Next, we will use useEffect to fetch our users when the component mounts. Import useEffect from React, and within the component, I'm going to paste the code for useEffect. Inside our useEffect hook, we've got an async function called fetchUsers that grabs our users' data from JSON placeholder API. This is the same URL we saw earlier, jsonplaceholder.typecode.com/users. If something goes wrong with the response, we throw an error saying failed to fetch users and update our error state with either error.message or an unknown error occurred. If everything goes smoothly, we update our user's state with the data we received. Either way, we set loading to false when we are done. We call this function fetchUsers right away inside useEffect when the component mounts. For the UI, we will handle each state appropriately. If you are still loading, we will show a loading message. If we hit an error, we will display that. And if everything works perfectly, we will map through our users and display them in a clean style list. User.name, user.username, their email, and phone number. The Tailwind classes are primarily for styling, so I wouldn't worry too much about achieving this exact layout and UI. As you can see, this is pretty much standard React code with just one RSC architecture addition. Use client directive at the top to enable the use of hooks. In the browser, if you navigate to localhost 3000/users-client, you should briefly see the loading text and then the list of users rendered nicely. We have the username, email, and phone number. We have the data for 10 different users. Here's the thing though, you should really only use client components for data fetching when you absolutely need to, like when you need real-time updates or when your data depends on client-side interactions that you can't predict on the server side. For everything else, the recommended way to fetch data is through server components, which we will cover next. Previously, we learned how to fetch data in client components. Now, let's learn how to fetch data in server components. One of the coolest things about the RSC architecture is that it supports async and await keywords in server components. This means we can write our data fetching code just like regular JavaScript using async functions coupled with the await keyword. Let me show you how this works with an example. We will once again use the /users endpoint from JSON placeholder for our mock API. We're going to fetch this user's data and display each user's name, username, email, and phone number in our Next.js server component. Let's jump into VS Code and get started. Inside your app folder, create a new folder called users-server and add a page.tsx file inside it. I chose the name users-server since we're handling user data in a server component, but feel free to name it as you see fit. First, let's define our TypeScript type for the users. We will keep it simple and just include the fields we care about. ID, name, username, email, and phone, similar to data fetching in client components. So I'm going to copy type user and paste it in the new page.tsx file. For our component, we will call it users server. So export default function users server. Make this component async since server components support async operations. Now here is where it gets really simple. To fetch our user's data, we just need to make a GET request to the user's endpoint using the fetch API. So const response is equal to await fetch, and the URL is JSON placeholder.typecode.com/users. In the next line, const users of type user array is equal to await response.json. And let's console log the value, users. When you save this and check out /users server in the browser, users-server, take a look at the console, you'll see the user list consisting of 10 users. Our data fetching is working. All there is left to do is display the users on the screen. Simply copy the return statement from the client component we previously created and paste it in the server component. Delete the console log statement. We map over the list of users where each user is defined by the user type. We render the user's name, username, email, and phone number. The classes are primarily for styling, so don't stress too much about achieving this exact layout and UI. Save the file, and you should see all 10 users being displayed. The route is /users-server. We have successfully fetched data in server components. Now here is something really cool you should know about. When building Next.js applications, you'll often end up fetching the same data in multiple places, like how request B appears across 6 different components in our tree to load a single route. You might think this would trigger multiple network requests for the same data, but React cleverly handles this through a feature called request memoization. React will deduplicate fetch requests with the same URL and options. This means you can fetch data wherever you need it in your component tree without worrying about duplicate network requests. React will only make the actual fetch once and reuse the result for subsequent calls during the same render pass. It's a React feature and thereby included in Next.js, letting you write data fetching code exactly where you need it rather than having to centralize fetches and pass data down through props. Notice how simple data fetching is with server components. Just async await with the fetch API. No use state, no use effect, none of that state management complexity we usually deal with. Speaking of state though, you might be wondering about handling loading and error states in server components. Well, that is exactly what we will explore next. Previously, we explored fetching and displaying data with server components. Now, let's tackle loading and error states. While client components require you to manage these states with separate variables and conditional rendering, server components make this process much cleaner. To implement a loading state, all we need to do is define and export a React component in loading.tsx. For error handling, we do the same in error.tsx. We covered these concepts earlier when discussing routing, but now let's see how they work specifically with data fetching. Let me jump into VS Code and show you how this works. First, let's create a new file called loading.tsx in the users-server folder. So loading.tsx. This is a Next.js convention. Here, define and export a React component. Let me paste the code here to save us some time. We have export default function, loading page, and this component creates a nice loading spinner using 2 div tags with Tailwind CSS classes. Since data fetching happens pretty quickly in our example, let's add a deliberate delay to better demo the loading state. So await new promise, which resolves after 2 seconds. If we head back to the browser and refresh the page, we will see the loading spinner appear for 2 seconds before our user data shows up. Implementing a loading state is pretty straightforward. Now for the error handling, let's create an error.tsx file in the same folder. The file name is once again a Next.js convention. Define and export a React component with suitable styling. I will once again paste the code here to save us some time. Error handling components need to be client components, so we have the useClient directive at the top. We then have export default function error page, and this component receives an error object which we are logging to the console using useEffect. In a real application, you would probably want to send this error to an error logging service. The UI simply shows a clear error message in red, error fetching users data. To test error handling, back in page.tsx within the same folder, we can simulate an error by changing the URL to something incorrect. So users 123. Save the file and go back to the browser. You will see our error message appear. Error fetching users data. We have successfully handled both the loading and error states when fetching data in server components. In summary, to manage data fetching states, add a loading.tsx file with a React component for the loading state, and an error.tsx file with a client component to handle error states. Now that we have understood the fundamentals of data fetching in server components, let's move on to explore two common patterns for data fetching. When fetching data inside components, you need to be aware of two data fetching patterns, sequential and parallel. In sequential data fetching, requests in a component tree are dependent on each other. This can lead to longer loading times, but there may be cases where this pattern is inevitable because one fetch depends on the result of the other. Let's understand better with an example. For the mock data, we will once again rely on the JSON placeholder API. This time though, we will use the /posts and /users endpoints to create a blog-like page. The /posts endpoint returns an array of 100 posts, and each post has a user ID, host ID, title, and body. The /users endpoint returns an array of users which we have already used before. If we append user ID to /users, for example, /1, we get the individual user object. In our application, we will create a posts component that fetches all posts, and then for each post, it will fetch its author using the user ID property. This is a perfect example of sequential fetching because we need the user ID from each post before we can fetch its author. Let's jump into VS Code and get started. Inside your app folder, create a new folder called Posts Sequential and add a page.tsx file inside it. First, let's define our TypeScript type for the posts. Each post has user ID, title, and body. For our component, we will call it Posts Sequential. So export default function Posts Sequential. Make this component async to support data fetching. Since we have just learned the fundamentals of data fetching in server components, I'm going to paste the entire component code here, and then we'll go through it step by step. We start by fetching all posts from the /posts endpoint, JSON placeholder typicode.com/posts, which is the URL you can find in the browser. We convert the response to JSON, and then we filter the posts to only include the ones with an ID that is divisible by 10. This is to make sure we have a different author for each post, as JSON placeholder has the same author every 10 posts. In the JSX, for each post, we display the post title, body, and a placeholder for the author name to be fetched. If we check the browser by navigating to /posts sequential, we should see 10 posts being displayed. Now, let's see how we can fetch the author for each post. Back in VS Code, create a new file called author.tsx inside the post sequentials folder. So author.tsx. Define the author type. This is the user type, but we only need the ID and name fields. So ID of type number and name of type string. Now let's define our author component. Once again, I'll paste the entire component code here, and then we'll go through it step by step. We have a function component that takes a user ID prop, makes a fetch request to JSON placeholder /users/user ID endpoint, and returns the author's name. To use this component, we need to import it into our post sequentials page component and replace the placeholder author name with the author component. Delete the paragraph tag, invoke author component, make sure to import it at the top, and then pass in user ID is equal to post.userid. If we check the browser, we should see the posts displayed with the author name, Leanne Graham, Evan Howell, and so on. This is sequential data fetching in action. First, we fetch all posts from the /posts API. Then, for each post we render, we make another fetch request to fetch its author's details. Each author request has to wait for the post request to complete because we need the user ID from the individual post. This works perfectly fine, but we can improve this by not blocking the UI while we are fetching the author details. We want to show the post first and stream the author in the background. We can do this by wrapping the author component in a suspense boundary. So wrap it with Suspense from React, which you should make sure to import from React at the top. Opening and closing, author is the children prop. And on Suspense, we specify the fallback prop, a div tag that renders loading author in gray color. In the author component, we can add 1 second delay to see the loading text in action. Await new promise, resolve after 1 second. Now, if we check the browser, reload, we should see the posts displayed with the loading author text, and after a short delay, the author name should be streamed in. Our component works as expected. If you're clear with sequential data fetching, let's move on to parallel data fetching. Now, let's look at parallel data fetching. In parallel data fetching, requests in a route are eagerly initiated and will load data at the same time. This reduces the total time it takes to load data. Let's understand better with an example. For the mock data, we will once again rely on the JSON placeholder API. This time though, we will use the /posts and /albums endpoints to create a user profile page. The posts endpoint returns an array of 100 posts. Each post has a user ID, title, and body. The albums endpoint returns an array of 100 albums. Each album has a user ID, and title. To both endpoints, we can append user ID as a query parameter to filter the posts and albums by the user. So user ID is equal to 1. You can see we have 10 posts, all written by the same user. Similarly, /albums, user ID is equal to 1. We have 10 albums written by the same user. Now, if you're building a user profile page, we might want to show both the user's posts and their albums side by side. Since these requests don't depend on each other, we can fetch them in parallel. Let's jump to VS Code and see this in action. Inside your app folder, create a new folder called user-parallel. We will pass the user ID as a route parameter, so create an ID folder inside user parallel, so square brackets, ID, and add a page.tsx file inside it. We have created a user dynamic route. First, let's define our TypeScript types. Type post, which contains user ID, title, and body, and type album, which contains user ID, and title. User ID is common across the two types, but here ID and title refer to the album ID and title. For our component, we will call it user profile. So export default async function user profile. Make this component async to support data fetching. Now here's the trick. We will define our data fetching functions outside the component. The function name is getUserPosts, and it is an async function that takes user ID as a parameter. It fetches the posts for the given ID from the JSON placeholder API and returns a response. So const res is equal to await fetch, passing in JSON placeholder /posts user ID is equal to the user ID parameter, and return res.json. The getUserAlbums function is identical but for albums. Let me duplicate the code and change the function name as well as the endpoint. GetUserAlbums /albums user ID is equal to the passed in user ID. Now let's define our page component. The component will receive the user ID as a route parameter. So we destructure params of type promise, which contains ID of type string. ID here is our folder name. We will await params and destructure user ID from it. Now we will initiate both data fetching requests in parallel using promise.all. So const posts data is equal to getUser posts passing in ID. Similarly, const albums data is equal to getUserAlbums passing in ID. We then call await promise.all. We specify an array of posts data and albums data. We assign it to posts and albums. Due to the nature of async and await, an awaited request inside the component will block any requests below it. This is why we initiated both requests before awaiting any of them. For the JSX, I will paste the entire component code to save time. It is a 2-column layout with posts on the left and albums on the right. Take a look at the browser. Navigate to user parallel/ID, which is 1, for example. And we see the 10 posts on the left and 10 albums on the right. Our data fetching is working as expected. The key to parallel data fetching is initiating the requests before awaiting any of them. Let's add a loading.tsx file and a delay to the two functions to see this in action. So 1 second delay to get user posts and 1 second delay to get user albums. Next, adjacent to page.tsx, create loading.tsx with a simple React component. I've used Tailwind CSS classes to create a loading spinner. Now, if we visit /userParallel/2, for example, both columns will load at the same time after a 1 second delay. This is much faster than waiting a second for the posts and another second for the albums. Parallel data fetching is particularly useful when you have multiple independent pieces of data that you need to fetch. Instead of fetching them one after another, you can fetch them all at once and reduce the total loading time. Alright, you should now have a solid grasp of how and when to use both sequential and parallel data fetching in your applications. Now that we have looked at how to fetch data from API endpoints using the Fetch API, let's dive into fetching data from a database in server components. Please pay extra attention to this part because what we are about to cover is super important. It's the foundation for data mutations and server actions coming up next. Now, there are two key reasons why fetching data directly from a database is powerful. First, server components have direct access to server-side resources, which makes database interactions seamless. Second, since everything happens on the server, we don't need API routes or worry about exposing sensitive information to the client. To understand how to fetch data from a database, we're going to be working with two super helpful tools, SQLite and Prisma. Now, don't worry if you've never heard of these before. I'm going to break it down super simple. SQLite is a simple file-based database to store information in your project. It doesn't require a server or a complex setup, and it is perfect for learning and prototyping. Prisma is a tool that makes it really easy to talk to your database. It's like a translator that helps your code communicate with SQLite. Let's head back to VS Code and go through the setup step by step. I highly recommend you to follow along with me. First, in the terminal, install Prisma CLI as a dev dependency. npm install prisma-d. Second, initialize Prisma with SQLite. npx prisma init --data source --provider SQLite. This creates a Prisma directory with a schema.prisma file. To simplify the setup, update the database URL in this file to file:\app.db. We will also add the database file to the gitignore file. Database prisma/app.db. Third step, in schema.prisma, add a product model with ID, title, price, and optional description. Models represent the tables in the underlying database. Product model corresponds to the products table. Finally, run a migration to create the database tables from the Prisma schema. In the terminal, run the command npx prisma migrate dev --name init. This command does three things. Creates a migration file in prisma/migrations, executes the migration against your database, installs the Prisma client package, and generates the Prisma client with which we will interact with the database. Our database and tables are ready. Now, let's define our database operations. In the source folder, create a new file called prisma-db.ts. To save time, I'll paste the code as we go, but you can find the full file on my GitHub repo, and the link to that is in the description down below. Start by importing the Prisma client package. Import Prisma client from @prisma/client. In the next line, create a new Prisma client instance. Const Prisma is equal to new Prisma client with parentheses. Next, we've got this seed products function. It checks if our table is empty, and if it is, it adds 3 sample products. Product 1, 2, 3 with prices and description. Next, we will define our CRUD operations. First, we have getProducts, which uses prisma.product.findMany to get all products. Next, we have getProduct, which uses prisma.product.findUnique to get a single product by its ID. Next, we have addProduct, which uses prisma.product.create to add a new product. We have updateProduct, which uses prisma.product.update to update an existing product. Finally, we have deleteProduct, which uses prisma.product.delete to delete a product. I've added a 1.5 second delay to each CRUD operation to simulate latency. You wouldn't have this in production. If you're new to Prisma, don't worry too much about the syntax details. All you have to know is that we have a database with a products table and functions to perform CRUD operations on that table. Alright, now for the exciting part. Let's fetch the products data in a Next.js page. In the app folder, create a new products.db folder with a page.tsx file. First, define the type of a product. Each product has ID, title, price, and optional description, similar to our model in schema.prisma file. Then, define the React component. Export default, async function, products.db page. Since server components run on the server, we can directly talk to our database without the need of an API. From prisma.db.ts, import the getProducts function. Here, I'm using a path alias which refers to the source folder. Within the React component, await the function call and store the result in a products variable. So const products of type product is equal to await getProducts. For the JSX, we are going to use the map method to bind the product information and use Tailwind classes to make it look pretty. I'm going to copy-paste the code to save us some time. So products.map, and we bind product title, description, and price. We use ID as part of the key prop on the list item. Save the file, head over to /products-db in your browser, and you should see 3 products displayed from your database. We've got a working Prisma plus SQLite database with direct access from our Next.js server component. No API layer required. And while we are using SQLite here, these same concepts apply to any database you prefer. The key takeaway is that you can query your database directly from your Next.js server component. Alright, up next, we will build on this foundation to learn about data mutations and server actions. We've covered how to fetch data using server components in the app router. Now it's time to explore something equally exciting, data mutations. When we work with data, we are typically performing what we call CRUD operations: create, read, update, and delete. We've already mastered the read part, so let's dive into the other 3, starting with how to create data. To follow along, make sure to check out the previous topic on fetching data from a database, where we set up our Prisma client with a SQLite database. We have a products table ready to use with some sample data and methods to perform CRUD operations. To really appreciate the app router's approach to data mutations, it is worth looking at how we have traditionally handled data mutations in React. This comparison will help us appreciate the benefits of the app router approach. Let's work through a practical example of creating a new product in our products table. Now, I've prepared the code ahead of time, but it should look pretty familiar if you've worked with React before. Let me walk you through how everything works. In a new folder called React Form, I've created a page.tsx file with a component called createProduct. Here, you create a form with input fields for product title, price, and description. You will need the useState hook to keep track of these field values. Then, you add an onSubmit event listener to your form that triggers a submit handler function when the form is submitted. Now, here is something important to remember about the submit handler. For security reasons, the client-side code can't directly interact with the database. That is why you or your backend team need to set up an API route to handle the create request. In our example, I'm using a Next.js API route, but you can think of this as a backend endpoint. This API route does the heavy lifting of actually interacting with our database, taking the form data and creating a new product record using the addProduct function. Meanwhile, on the front-end side, you also need to handle the submission process elegantly. This typically means implementing a loading state to disable the submit button while the submission is in progress. If the submission is successful, you will want to redirect the user to the products page to see the newly created product. In the browser, head over to /React form and you will see the form we have created. Fill it out and submit it. You will see the loading state and then be redirected to the products page. We see our newly created product in the list. As you can see, there is quite a bit going on here. We are managing form state, handling submissions, interacting with an API route, dealing with loading states, and handling redirects. But here is the good news. If you're thinking, there must be a better and simpler way to do this in Next.js, you're absolutely right. Up next, we will explore how the Next.js app router transforms this entire process, making it significantly more streamlined and efficient. Previously, we explored the traditional way of handling data mutations in React. Now, let's explore an exciting feature in the app router called server actions. Server actions are asynchronous functions that are executed on the server. They can be called in server and client components to handle form submissions and data mutations in Next.js applications. You should use server actions when you need to perform secure database operations, want to reduce API boilerplate code, need progressive enhancement for forms, and want to optimize for performance. A server action can be defined with the React useServer directive. You can place the directive at the top of an async function to mark the function as a server action, or at the top of a separate file to mark all exports of that file as server actions. Let's jump into VS Code and see how this works. For our example, we will build a form to add a new product to our database. First, let's create a new route. In the app folder, create a new folder, products, db, create, /page.tsx file. Here, we'll define and export a React component called addProductPage. So export default function, addProductPage. This is a server component. For the JSX, we will copy the form JSX from our previous example. So from React form page.tsx, copy the return statement, and then get rid of state and event handlers which don't work in server components. Remove onSubmit from the form element, onChange from the 3 input elements, disable state with loading, and we can change the text to just addProduct. Now we will define our first server action to handle the form submission. First, we create an async function called createProduct and mark it with the useServer directive at the top. Next, we connect this function to our form by assigning it to the action attribute. So action is equal to createProduct. When someone submits our form, this createProduct function automatically receives the form data as an argument. The type is form data. Then we grab the fields we need from form data and call our addProduct function from prismadb.ts file. So const title, formdata.get, title as string. Similarly, get hold of price and description. Make sure useServer is at the top. Once you have all the data, call addProduct from prismadb. Since price is numeric, call parseInt and pass in price. Because we are using a server action in a server component, we can talk directly to the database. This code never reaches the client's browser. It's like having an API endpoint built right into your component. Finally, we can add a redirect to take users back to the product lists after they've created a new item. So await addProduct, and then call redirect from next/navigation and navigate to products-db, which is the listing page. Make sure to add a / at the start, so /productsdb. Let's try this out in the browser. With the DevTools network panel open, navigate to the new route /products-db-create. Fill in the form and submit it. You will notice a network request to the server as a server action runs, and on the products list page, you should see our newly inserted product, test product 2, test description 2, price for $40. Now, I've already pointed out the benefits of server actions, but let me reiterate them now that we have seen the traditional way of handling form submissions as well as the new server actions way. First, they dramatically simplify your code as there is no need for separate API routes or client-side state management for form data. Second, they boost security by keeping sensitive operations server-side away from potential threats. Third, they improve performance because there is less JavaScript running on the client, leading to faster load times and better core web vitals. But the cherry on top is that server actions support progressive enhancement. This means your forms keep working even if JavaScript is turned off in the browser, making your apps more accessible and resilient. In the browser, navigate to products-db-create, and in DevTools, in the Sources panel, press Command-Shift-P and disable JavaScript. Now fill in product details and try submitting the form. The product still gets created. This is progressive enhancement in action. Hit Command-Shift-P again and enable JavaScript. To summarize, server actions are asynchronous functions that are executed on the server. They allow us to perform data mutations without separate API routes. We implement them using the useServer directive, and they simplify our code, improve security, and support progressive enhancement. Up next, we will take things further by handling the form submission's pending state. We will learn how to disable the submit button to give users better feedback and prevent accidental double submissions. Previously, we explored server actions for handling form submissions. Now, let's enhance our user experience by adding feedback during form submission using a React hook called useFormStatus. useFormStatus is a React hook that provides status information about the most recent form submission. When you call it, it returns a status object with 4 key properties. Pending, which is a boolean that indicates if the parent form is currently submitting. Data, an object containing the form's submission data. Method, a string either get or post showing the HTTP method being used. And action, a reference to the function that was passed to the parent form's action prop. For our purposes, we will focus on the pending property, which we will use to disable our submit button while the form is being processed. Let's head back to VS Code and implement this. Now, we could use the useFormStatus hook directly in page.tsx, but there is an important consideration. Hooks can only be used in client components. Converting our entire page to a client component would not be ideal. We would lose all the advantages of server components. So what's a smart approach here? We will extract just the submit button JSX into its own client component. This way, we can use the hook without compromising on the benefits of RSCs. Let me show you how. First, create a new folder called Components in the source directory. And inside this folder, create a new file called submit.tsx. Here, we will define our submit component. Export const submit is equal to an arrow function. First, add the useClient directive since we're using a hook. Next, we import the useFormStatus hook from React DOM. In our component, we destructure the pending property from useFormStatus. We return a button element with text submit, type is equal to submit, and some Tailwind CSS styling. Finally, we use the pending boolean to disable our button when the form is submitting. So disabled is equal to pending. We also have a style corresponding to disabled state. Now, let's use this component in our page.tsx file. So within add product page component, remove the button element and invoke the submit component. Make sure to import it from add components/submit. If you try this now in your browser, you'll see the submit component being displayed. Fill in the form and click the submit button. It becomes disabled immediately, and when the form submission completes, the button is enabled again. you will see the newly added product in the list. Now you can take this further by adding a loading spinner or changing the button text if you want to give your users more feedback. But to summarize what we've learned, with Next.js server actions, we can use the useFormStatus hook from React DOM to manage state related to active form submissions. By extracting just the submit button into a client component, we can get the best of both worlds. Server component benefits from our main component and dynamic client-side updates for our form submission state. Up next, we will explore how to handle error messages with server actions. Previously, we learned about handling loading states with useFormStatus. Now, let's dive into something equally important: managing error states in our forms. We will be using another new React hook called useActionState. useActionState is a React hook that allows us to update state based on the result of a form action. It is particularly helpful for handling form validation and error messages. Let's jump into code and see how it works. In productsdb create page.tsx file, let's start by defining our types for error handling. Type errors. We will track 3 potential errors: one for the title, one for the price, and one for the description field. They're optional of type string. The errors will be part of the overall form state, so let's define that. Type form state contains a key errors of type errors. Now, inside our component, we will set up the initial form state. So const initial state of type form state is equal to an object with errors set to an empty object. We now have the prerequisites in place for our useActionState hook. Invoke it within the component useActionState. Make sure to import it from React. So import useActionState from React. This hook takes 2 parameters. First, our server action, which is create product, and second, our initial form state, which is what we have just defined. You might see a TypeScript error for create product, but don't worry, we will fix that shortly. Next, let's update our create product server action to work with this new state. First, let's declare errors of type errors, which is an empty object to begin with. Next, if there is no title in the form data, we set errors.title is equal to title is required. Similarly, if price doesn't exist in our form data, we set errors.price, price is required. And finally, if description doesn't exist in our form data, we set errors.description is equal to description is required. It is optional in our model, but let's enforce a required field validation. Once we perform these checks, if object.keys of errors.length is greater than 0, we return the errors object. What we are doing here is validating the form data and setting appropriate error messages. If we find any errors, we return an updated form state without proceeding to the insert statement. Since the object key and value is errors, we can use the shorthand notation. This, however, should conform to our form state type. In case you're finding it difficult to keep track, within our create product server action, we're getting hold of title, price, and description from form data, and then we check if values exist for each of them. If they don't, we populate an errors object with the different keys. If even one key exists, we have an error in our form, and we return the errors object instead of inserting the data into our database. Let's now go back to our useActionState hook. This hook returns an array with 3 things. The const array is equal to useActionState. The hook returns the current form state, which we will call state, a new form action, which we will call form action, and a boolean that indicates if the action currently is being executed. Let's call it isPending. Now let's use the 3 values in our component. First, we will use the current form state to display the error messages. So below each label, we will add a paragraph that displays the error message if it exists. So curly braces, state.errors.title, and if this exists, add a paragraph tag rendering state.errors.title. We'll also add tailwind styling to display the message in red. I'm going to copy these 3 lines of code and paste it under price as well as description labels. For price, update state.errors.price, and for description, state.errors.description. We will also group the form field and the error message in a div tag. So div tag wrapping label as well as error message, div tag wrapping label and error message, and the final one. This is purely for grouping related elements and adding space between the different fields. State is now taken care of. Next, we will bind the form action to our form's action attribute. So instead of create product, we specify form action. We will use the isPending boolean to conditionally disable the submit button when the action is being executed. Now this is completely optional as we are already handling the pending state with useFormStatus in the submit component. But I will show you how to do it anyway. I will comment out the submit button component, copy the button element from the submit component, and paste it in place. To the disabled attribute, we will pass isPending boolean returned by the useActionState hook. Ultimately, what we have done here is instead of directly calling the server action, create product, we pass it through the useActionState hook that manages state updates based on the form action. Now, when we save the file and head back to the browser, we will run into an error. Can you guess why? Well, we're using a React hook in a server component, useActionState. Now, your first instinct might be to add useClient at the top of our file. Let's do that. useClient. When I save the file, you can see that gives us a different error because it is not allowed to define inline useServer annotated server actions in client components. In simpler terms, we can't use the useServer directive in a component marked with the useClient directive. So what is the solution? That is what we will explore next. Previously, we hit a bit of a roadblock when we tried to define a server action in a client component. Next.js wouldn't allow it. But don't worry, I've got a neat solution for you. The trick is to separate our server action into its own file, keeping our server-side logic cleanly separated from our client-side components. Let me show you how to do this. First, create a new folder called Actions in your source folder. Inside this folder, create a file called products.ts. We're using this name because we are working with products, but feel free to name it whatever makes sense for your project. Now, let us set up our product.ts file. Here's the thing about useServer directive. You can place a directive at the top of an async function to mark the function as a server action, or at the top of a separate file to mark all exports of that file as server actions. So we start this file with the useServer directive at the top. Next, we will move our types, errors, and form state into this file and export them. Then we will bring over our create product server action but we will remove the useServer directive from inside the function as it's not needed here anymore. Let's make sure we import product and redirect functions. At the top, import add product from PrismaDB and import redirect from Next Navigation. Make sure to also export create product. Now let's update our page.tsx file. We will delete the imports for add product and redirect. We will import form state and create product from our new products.ts file in the actions folder. We will still use useActionState with our create product function. Now, if you save the file and try this out in the browser, we have an error that says, did you mean use server? So let's make sure we don't have any extra spaces. Navigate to productsdb-create, and without filling the form fields, click on the submit button. We have formData.get as not a function. Now this is because when we use useActionState and pass in create product, the function automatically receives the previous state as the first argument. So previous state of type formState. Now, when you submit with empty fields, you'll see the error messages. Title, price, and description, all of them are required. When you fill everything in correctly and submit, your new product will show up in the list. And there you have it. We have successfully implemented form validation using useActionState with a separately defined form action. This approach gives us the best of both worlds. We get to use client-side React hooks for managing our form state while leveraging the power of server actions for data mutations. For our next topic, I want to take a quick detour to talk about pending, returned from useFormStatus, and isPending, returned from useActionState. Let's take a look at the pending state from useFormStatus and isPending from useActionState. Both booleans can help us determine if a form is being submitted and let us disable the submit button. But there's an interesting difference between them that is worth understanding. The pending state from useFormStatus is specifically for form submissions. On the other hand, isPending from useActionState can be used with any action, not just form submissions. Now, in our example here, you could actually use either one and get the job done. Pending from useFormStatus in its own submit component, or a regular button element with isPending from useActionState. But here is how I think about choosing between them. Go with pending from useFormStatus when you're building reusable components that are meant to live inside forms. For example, submit buttons or loading spinners that you'll want to use across different forms in your application. Choose isPending from useActionState when you need to keep track of server actions that aren't necessarily related to form submissions. It gives you that extra flexibility. I should mention that the official docs on React as well as Next.js are a bit light on this topic. If you've got more real-world examples of when you would use one over the other, I would love to hear about them in the comment section below. Alright, now that you've seen how to create a new product with server actions, next, let's take a look at how to update an existing product using server actions. Let's dive into implementing an update operation for our products and learn how to pass additional arguments to a server action. In VS Code, we will begin by creating a route to edit product details. Under app/productsdb, create a new dynamic route. Within square brackets, id/page.tsx. Go ahead and copy the code from productsdb create page.tsx and paste it in this new route. Rename the component to edit product page. In the browser, navigate to productsdb/1 and we see our form to update product details. Now, we need to fetch the existing product data corresponding to ID 1 to populate this form. For that, we will extract the route parameter ID and fetch the corresponding product from the database. So destructure params, which is of type promise, object, ID of type string. Within the component, destructure ID from params. So const ID is equal to await params. And then we will use the getProduct method from PrismaDB, which returns a single product given its ID. Const product is equal to await getProduct, and we pass in parseInt ID. Now here is where we encounter our first challenge. We cannot use the await keyword as client components can't be async components. If I add the async keyword, you can see the warning. And we can't remove useClient either, since we're using React hooks in the component. This is actually a common issue you'll come across in Next.js. To solve this, we will split our logic. In the same ID folder, create a new file, product-edit-form.tsx. Copy all the code from page.tsx, but leave out the data fetching part. So remove getProduct, await params, and the props. Let's call this edit product form component. Then in page.tsx, we will focus only on the data fetching part. So remove the useClient directive at the top, useActionState from React, the invocation of useActionState, and for the JSX, we return our newly created edit product form component. We can also remove form state and create product, as well as initial state from the component. We can add async, as we don't have any hooks anymore. Pass product as a prop to the form component. So what we are doing here is extracting the route params, getting hold of the ID, getting the product corresponding to the ID, and passing the details of that product as props to edit product form. In the edit product form client component, specify the prop product. And for the type, we're going to go to our products listing page in products-db, export type product, and import it here. And make sure to use @app/productsdb. Now use the product details as default values for all the form fields. So for title, default value is equal to product.title. Similarly, for price, default value is equal to product.price. And for description, default value is equal to product description. Since description could be null, we use the nullish coalescing operator to provide an empty string as the default value. So double question mark, empty string. If we go back to our edit product page, we still have a TypeScript error. First, let's import the product type. I'm going to copy this line, paste it here, and specify the type of the product variable. Now getProduct could return null if the product is not found, so we need to also handle that case. If the product is not found, we call the notFound function from next/navigation. Make sure to import it at the top. TypeScript is now happy. Back in products.db listing page, wrap the product title with a link component to enable navigation to the edit page. So link component, which we import from next/link, wrap the product title, specify href is equal to backticks/products-db/id. And that is $curly braces product.id. In the browser, clicking a product title, so product 1, takes us to the edit page pre-populated with product details. Product 1, price 500, description 1. Our UI setup is now complete. Let's move on to implementing the update server action for form submission. In products.ts, within the actions folder, duplicate the create product server action and name it edit product. In product edit form.tsx, we will import edit product server action instead of create product and pass it in as the argument to useActionState. Also, back in edit product server action, we'll modify it to call update product from prismadb.ts, which updates the product in the database. But we now face another interesting challenge. Update product needs the product ID, which means we need the product ID in our edit product server action. Since product ID is not a form field, we can't access it from form data like our other fields. Now we could use a hidden input field. So input type is equal to hidden, name is equal to ID, value is equal to product.id. But this would expose the ID in the HTML without proper encoding. Instead, let's use JavaScript's bind method to pass additional arguments. In the edit product form component, we can bind the ID to the edit product server action. So const edit product with ID is equal to edit product dot bind null comma product ID, and then pass this function into useActionState. The bound argument ID will now be available as the first argument in the edit product server action. So ID of type number, comma, previous state of type form state, form data of type form data. Pass this ID as the first argument to update product function. ID, comma, title, price, and description. Back in the browser, update the product details. So updated description 1. Click on submit. And the changes will be immediately reflected in the products listing page. Our update server action is now complete. I understand that was a lot to take in, so let me summarize what we did. We created a dynamic route for updating individual products. We used route params to fetch product details from our database. We found out that client components can't be async components. To solve the async issue, we split data fetching into a server component and form logic into a client component. From the server component, we passed product details as a prop to the client component. In the client component, we bound product details as default values to our form fields. In our actions product.ts file, we created a new server action to handle product updates. The database function, though, required the product ID, which was not available in the form data. We used the bind method to pass the ID argument without exposing it in the HTML. We retrieved the ID as the first argument in our server action and passed it to the database function. We got our product update functionality working smoothly. Up next, we will tackle the final piece of our CRUD operations, the delete functionality. Let's dive into implementing delete functionality using server actions. We will start by adding a delete button for each product in our list. So in productsDB page.tsx, after product.price, I'm going to add a delete button. Button type is equal to submit with a red background for styling and the text delete. Next, let's define our delete server action. In actions/products.ts, we will add a remove product function. So export async function remove product. Import the delete product function from prismadb.ts, which handles deleting a product by its ID. Remove product server action takes an ID parameter of type number and passes it straight to the delete product function. Very straightforward. Now, back in our products page, we need to call this server action. But here's the question, how do we do that? If we use the onClick handler on the delete button, it would make it client-side code. We, however, want the component to remain a server component. Well, the solution is to wrap our button with a form element. So form opening tag and closing tag. On the form element, we will specify the action attribute to call the remove product server action. So action is equal to remove product. Make sure to import it at the top. Import remove product from actions/products. Now remove product needs the ID parameter. So we will also bind product.id using the bind method. So null, product.id. This makes the product ID available as the first argument to remove product, just like we did earlier with our update product server action. This same ID is passed to delete product. Let's save everything and try it out. In the /productsdb route, we see our newly added delete button against each product. When we click delete on the last product, so validation title 1, we see the network request, but nothing seems to happen in the UI. If you refresh the page, you will notice that the last product is gone. So what's missing? Well, we need to refresh this product list automatically after deletion. To fix this, we can use a function called revalidatePath. Make sure to import revalidatePath from next/cache. As an argument, specify /productsdb, which is the path of our products listing page. We are telling Next.js to refetch data for /products-db path after deletion. Make sure to add the await keyword. Now, when we delete a product, submit product 1, we see the network request, and it disappears from the list without needing a manual refresh. You will still notice this 1.5 second delay we built in though. In a real application, this would typically be shorter. Still, any delay isn't ideal for user experience. So up next, we will look at how to make this feel smoother using optimistic updates. For the final topic related to CRUD operations, let's take a look at performing optimistic updates with the useOptimistic hook. useOptimistic is a React hook that provides a way to optimistically update the UI while an asynchronous action is underway. This technique helps make our apps feel more responsive, especially when working with forms. Instead of making users wait for server responses, we can show them the expected result right away. Let me show you how this works with some code. For our example, when the user clicks on a delete button, instead of the 1.5-second delay to show the deletion, we will remove that product right away from the list. To achieve that, first we import useOptimistic hook from React in our productsDB page.tsx file. Import useOptimistic from React. Invoke it within the component after the data has been fetched. useOptimistic. Now the hook takes two parameters. The first parameter is the initial state that you want to optimistically update. This is our list of products fetched from the database. The second parameter is a function that determines how to update the state optimistically. This function takes two arguments, the current state, which we will call current products, and an additional argument to help create the new state. For our scenario, the additional argument is the product ID, which corresponds to the product we want to delete. The function filters the current products array to exclude the product with the given ID. So current products.filter product such that product.id is not equal to product ID. This is just simple JavaScript, nothing specific to React or Next.js. It is important that we return this updated list as our optimistic state. Now, what does this useOptimistic hook return? Two things. First is the resulting optimistic state, which we will call optimistic products. This is the array we will show to the user. Second is a function to trigger the optimistic update. The function takes one argument of any type and will call the update function that we have defined as the second argument to useOptimistic. So how do we make use of these two values? First, instead of iterating over the list of products from the database, we will iterate over the list of optimistic products, which is managed by the useOptimistic hook. Second, we create an async function, remove product by ID, that takes a product ID of type number and handles our delete server action. So await, remove product, passing in product ID. Before calling the server action though, we trigger our optimistic update. So set optimistic products, passing in product ID. This immediately shows the user their changes while the actual deletion happens in the background. Now, on the form element, to the action attribute, we invoke the new function, remove product by ID, binding the product ID. So .bind null, product.id. This value is the product ID that the function receives. That was a lot to take in, so let's go over the flow of the useOptimistic hook one more time. We invoke the hook with the current state and a function returning the optimistic state. The optimistic state is available as the first return value, which we use to render the list of products. We use the second return value, the setter function, to call the update function and execute a logic to return the new state. This setter function runs right before the server action. Users always see the optimistic state while the actual operation completes in the background. If we save the file, we will see an error because we are using a hook in a server component. The solution? We will need to separate our data fetching from our data mutation logic, similar to what we did with our update operation earlier. So alongside your page.tsx, create a new file, product-detail.tsx. Copy the entire code from page.tsx and paste it into this new file. Rename the component to product detail. Product detail becomes a client component handling the mutations and optimistic updates. Add the useClient directive at the top, remove async keyword, and also the data fetching code. It will receive data from the parent server component instead. So we specify products of type product. I will also make this a named export. Perfect. The page.tsx file will now be a server component in charge of only data fetching. Let's delete the unwanted code. useOptimistic, remove product, and the link component can be deleted. Instead, import the newly created product detail component. So import product detail from /product detail. For the component, we will still fetch our products from the database and then return the same component, passing in the list of products as a prop. Save both the files and try it out in the browser. I want you to observe what happens when we click the delete button. So test product 1, delete, and the product disappears instantly while the actual deletion completes in the background after 1.5 seconds. But your users get that smooth, responsive experience they love. So delete, it's removed right away, and the delete operation completes in the background. That wraps up our look at CRUD operations with server components and server actions in the app router. For our final topic in this section on data fetching and mutations, let's take a look at the newly introduced form component in Next.js. The form component is built on top of the HTML form element, and it comes with some powerful features that make it perfect for modern web applications. It automatically prefetches loading UI, it handles client-side navigation on form submission, and it provides progressive enhancement out of the box. Let me show you how the component works with an example. In our application, currently we have a home page and a products-db page where we display a list of products. In the home page, we will add a product search feature that will redirect to the products.db page to show the list of products filtered by the search query. Let's jump into VS Code and see how to achieve that. First, let's set up our loading state. In the products.db folder, create a loading.tsx file. Define a simple React component. Export default function loading that returns a div tag loading products. Next, we will define a search component. Create a new file called search.tsx in the components folder. Export a React component called search. This component will render a form with a search input and a submit button. I will paste the code to save time. So export const search, return an HTML form element with action is equal to /products-db with some styling. And then we have one input element, name is equal to query with CSS styling and placeholder search products. We also have a button element of type submit, tailwind CSS styling, and the text submit. A very straightforward form with input and button elements. We will, however, make use of the new form component instead of the form HTML element. So import form from next/form and invoke the form component. Now that we have our search component ready, let's add it to our home page. The root page.tsx file in the app folder will be the entry point for our search functionality. Import the search component from @components/search, and right after the main HTML element and before the image component, invoke search. If you check the browser, you will see that the search input and submit button are rendered. If you type a search query and hit submit, you will be navigated to the /products-db page, and the loading state will briefly appear before the products are rendered. The list of products, however, is not filtered. For our search to work, we need to update our data fetching logic based on the search query. So back in VS Code, in prisma.db.ts, let's modify the getProducts function to handle search queries. Accept query, which is optional, of type string. And then, if query exists, we're going to return prisma.product.findMany, and we're going to specify a condition where or title contains query, description contains query. In other words, if a query parameter exists, find all products whose title contains that search query or description contains the search query. If the query doesn't exist, return the full list of products. Finally, we need to update our products.db page.tsx to handle the search parameter. So the page component now has props and we destructure searchParams of type promise object. It's going to contain query, which is optional and of type string. Within the function body, we destructure query from searchParams and pass query as an argument to get products. Back in the browser, when you type product3 in the search input and hit submit, you will be navigated to the /productsdb page, and the products will be filtered based on the search query. We just see the one product that contains product3 in the title or the description. Now, this might not seem anything special, but Next.js is actually doing a ton of work behind the scenes. First, when the form component becomes visible, it prefetches the loading UI associated with /productsdb route. This is the value of the action prop. Second, when a user submits the search, it instantly navigates to the products page client side, and the form data gets turned into URL params. For example, $query is equal to product3. Third, it will show the loading state while the search results are being fetched. We see our loading div tag while the products are being fetched in the background. Finally, once the data is ready, the results are displayed in the UI. A lot of functionality is happening here. Now, the form component also supports progressive enhancement out of the box. This means that even without JavaScript, the form will still work as a regular HTML form. The form component gives us a really smooth user experience with minimal effort on our part. It handles all the complex parts of form submission, navigation, and loading states, letting us focus on building features rather than dealing with messy code like prevent default, manual state management, or any of that old school form handling stuff. And you should know that the form component also supports server actions. In our product details component, we have a form that allows us to delete a product. Let's replace the HTML form element with the form component. So import form from next/form and replace the HTML element with the form component. Head back to the browser and delete a product. It continues to work as expected. To summarize, the form component is a new component in Next.js that extends the HTML form element and provides a lot of powerful features like prefetching loading UI, client-side navigation on form submission, and progressive enhancement out of the box. With that, we complete this third section on data fetching and mutations. We learned how to fetch data in client components, how to fetch data in server components with async await, handle loading and error states with loading.tsx and error.tsx, and about fetching data directly from a database. We also learned about server actions for data mutations, validation and pending state feedback with useFormStatus and useActionState hooks, separating server actions for use in client components, how to pass additional data to perform update and delete operations, how to perform optimistic updates, and finally, how to handle forms with the new form component. You should now have a solid understanding of fetching data and handling forms in Next.js. For the next section of our Next.js course, let's tackle another crucial aspect of web applications, which is authentication. If you think about it, most apps revolve around users. When building for users, we need to consider three fundamental concepts: identity, sessions, and access. Identity is about verifying who someone is through authentication. Sessions keep track of a user's logged-in state across requests, and access controls what they can do. In developer terms, we call these authentication, session management, and authorization. Now, Next.js handles this a bit differently than traditional React apps. With React single-page applications, you're only dealing with client-side code. But Next.js, you've got to protect your application from three different angles: client-side code, server-side code, and API routes. When implementing authentication, you will typically want to let users sign up, give them a way to sign in, enable them to manage their account, show or hide UI elements based on whether they're logged in, protect certain routes depending on authentication status, access session and user data when needed, set up role-based access control, and finally, provide a way to sign out. Here's the thing, building all of this from scratch would take forever. That's why even Next.js themselves recommend using an authentication library. The docs explicitly state, while you can implement a custom auth solution, for increased security and simplicity, we recommend using an authentication library. This brings us to Clerk. Clerk is this really cool authentication and user management service that works beautifully with Next.js. The best part, it is free for up to 10,000 monthly active users, which is perfect for our course and most projects you will build. I've actually used Clerk in a few of my side projects, and I can tell you it's the most straightforward authentication solution I've found for Next.js. Stick around and you'll see why. To get us started with this section on authentication, I've already set up a fresh Next.js project in VS Code using the command npx create next app at latest authentication-demo. Go ahead and run this command. You should end up with a similar project to what I have here. Now we can begin our journey to building a secure Next.js application. Let's get started by setting up a Clerk account. I recommend following along with me to quickly set up your account in parallel. Go to Clerk's homepage, the link is in the description, and click on Get Started. Create an account using your preferred method. I'm going to enter an email and password. Click on Continue. Enter the verification code. Once logged in, create a new application in Clerk. Enter the name of the application as Next.js application. Select the sign-in options that you want to support, and you can see a preview of the UI on the right-hand side. We will have email password and Google authentication. I will also add GitHub. You can see the same updated in the preview. To proceed, click on the Create Application button. This brings us to the Setup Instructions page. Choose Next.js as the framework if it's not already selected. Now, let's follow these steps together to add Clerk to our project. Step 1. Install the Clerk package. Copy the command from the Setup Instructions page and run it in your terminal. npm install at clerk/Next.js. Step 2. Set your environment variables. In your project, create a .env.local file in the root of your project and add your Clerk API keys. Copy the publishable key and secret key from the Setup Instructions page and add them to the .env.local file. Make sure to use your own keys and not mine. Step 3. Create a middleware.ts file in the source folder. In VS Code, in the source folder, create a middleware.ts file. Copy the code from the Setup Instructions page and paste it here. This will help us access auth data and configure protected routes later. And I just realized this should not be inside app, but inside source folder. Step 4. Wrap your entire application with the Clerk provider component, which is a React component that provides Clerk's context to your application. We will do this a little differently to what the setup instructions show. In the root layout file, layout.tsx, import Clerk provider component at the top from @clerk/Next.js and wrap the JSX with it. Clerk provider, opening tag, and closing tag. This now gives us access to Clerk's hooks and components. With the setup now complete, we can start writing code to implement our goals. All right, now that we have Clerk set up, let's add sign-in and sign-out functionality to our application. The great thing about Clerk is that it provides pre-built components that handle all the authentication flows for us. Let's start with the sign-in functionality. Begin by creating a folder in the source folder called components. Inside this folder, create a file called navigation.tsx. Here, define and export a React component called navigation. I want a decent looking navigation bar with a logo and a sign-in button. So to save time, I'll paste the component code, which you can find on my GitHub repo. Export const navigation. We have the nav HTML element, plenty of Tailwind CSS classes, an h1 tag Next.js app, which is supposed to be our logo, and a placeholder for where the sign-in button should go. Include this component in your layout.tsx file so it's rendered on every page. Right before children, invoke navigation and make sure to import it from @/components/navigation. Check the browser, and you should see the navigation bar with the logo, Next.js app. Now let's add the sign-in button. In navigation.tsx, import the sign-in button component from Clerk. Import sign-in button from @clerk/Next.js. Render the component within the div tag where you see the placeholder component. Sign-in button. On this component, set a prop mode is equal to modal. This means clicking the button will open a nice modal dialog instead of redirecting to a separate page. Check the browser, and you will see a sign-in button in your nav bar. Go ahead and click it. You will see Clerk's beautiful sign-in modal with all the authentication options we configured earlier. Since we don't have an account yet, I'm going to click on the Sign Up button at the bottom of the modal. This presents us with the UI to create your account. Let's create an account with email and password. Click Continue and enter the verification code. Once verified, we will be redirected back to the home page. We are now signed in. Let's proceed to add the sign out functionality. For signing out, Clerk provides a component called Sign Out button. Let's import and add that right next to our sign in button. Check the browser, and you will see a sign out button in your nav bar. Go ahead and click it. You will be signed out from the application. Clerk automatically handles everything, clearing the session, removing tokens, and updating the UI if needed. But right now, there is no UI change to indicate that we are signed in or signed out. Let's work on that next. We have the sign in button and sign out button components for signing in and out. But for signing out, Clerk provides an even nicer component called user button. Let's import it, comment out sign out button, and add it to the JSX instead. User button. In the browser, try signing in, and you will see it appear. When you click, it opens a drop-down menu with two options. We have Sign Out, which performs the same function as our Sign Out button component. But the second is Manage Account, which opens a full profile management interface in the modal dialog. Here, you can update your profile picture, update your email address, update your password, delete your account, and much more depending on your configuration in the Clerk dashboard. But what if you prefer having a separate profile settings page and not a modal? Well, no problem. Clerk provides a user profile component that we can embed in an optional catch-all route. I'm going to comment out the sign out button import to make sure we don't have a red squiggly error. Now, for the separate profile page, in the app folder, create a new folder called user profile. User-profile. Here, add an optional catch-all route called user profile. So double square brackets, ... user-profile. Within this folder, create a page.tsx file. Define and export a React component called userProfilePage. Export default function, userProfilePage. At the top, import the userProfile component from Clerk and render it as part of the JSX. So return a div tag to add some styling to the page, and then we invoke our userProfile component with a path prop set to /user-profile. Now, in the navigation component, add a link to the user profile page, so link, which needs to be imported from next/link. The text is going to be profile. href is going to be equal to /user-profile, the same path we have specified here. Uncomment sign out button and comment user button instead. The same for the import statement. Check the browser, and you should see the profile link in the nav bar. Clicking on it should take you to the profile page with path /user-profile, and clicking on security will take you to /user-profile/security page. Clicking on sign out should sign you out and redirect to the home page. As you can see, Clerk makes it super easy to add profile management to your application. Next, let's take a look at how to conditionally render different parts of our UI based on the user's authentication state. Previously, we added sign in, sign out, and profile management functionality to our Next.js application. Everything works great, but there is still a small issue. Our sign-in button and profile link are both visible when we are already signed in, and the sign-out button is visible when we are already signed out. Let's fix that by learning how to conditionally render UI elements based on the user's authentication state. Clerk once again makes this super easy with two special components, signed in and signed out. Let's import them and use them to update our navigation component. So signed in and signed out components from @clerk/Next.js. In the JSX, wrap the sign in button with the signed out component. And the profile link plus the sign out button with a signed in component. Now, the sign in button only shows up when the user is signed out, and the link and sign out button only appear when the user is signed in. Pretty neat, right? Clerk handles all the state management for us. Check the browser, and you should see the sign in button only when you're signed out. And when you sign in, the profile link and sign out button should appear. The sign in button is now hidden. Simple and straightforward. Now that we understand how to conditionally render UI elements, let's take it a step further and learn how to protect entire pages from unauthenticated users. If you're signed out, try navigate to localhost 3000/user-profile. You will encounter a Clerk runtime error. User profile cannot render unless a user is signed in. What we need to do is protect this route so that only authenticated users can access it. The most robust way to protect routes in Next.js is through Clerk's middleware. As part of the setup, you've already created a middleware.ts file in the source folder. This is where you can configure Clerk's middleware. Begin by importing a function called createRouteMatcher from Clerk. Next, create a matcher for the routes that you want to protect. Invoke the function and pass an array of routes that need to be protected. In this case, we want to protect /user-profile route. Let's store the return value in a constant called isProtectedRoute. Finally, pass a function to Clerk middleware. The function receives the auth object and the request object as arguments. In the function body, we check if the request matches any of the protected routes. If isProtectedRoute, passing in request, and if it does, we call the protect method on the auth object. So auth.protect. We will need to await this and add the async keyword. Make sure to get your parentheses right as well. Protect method will redirect the user to the sign-in page automatically if they're not signed in. In the browser, if we try to navigate to /user-profile again while being signed out, we will be redirected to the sign-in page that is hosted by Clerk. Sign in with your credentials, and you will be redirected back to /user-profile. We have successfully protected the user profile route. Now in the middleware, you can also invert the protection logic. Instead of isProtectedRoute, create isPublicRoute. Our public routes are the root route, sign-in route, and sign-up route. In the Clerk middleware, if not isPublicRoute, passing in request, await auth.protect. So the middleware will now protect all routes by default, and you specify which routes should be public. This is useful when most of your application requires authentication. In the browser, if we try to navigate to /user-profile, while signed out, we will still be redirected to the sign-in page that is hosted by Clerk. Sign in and you can access /user-profile. Now, if you want even more control over what your application does based on user authentication status, you can use the auth argument in the middleware. Await auth to get the user ID and the redirect to sign in function. If the user is not signed in, so if not user ID, and the route is not public, so not isPublicRoute, request, you can redirect to the sign in page. Return, redirect to sign in. Make sure to destructure user ID. The same logic as before, but now you can add custom logic to run before redirecting. This could include logging unauthorized access attempts for security monitoring, routing users to region-specific sign-in pages, or handle maintenance windows for specific routes, whatever might be relevant for your application. Protecting routes is a crucial part of building secure and personalized web applications. With Clerk's middleware, the process is simple and flexible. When building web applications, we often need to access user and session data to personalize experiences and track user actions with their account. To read user and session data, Clerk provides two helpers, auth and current user. Let's understand how to use them with an example. For this example, we will create a new route called dashboard. Within the app directory, create a dashboard folder and add a page.tsx file. Export a default function, dashboard page, that returns a heading. Within the page, import and invoke the auth and current user helpers and inspect the returned objects in a console. So first, import the auth and current user methods from Clerk/Next.js/server. Then invoke them in the dashboard page component, so auth and current user, and await the returned objects. The auth helper will return the auth object of the currently active user. So const auth object is equal to await auth. The current user helper will return the backend user object of the currently active user. So const user object is equal to await current user. Log both the objects to the console. Object, comma, user object. In the browser, once we are signed in, if we navigate to /dashboard, we should see the auth and user objects logged in the console. If you inspect the auth object, you will see user ID, session claims, redirect to sign in, and so on. The user object contains email addresses, first name, the user ID, image URL, last name, etc. In server components and route handlers, you will typically use the user ID from the auth object and query the database with it. Now, these two helpers, auth and current user, are useful in server components and route handlers, but don't work in client components. In a client component, you can read the same data using useAuth and useUser hooks. Let me show you how. In the components folder, create a new file called counter.tsx. Define and export a simple counter component. Export const counter. We invoke useState with a value of 0. We render the count value, and on click, we call setCount, incrementing the count value by 1. A very straightforward counter component. Add useClient directive at the top to make it a client component. A very straightforward client counter component. Let's import and invoke this component in the root page.tsx file below the image component. So counter, make sure to import it from @/components/counter. Then back in the counter component, import the useAuth and useUser hooks from Clerk. From @Clerk/Next.js. In the component, invoke useAuth and destructure the returned object. To access the properties, isLoaded, user ID, session ID, and getToken. Also invoke useUser and destructure the returned object. To access the properties, isLoaded, isSignedIn, and user. They do have conflicting properties, so let's use them one at a time. From useAuth, you can use the isLoaded and user ID properties to return null in case the user signs out while the component is mounted. So if not isLoaded or not user ID, return null. Save the file, head back to the browser and click sign out. And you can see the component is removed from the UI. Similarly, from useUser, you can use the isLoaded and isSignedIn properties to return null in case the user signs out while the component is mounted. Either of these conditions work. In the browser, sign in again, and we can see the counter component, sign out, and our app continues to function as expected. The component has been removed. You can rely on useAuth if you just need the user ID to personalize experiences or associate data with the user. Use useUser only if you need the full user object. Speaking of users, up next, we will learn how to work with roles and permissions. Now that we have covered authentication and session management, let's move on to something really important for your web applications: user roles and permissions. Most apps need more than just checking if someone is logged in or not. They need different permission levels for different users. So let's learn how to implement role-based access control using Clerk. First things first, we need to configure Clerk to make user roles available in our session token. Clerk gives us something called user metadata, which is like a storage space for extra user information. In our case, we will use it to store user roles. We will specifically use something called public metadata because it is read-only in the browser, making it super secure for storing sensitive information like user roles. To build a basic RBAC system, we need to make sure this public metadata is readily available in the session token. By doing this, we can quickly check user roles without having to make extra network requests every time we need this information. This makes our application much more efficient. Here's what you need to do. Head over to the Clerk dashboard and under the Configure tab, find the Sessions page. Under Customize Session Token, click Edit. In the modal that opens, add JSON with the following key and value: metadata within double curly braces, user.public_metadata. Scroll down and click the Save button. For the second step, we will need to create a global TypeScript definition to work with roles. Back in VS Code, in your application's root folder, create a types directory. Inside this folder, create a globals.d.ts file. Here, start by exporting an empty object. This makes the file a module. Next, we define what roles are available in our application. Imagine a social media app where moderators can moderate content and admins can manage moderators. So export type roles is equal to admin or moderator. These are the two roles for our application. Next, extend Clerk's session token type globally. Declare global curly braces interface custom JWT session claims. We specify metadata role optional of type roles. This will provide autocompletion and prevent TypeScript errors when working with roles throughout our application. For the third step, we will manually add the admin role to our own user. In the Clerk dashboard, navigate to the Users tab. Select your own user account, which should be the only user in the list. Scroll down to the user metadata section and next to the public option, click Edit. Update the JSON with the key role and value admin. Click Save. For the fourth step, we will define and protect a new admin route. In the app directory, create a new admin folder with a page.tsx file. Here, export default function admin returns an h1 tag admin only page. Now to view this page, you not only have to be signed in, but also have the admin role. So to protect this route, we will apply role-based access control in our middleware.ts file. First, use createRouteMatcher to create a matcher for the admin route. So const isAdminRoute is equal to createRouteMatcher, and the path is /admin. Next, add a check for the user's role in the middleware function. If isAdminRoute of request and await auth dot session claims dot metadata dot role is not equal to admin, const URL is equal to new URL, path is /, and the second argument is request.url. We return next response dot redirect and pass in URL. Make sure to import next response from next/server. In the browser, make sure you're signed in and navigate to the admin route /admin. You should be able to access it. Now, back in the Clerk dashboard, change the role to moderator and click Save. Try to access the admin route again So /admin, and you will be redirected to the home page. Our RBAC system is working as expected. Of course, manually adding roles to users is not scalable. In a real-world application, an admin will want to be able to manage user roles. So for the fifth step, we will create server actions to manage user roles. In the admin folder, create a new actions.ts file. Start with the use server directive. Next, we will define a function to set a role for a user. Export async function set role, and the function receives the form data of type form data. Within the function, we first need to check that the user calling this action is an admin. We can do this by checking the session claims.metadata.role on the auth object. At the top, import auth from clerk/Next.js/server, and within the function, extract the session claims. Const session claims is equal to await auth. If the user role is not an admin, if session claims metadata role is not equal to admin, we will return a not authorized error. So throw new error, not authorized. If the user is an admin, we will get the Clerk client to update the user's role. So import Clerk client from clerk/Next.js/server and invoke it within the component. Const client is equal to await Clerk client. Now this server action expects a form submission with two types of info. So const ID is equal to form data dot get ID as string, and role is equal to form data dot get role as roles. Make sure to import it from types/globals. ID here refers to the user we are updating, and role refers to what role we are giving the user, either admin or moderator. Next, within a try block, use the Clerk client to update the user's role. So await client.users.update user. We pass in ID as the first argument. And for the second argument, it's an object where we specify public metadata. This is an object where we set role equal to the passed in role. If there is an error, throw new error, failed to set role. Let's make sure the syntax is right. Similarly, we'll define a function to remove a role from a user. I'll paste the code here, but let me walk you through the code. So export async function remove role, which receives form data. Once again, start by checking that the user calling this action is an admin. Then get the Clerk client and extract the ID from the form data. Finally, within a try block, use the Clerk client to update the user's role to null. If there is an error, throw new error, failed to remove role. In both the functions, if the update operation is successful, we will call revalidate path and revalidate/admin. This will automatically update the admin UI without us having to refresh the page when we update a role. Alright, with these two server actions, we can now manage user roles in our application. For the final step, we will flesh out the admin page to let admins manage user roles from the user interface. Now, this is a pretty verbose React component, but you already know the fundamentals of how to write React components. I'm going to paste the code to save us some time. It's about 78 lines of code, but let me walk you through what I've pasted. We still have export default function admin. We get hold of Clerk client and call users.getUserList.data to fetch the list of users from Clerk. We then map over that users list in the UI. There's some Tailwind CSS styling for alternate rows. We render user.firstname and user.lastname, the primary email address, the role of the user, and then against each user, we have make admin and make moderator buttons, which include hidden inputs for user ID and role. These buttons use the setRole server action to update the role for the given user ID. We also have a remove role button that calls the remove role server action, passing in the user ID. Let's go back to the browser, change our user role back to admin, and navigate to the admin route. So /admin. I'll close the DevTools for some extra space. I'm also going to register with a new user behind the scenes in a different browser. Alright, I've registered with a new user in Firefox. But this user will not have the admin role, so they won't be able to access the admin dashboard. Navigate to /admin, and you will be redirected to the home page. In the first browser, refresh the page, and you will see the new user. Using this admin account, update the role of the new user to admin. So click on Make Admin. We can see the role is now admin. With the user logged in Firefox, try to access the admin dashboard again, /admin. We are able to view the admin component. Our custom RBAC system is working as expected. Now, to make RBAC more streamlined in larger applications, Clerk also provides a built-in organizations feature with a roles and permission system. You can learn more about it in the documentation. But if you're building a small application, our custom RBAC system should be good enough. With that, we have successfully implemented all our authentication goals. Next, let's take a look at some of the customization options available when using Clerk's components. Now that we have an end-to-end example of authentication with Clerk, let me walk you through customizing the sign-up and sign-in flows. Currently, our navbar has a sign-in button that triggers a modal when clicked. This modal lets users sign in, and if they don't have an account, they can easily switch to sign up using the link at the bottom. However, many applications prefer to have a dedicated sign-up button that initiates the sign-up flow directly. You can easily achieve this by importing the sign-up button component from Clerk. In navigation.tsx, import sign-up button from Clerk and add it right below sign-in button. Mode is equal to modal. In the browser, you will see a sign-up button appear in the navbar. Clicking it launches the sign-up modal, and users can switch to sign in using the link at the bottom if needed. Very straightforward. Next, let's talk about styling. When working with Clerk, you're not stuck with the default button styles. You can completely customize how your sign-in and sign-up buttons look. It is as simple as nesting a button element with your own CSS inside the sign-in button and sign-up button components. Change from self-closing to opening and closing tags. In between the tags, include an HTML button element. This is sign-in, and this is sign-up. Let's add some Tailwind CSS to both buttons. Take a look at the browser, and you will see both buttons have been customized. Now, what about having dedicated pages for sign-in and sign-up instead of modals? That is also very easy. In navigation.tsx, on the sign-in button and sign-up button, remove the mode is equal to modal prop. Back in the browser, click on Sign In, and Clerk will redirect you to the dedicated sign-in page. Similarly, click the Sign Up button, and you will land on the Sign Up page. Now, if you check the URL, you might notice we don't see our app's domain. That is because these pages are hosted by Clerk. If you would prefer to keep users on your domain, you can create your own sign-in and sign-up pages while still using Clerk's components. Here's how to do it. In your app directory, create a sign-up folder with an optional catch-all route. So, new folder, within double square brackets, ... sign-up is the name, and add a page.tsx file with a simple React component. Export default function, sign-up page, and we return a div tag that renders the sign-up component from Clerk. Make sure to import it from @clerk/Next.js. I will also add some styling to the div tag: flex, justify center, item center, and some padding. Do the same for sign-in by creating a new sign-in folder with an optional catch-all route, so double square brackets, ... sign in, and add a page.tsx file. Copy paste the component code for sign up page.tsx and change sign up to sign in. Sign in is another component that Clerk provides. When you add these two pages, ensure both routes are public in your middleware.ts file. We already have it from the time we learned about middleware. If you don't, please make sure to add these two routes. Finally, update your .env.local file with two new environment variables: next public clerk sign-in URL and next public clerk sign-up URL. They point to /sign-in and /sign-up, which are the two routes that we have just created. Make sure to restart your dev server, so npm run dev, and head back to the browser. Now, when users click either button, so sign in or sign up, they will stay on your domain at /signup or /signin. Lastly, let's talk about redirects after authentication. By default, Clerk is pretty smart. It remembers where users came from using a redirect URL query parameter. Try it out. Let's create a simple about page in the app folder. Export default function about return h1 tag about page and navigate to localhost 3000/about. Since every page is a protected page by default, we are redirected to /signin. You'll notice how redirect URL is equal to http localhost/about. When you continue, you're redirected to /about. While this default behavior works well in most cases, you can customize it using environment variables. You have two options for fallback URLs. Next public clerk sign-up fallback redirect URL and next public clerk sign-in fallback redirect URL. The first one is to set the fallback redirect URL after sign-up in case the redirect URL query parameter is missing. The second one is to set the fallback redirect URL after sign-in in case redirect URL query parameter is missing. If you don't care about the redirect URL query parameter and you want to force specific redirects regardless of where users came from, you can make use of next public clerk signup force redirect URL and next public clerk sign-in force redirect URL. With these force redirects, users will always land on /onboarding after sign-up and /dashboard after sign-in. Currently, we haven't created the onboarding route, so make sure to create it if you want to test this out. But as you can see, Clerk offers plenty of flexibility in customizing your authentication flows. Next up, we will look at deploying our application. All right, for the final topic in this course, let's see how to deploy a Next.js application. For this demo, I will be using GitHub and Vercel. Vercel is a platform by the Next.js team that lets you seamlessly deploy Next.js applications. Step 1, ensure your code is pushed to GitHub. As you can see, I already have a repo created, which is the same repo I've used for the entire series, Next.js 15 tutorials. We have a couple of applications in here, and we will deploy the authentication demo app we have recently worked on. Step 2, head over to vercel.com and sign up if you're new to Vercel. I am going to log in with GitHub. Once you're logged in, add a new project. If you're doing this for the first time, you will need to install Vercel when prompted. I'm going to select my GitHub account, which is already linked. Our code is in the Next.js 15 tutorials repo, which I'm going to import. For Vercel team, I'm going to select my personal account and choose the framework preset as Next.js. For the root directory, we're going to click on Edit and select Authentication Demo. Continue. We can leave the build and output settings as they are, but expand the environment variable section to enter the key value pairs from your project. Our project has 4 environment variables: select all, copy, and paste. Vercel automatically creates the 4 environment variables with the values. Finally, click on Deploy. This will take a minute to build and deploy your application. Once the process completes, we should have a preview of the application. Clicking on it will take us to our application hosted on a Vercel URL, Next.js 15 tutorials.vercel.app. Sign in with the test account credentials, and our application works as expected. Now, if you have a custom domain, you can of course point this app to that domain. But as far as a simple build and deploy with GitHub and Vercel is concerned, this is all you have to do. Very, very straightforward. Well, with that, we come to the end of this course on Next.js. I hope you have a much better understanding of the concepts now than you did before starting. If you enjoyed the course and found it helpful, please click the like button and subscribe to the channel as it helps out a lot. Share this course with your friends or teammates, and hopefully they start using this amazing framework as well. As always, thank you for watching, and until next time, take care. Supporting the channel is free. Please like and subscribe. It helps a lot.